since 2006, the 3.0 days. I've been primarily a sysadmin for most of my life, very limited programming background. And again, I'm a solution architect now selling VMware Cloud and AWS. Why would you want to modernize your skills? Obsolescence, right? We've all worked with floppies, at least those of us who've been around as long as I have in the industry. And I have spent many, many hours of my life staring at this Norton Ghost screen, cloning drives for servers and desktops. But those skills aren't in demand today, right? That doesn't help. So you have to modernize your skills. You have to keep with the times to keep yourself relevant and employable. So since 2006, I was doing all system administration. It was all system administration all the time. Virtual machines, your classic 3-tier apps, and started off doing physicals, and then virtualization came in, which really virtualization was the same work as a physical, but it was just an easier way to do it, right? Virtualization came with the ability to clone VMs. You couldn't do that easily with a physical, except with Ghost, but it was a lot faster in the virtual world. Kind of the same job. And my programming skill really was all scripts, so I went and looked at one of my old directories preparing for this presentation and found that I had amassed 440 Power CLI scripts, all of maybe 10 or 20 lines each. And that's what I would do. I'd go out to the internet and I would find a script that did something close to what I wanted and hack around and get the Power CLI to do what I want, with just little chunks and snippets of Power CLI code to do what I wanted. So we'll talk about 2013, VMware launched NSX, and just like when you were doing virtualization instead of physicals, this was networking. It's the same networking that we already knew. It was just a slightly different way to do it. And now we're in 2020, and we have all of these developer words. There's Kubernetes and Docker and microservices and containers, and what makes it difficult for people who come out of a system administration background is we're not learning how to do things in a different way like we were with virtualization, like we were with NSX. It's a whole new profession, and that's why it's so tough, and that's why it's so hard to get started. If you take a look, this is from CNCF, the Cloud Native Landscape. Like, this is a lot to understand when this isn't really your profession, when you're coming into this not really knowing even the basics. It's really overwhelming. So the question is where to start. So I started, and I'm proposing to you that maybe you can start too, with the VMware Event Broker appliance. I am not good at learning things just to learn them. I need a project. And the VBA project is event-driven automation for vSphere. It's an open source project. It uses Kubernetes, which I don't really know, but I'm gaining skill in it. But I'm learning Kubernetes in the context of something that I do understand really well, which is Virtual Center. So if you look at vCenter automation today, when anything happens in Virtual Center, you have an HA event or a data store gets full. You have the same 3 alarm actions that you've had since like the beginning of time. You can send an email, you can send a trap, or you can run a command. It hasn't really changed since vSphere like 3, right? And it's limiting. You can just do those 3 things. And what VBA does is it actually reads vCenter events and can react to them. And you can write code in arbitrary programming languages. And there's a whole set of functions that are built in to do different things. A lot more than just send an email, right? Run a script, send an SNMP trap. For example, out of the box, one of the functions built into VBA is maintenance mode alarms. So how many times have you went to update a host, pop it into maintenance mode, go to reboot it, and you get a bunch of emails saying the host is down? Well, of course the host is down, you rebooted it. So this maintenance mode alarm function, when you put a host into maintenance mode, it disables alarm actions. And when you pop hosts out of maintenance mode, it enables alarm actions. So just a very simple reaction to an event that happens in Virtual Center, but it makes your life easier. This other one out of the box that was contributed by the community This is an HA event notification. So when there's an HA event, your host goes down and virtual machines are booted on a different host. You get an email that tells you, hey, this is when the virtual machines were restarted. Here's a list, and here's a date. So it's just a couple examples of functions that are there out of the box. It can do a lot more, but those are examples of what's there. So how did I get into this in the first place? Well, I needed to send notifications out of VMware Cloud and AWS, and because of security permissions and the way VMC operates, it's not possible to get into that section of vCenter. And one of the product managers told me, hey, there's this new VBA open source project that might be able to help. So I'm like, okay, I'll take a look at it. And first it was, hey, download an OVA, which, okay, I can do that. I've done that a lot of times. And then I'm reading what to do. And step one is clone the repo. Like, what does that mean? I don't know Git. I don't know any of this stuff. And then it's talking about stack.yml. I didn't even know what YML was. I now know it's called YAML. And then there's JSON. I'd heard of JSON, but I'd never used it. So it's using foreign terminology. I didn't really know what to do. So I thought, okay, I'll look at this YAML file. So it's just a config file. So this isn't too confusing, just a text config. And then I read, oh, you need Docker to be able to deploy this. And I thought, okay, I'm just going to log on to this VBA appliance and I'll look around and see what I can find. Well, all I found was a bunch of stuff called containerd and Cube. And I'm thinking, where's Apache? Where's Nginx? Where's like MySQL? Where's the stuff that I know and understand? Well, it's not there because it's containerized. And so I sent back to product management. I'm like, yeah, Viva's a developer's tool. I can't use this. And the next day, William Lamb, who I'm sure you all know from all of his community work, he's like, yeah, it's actually targeted at virtual infrastructure admins. And William spent about an hour and convinced me, this really is in your skill set and you should give it a shot. So I said, okay, I'm going to give it a shot and I'm going to blog about it because I learn better when I go into it with the intent of not only learning it, but I'm going to teach it to somebody. So I started off and I deployed the appliance and I blogged about it. And it brought me into this open source world where all of these really hardcore developers are working on this product, and then there's me. So you want to talk about feeling like an imposter out of the gate? Take a look at this. So this is a screenshot of various people on the project. This is their GitHub. And every time you see green, that's a day that they contributed code. And the darker the green, the more code they contributed on that particular day. So, 374, 258, 413 contributions in the last year. And there's me, right? Nothing. But what I wasn't prepared for is just how helpful they were. Every single person on this list has helped me. They all want the project to be successful. People who contribute to open source projects, they want them to be successful. They want to help. They've helped me in Slack. They've helped other customers in the public Slack channel that we have for this project. And it really is a lot more welcoming than I think some of the initial fears that I had are, right? And I think a lot of people are nervous. And when you start to learn just a little tiny bit, using the right tools, don't list off the process, use kubectl commands. And I started to learn, okay, containers run code, pods are a group of containers, and they're organized into namespaces. And suddenly things start to make a little bit more sense. And pods have logs, so I can actually tail a log file the way that I'm used to doing on a Linux system. That all works. So really, 2 days after I started kicking around with this stuff, I found a typo channel. So I fixed it. And I committed a change back to the just one character typo, but I was able to do it. So then I did some more, and you can see, well, I've amassed, not too bad for a non-programmer. I've contributed 34 times in the last year, and I've been able to put code into an open source repository. And the blog series grew. So I blogged on how to deploy code, and I blogged on how to get a function into the VBA, and I wrote about how I got my laptop ready to deploy code, and a bunch of stuff on Git commands. And over time, over the past 8 or 9 hours CLI. And then I did a little more documentation. So I've kind of jumped around and jumped. Maybe the biggest thing that I did right here is it's a checkbox. It's just a simple checkbox, and it auto starts SSH on an OVA deployment screen and actually have that impact the installation. And if you really look at what's behind the checkbox, it's not that much, and it's something that most of us who've spent any time in Linux will understand, right? Right at the top, it's just a little bit of shell scripting. And in the middle, it's just reading a property. Now, do I know off the top of my head exactly what all those commands do? Not really. I did the exact same thing that I taught them to. It's just a copy and paste of properties that were already there, and it's just simple markup. So if I've inspired you, maybe I've piqued your interest, go ahead and get out there and start helping it and learn a little bit about how to.
Be wary of more sophisticated actors, and thinking back to the headlines I showed you, those were sophisticated actors in those situations. And we'll talk more about their techniques, but they're in it for the money. We can't stop there. So insiders, nobody likes to think about their employees being bad actors, but it happens. People get angry. They might be bribed, extorted. We've seen that with attacks recently. Some high-profile companies where insiders were involved. So our protections have to go beyond just the basic criminals and include insiders. Then as we move over to the left, particularly with hacktivists and with cyber weapons, the purpose for those bad actors is to destroy. So they may encrypt data just like a ransomware attack, but there's nobody to pay. So if you're not prepared with the ability to recover data and you get hit by a hacktivist or a cyber weapon, you can't count on the ability to pay a ransom and get your data back. There's simply nobody on the other side. So working across all of these threat actors, very important as you think about your strategy in the cyber resilience space. Here's one of the techniques that is getting to be better known, but really important to understand when you're making your plans here. And that's the idea of using a backup in a cyber recovery strategy. So you think about normal attacks, the slide I just showed to you, the bad actors are getting into the network, and ultimately their goal is to encrypt your production data, databases, servers, sometimes file shares, just the important stuff that's in production. And so if you have a backup, you might be able to recover from that attack. Well, the bad guys know that too. And so more frequently, they've been targeting the backup infrastructure as part of their attack. They're very resourceful. They have a lot of tools. What we frequently see is deployment of things like a tool called Mimikatz to pull in passwords. We're seeing more frequently the bad actors breaking into password vaults, and then they get all the passwords for all the infrastructure. So when they roll out their attack and they encrypt the production data, they're deleting, encrypting, or otherwise destroying the backup data. So you can't count on having that data unless you take extra measures. Another thing we see for some organizations is to simply put an extra copy of data, maybe an extra backup, in the cloud. And really the public cloud, if I'm being more specific. And that's an interesting strategy to have an extra copy of data, but it's not protected. It's just an authentication away. And we've seen some of these bad actors get into the infrastructure and watch what the administrative people are doing on a daily basis. So they're uncovering those extra copies. And since it's just an authentication away, they can log in and delete or destroy that data. We've also seen them leverage cloud data for their own recovery. So they might get access to that content and then they just do a recovery to their servers and now they have all of your data. It's not a ransomware attack anymore, but it can certainly be just as painful. Similarly, a disaster recovery or DR strategy is a little different from a cyber resilience strategy. So think about DR, the idea is if we have an operational or physical disaster, we've replicated data to another site so that we can fail over to that site and continue operations without too much disruption. The good data, bad data, that bad data, as they ever were, they just meet a different purpose than a recovery or a cyber resilience strategy. At the same time, we want to be able to leverage those investments that our customers have made in their DR and backup strategies as stepping stone into their cyber resilience strategy. So that's where we focus with our PowerProtect cyber recovery solution. This is an area where we've been involved for 5 years. We've really been the leaders in cyber resilience. We've helped to set the market, set the capabilities that are out there. We have the most sophisticated solution and the most sophisticated practice. We also have the most customers, and that's important because we've got a lot of hands-on and operational experience. Another thing we've done in this space, and I'll touch on a little bit later, is work with the best practice groups that are out there, like the Sheltered Harbor Initiative, and we're the only ones involved with that process, which again, important from a standpoint of maturity and capabilities and sophistication. So what do we do? What is cyber resilience? What is cyber recovery for us? Now, I like to say we could spend a couple hours on this, and I have on this particular diagram, but I'll just give you kind of a basic overview. Of course, we're all happy to talk with people in more detail about it at any time. So on the left, what we have is our traditional data center, very simplistically depicted production environment and the backup environment. Note, we don't have DR here, but people may have a second or third site. The other thing that we've done is we've color-coded some of the data. So when we talk about cyber recovery and cyber resilience, we're really focusing on protecting the most important data. That might be 20% or 30% of the overall footprint, just depending on the organization. We can certainly protect all 100%, but normally it's a focus on that most significant part. And so we've color-coded that here between the blue and green data on the left. So organizations are already making a backup. We're not going to impact that, but we do want to leverage it. And how do we do that? So our cyber recovery vault, our data vault, is on the right side. It has a couple of important characteristics. So one, it's physically separate. We like to have it in a locked room or locked cage, but it's not another data site. It's at your production site, it's at your DR site. It might be with a managed service provider or even a cloud provider. Location doesn't matter. It's just that physical access that helps us protect against bad actors. And it's logically separated. So you can see in the middle, we've got this air gap, and we call it an automated operational air gap because it's not always off. We enable it sometimes so that we can update the data that's in our vault. So normal status are components in our vault. They run the vault from that side. We have storage, compute, and other components there. They're not accessible if you're in the production environment. They have private IP addresses. We don't share switches, firewalls, data diodes, our Unisys stealth capability. All those things can come into play to further secure the vault. What happens, though, is we want to take that most critical data, so the green boxes, if you will, on the left, and on a regular basis, we want to update the content that's in the vault. So we will enable that vault, essentially unlock it in a very careful manner so that it's limited what can happen. And we'll go through these steps. Sync, we take the data from the production side that has changed from the last time we've done this process, and we sync it over into the vault. Then we lock the vault back down. We make a copy of the data, and organizations will keep that data from a couple weeks to a couple months, depending on their vault requirements. Then we'll lock the data. So we'll apply a retention lock to it, which helps to protect further against an insider or a failure of any type. It can't be deleted before the retention period expires. And then we'll analyze that data on a full content basis. And we'll talk about that a little bit more. But essentially what we're doing is we're looking at that data to make sure that it's valid, that if there was an attack, we could use it for a recovery. Out of all of this, we can get monitoring and reporting. It's automated. You don't need somebody sitting in the vault. It runs by itself and sends out information about the vault to your SOC or NOC or other monitoring groups. And of course, the whole point of this is if there is destruction or encryption in the data center, you use the data that's in the vault to securely recover back to your production environment or another environment that you've chosen for your recovery process. So that's really the basics of our solution here. There's a lot of detail in there, but that's our overview of everything. One of the most important things that we've done is that we've built the solution out and we've productized it. And what I'm showing you here is the graphical interface for the system that runs in the vault. So if I can skip back for just a second, you can see the vault side. This is what runs in the vault, and the vault is controlled and operated from the vault side. That's really important because we make the assumption that a bad actor who's in the data center might have access to everything. Think about when I mentioned before about the insider. That insider may have access to everything, knows all about the vault, knows when it syncs up, how everything works, and yet we're still going to be secure from that type of a threat actor. And part of that is running everything automated and operating it from the vault side. The other great things about having a product is it's tested frequently. We have a help desk. There's a roadmap. We make improvements all of the time. And so you don't want to go out in this space and get a custom one-off solution that may not be secure and may lose its security over time as changes are made. Having this productized is really important. Also, as you make changes into your vault, you might change what's brought into the vault. You might decide that certain data sets aren't critical anymore, or they've moved. And being able to use this GUI, especially on the right side here with things like policies, to update that is all very easy and straightforward. And then you can see here too, the recovery tab. We've automated a lot of the recovery processes. So if there is an attack, you know what to do, and you can do it at least partially on an automated basis to speed your recovery and make it as efficient as possible. A couple things that we've learned about cyber recovery and resilience that are important to a solution that's going to be effective. And again, tying this back to the whole spectrum of threat actors and the tools and capabilities that they have. So we think about this on a couple of different levels. You can see on the slide here, good, better, best. And of course, you want to get further up as you assess the risks and the importance of your data in your environment. So good capabilities are things like making the data immutable. Some people will call that WORM, write once, read many. There's a standard out there called 17A4F that people use to kind of take the place of WORM. But essentially what we're doing is we're making that data harder for a bad actor to delete. So if they get into our backup environment, our infrastructure, we've locked the data. And note that I did say harder or more difficult to delete. Data that's locked really isn't immutable. There are ways to attack the data. There are clock attacks. There are insider attacks. So it's a good control that you want to add to a solution, but it's not a solution in and of itself. Then as we move into better, how do we improve our positioning there? Well, one thing is let's protect from insiders. So having those capabilities to separate the systems that an insider can't even get access if they know where everything is, putting physical controls on rooms and locks, separating duties so that different people can do different things. Those are all components of a solution that are important too. But as we get into best, this is really where we separate from everybody. And the key there is having that air gap, that operational air gap that separates the system from any bad actors that don't actually have physical access. And that's almost every case. So doing that alone is a huge step up from the good and better. I mentioned Sheltered Harbor before. There's not a lot of standards in this area. So when you look to how do we benchmark our capabilities or our solution, Sheltered Harbor is a financial services initiative that looks at a lot of these things and has some recommendations on it. We're the only group that's working with them in their technology solution provider program, in their alliance program. So that's a really great data point. And then the last piece is analytics. How do we know that what we put into the vault is good data? And then can we use that data when we recover? You think about some of these attacks, you don't know that an attack is, for example, a NotPetya attack, which happened a few years ago, until later. All you know is that your systems have gone down, your data's locked up. Having analytics for your vault data can tell you immediately what data is good and what data is bad. So you might be able to use some of the data that didn't get impacted. You might know that some of your data from today is bad. And think back to my sync, copy, lock, analyze process. You may have a copy of an application, for example, from the day prior that's good, and you can reuse that versus having to go back and set things back up. So all that information leverages into the process of enabling your recovery to be more efficient and more effective. This is kind of my specialty area. I know puts some people to sleep, but what's happening in the regulatory environment, what's happening in the legal environment, and we're tracking along with those things. And in fact, in many cases, we're helping to drive those. So in the US, we tend to have more industry-specific requirements, and healthcare and financial services really lead the way. They're talking about, you can see from the FFIEC, an air-gapped data architecture. Our FBI, which is a group that we get to spend time with here, is talking about backups and ensuring they're not connected to networks that they're backing up. So you think about those backups being attacked from my earlier slide, that's really what they're referencing there. Outside of the states, the protections tend to be more broadly structured. So they're not going to be sectoral in an industry, but things like the GDPR, which protects personal data, actually has some cybersecurity requirements to it. And just fascinating to me, again, GDPR has been out for a few years, that they mention what I talked about before, confidentiality, integrity, and availability of the data, not just the confidentiality, which is the theft, but if you're going to have that data, you've got a responsibility to make sure that you can use it and that it's secure and available. So this is the path that we're working down. And when you think about how these all coalesce, it's an air-gapped copy of data that's protected in the data vault. That's the best way to meet these requirements as they become more structured, more strict, and more important in the coming years. So when you look at the competitive differentiators, and this is similar to the slide that I showed you before, I think it's important to understand what else is out there and where it may fall short. So in many cases, what we see from others in this space is just taking a backup and hardening that backup. And as I said before, things like immutability, which you can see across the top row here, it's important, it's useful, but it's not a solution. It's just an extra control that's going to make that data a little bit harder for a bad actor to reach. We're operating across all of these different capabilities, and they're all very important. So as you look at other solutions, really understand what they do, what they don't do, and where the gaps are going to be. They're going to protect typically against the, I mentioned before, garden variety bad actor, and not against insiders, not against more sophisticated threat actors, and not against things that are cyber warfare like NotPetya that we saw a few years ago. So be very careful and be very informed on all these capabilities and determining what's necessary for you to really keep a safe copy of data. I talked a little bit about the analytics and want to talk a little bit more. So how do you know that data in the vault is good? And that's what we do with our CyberSense capability. So think about the sync, copy, lock, analyze. We're bringing data in to the vault. We don't care if it's good or bad data. It's not going to run in the vault. So if there's malware in our backup that we're bringing into the vault, or there's dormant malware, it doesn't run. It can't impact our vault because we're keeping it in this backup format. But we want to know, is the data good? So what we do with our analytics is we take that data once it's in and locked into the vault, and we scan it. We don't have to restore it. We can read through the backup format, and then we're going to make some observations, some statistics on all this data. We're going to go at a critical data. So as we work across industries, every industry has different focus areas. You can see a few here. I spend a good amount of time in the financial services area, so banks and credit unions looking at core banking. Some are looking at trading platforms. In the legal community, document management is really important. All data is going to be important at certain levels, but what we're really looking to protect in the vault are those critical data sets that without you really do not have a business. You can't operate at all. So get those into the vault and make sure that they're protected. I've mentioned Sheltered Harbor a few times. I think it's a really good organization for people to look at for best practices. Shelteredharbor.org is the site. If you're in the U.S. banking and financial services industry, you can be an actual participant. And I think it's a good evaluation to make. It helps protect the U.S. financial system. If you're not a potential participant, the ideas that they have, and you can see here on the right, for example, how they require a data vault, the characteristics that are necessary to protect data are useful. So the unchangeability, the separation of the data, make sure that it's accessible. All those components add up, and there's more technical requirements there that are really useful. We're looking forward to winding up our last step of our endorsement process this month, which is August 2020, and continuing to work with the organization and their participants out there. So just kind of wrapping up here, why Dell Technologies for cyber recovery? I mentioned before kind of some of the specifics here. The air gap is hugely significant. Just making data immutable or locking it is a good step, but it's not enough. All of our experience in this space, really good, 5 years. We know what we're doing. We've made changes to the product over time to reflect some of the new techniques. And then the analytics in the vault, going full content. All of those things really add up to a very robust solution. We've got a lot of other materials out there on our website, videos, case studies, white papers. Recommend that to you also. So I want to thank you very much for your time. Look forward to the opportunity to maybe speak with some of you in the future, and be safe and take care. Thank you very much.
Hello and welcome to VMware SD-WAN by VeloCloud session. 5 ways VMware SD-WAN enables network transformation. I am Rohan Nagi, Senior Technical Product Manager at VMware. I also run SD-WAN 360 podcast. You can do a Google search for SD-WAN 360. It's one of its kind podcasts. I also co-authored a couple of books on SD-WAN. You can check on Amazon for those SD-WAN books. So let's go through our agenda for this session. 5 essential capabilities that SD-WAN delivers in here, which can transform your network using the VMware SD-WAN. So we'll look at how SD-WAN simplifies the deployment. But before that, we will kind of go over the problem statement, what the problem statement is with the legacy architecture. Then we'll kind of touch base on the SD-WAN 101, where you understand the components, how the VMware SD-WAN solution really works, how the architecture is. And that's where we'll go over those 5 essential capabilities like deployment simplification, application performance, security, what are the flexibility in the security. So with that, let's get started. I call this as IT 1.0, and that's where the legacy architecture comes to play. The traffic pattern, if you see, is very predictable. User from the branch side will try to access a resource which is sitting in the data center. So request, response, and typically it happens over the private circuits, which is an expensive circuit which takes time to get it installed and configured. And then moving on, we started getting more and more public internet connection, but those were used kind of as a backup. So there is an active backup scenario. Not all the circuits were leveraged at the same time. So there was some inefficiency at the same time, configuring them, pushing out the policy, different network functions at the branch site. All those created that complexity, and that's where I'll consolidate in the next screen for that problem statement. So like I mentioned, all the user traffic, getting backhauled to the data center where the resources are, but over the years, or even during this pandemic situation where users are working from home, we see that, user locations are changing. At the same time, apps or your applications have started moving to the cloud. So your applications are now everywhere. There are on-premise applications, there are cloud-based applications. So enterprise networks are really not ready to work from anywhere. Like I mentioned, apps are moving, even the data centers are moving to the private cloud, the public cloud. WAN is really getting complex out there. You can see actually 50 to 80% of the traffic is backhauled to the data center. And at the same time, complexity has started increasing on the branch sites where, you have hybrid connections, you have public internet, you have private internet. So these are some of the problems. But what are the real user concerns for user? Poor voice quality when they are using a business collaboration application like Zoom. At the same time, inconsistent experience when the user changes their location, let's say from branch office to working from home. What are the IT concerns? IT concern is to provide security when the users are moving, when they are using, let's say, different laptop. At home, I'm using my home laptop. How do I access these company applications securely, or applications which are in the cloud? And these leads to other problems, which I have kind of listed out here, scaling problem. At the same time, if you see the biggest kind of a drawback with the legacy architecture is the hub and spoke model. Every traffic from these spokes, from these branch sites, has to go to the data center where the hub is installed, which increases the latency. So with the current environment, if we have to move away from this legacy architecture, what we want is the networking and even the security actually must come together to serve the user either at the branch or at working from home or from any location. And that's where SD-WAN comes to play. And I'll come to this VMware SD-WAN architecture, but let's do that SD-WAN 101. What are the basic capabilities for any SD-WAN solution? So the key 4 things are transport independence. What it means is, if you remember the problem statement, even when you have multiple circuits, we are using them in a primary backup mode, primary standby mode. But with SD-WAN, you'll be able to leverage all the circuits at the same time. And with VMware SD-WAN, all the circuits by default are in active fashion. So you are leveraging all the circuits, and that brings transport independence. Any kind of circuits you can bring in to VMware SD-WAN. The second key piece here is, now that I can use the public internet, what about the security? How do I access workloads in data center or in public cloud? So I need some kind of a secure overlay, and that's where VMware SD-WAN will build up secure overlay tunnel between branch to hub, branch to data center, where the hub is branch to branch, dynamic branch to branch, or even when the traffic is going to the cloud. And you might be wondering, traffic going to cloud in a secure fashion, and that's where VMware SD-WAN comes to play, and it shines because one of the VMware SD-WAN component, the gateway, it's in the cloud, hosted and managed by VMware. As a customer, you don't have to take care of that gateway. It has a global footprint. And we'll talk about that in the next slide when I kind of share the components of the VMware SD-WAN. And that secure overlay over public internet or private internet brings in the cloud VPN, where the VMware SD-WAN supports multiple topologies, like I mentioned about the hub and spoke, branch to branch. And at the same time, application firewall, there is an integrated firewall built into these edges which you deployed at the branch site or at the office, your home location. Now that we can leverage any circuit, security is in there, who will take care of the link steering if there is any blackout or brownout condition? And that's where the third components come to play is the path selection or the application performance. That's the key. And that's the number one driving force for adopting SD-WAN solution, dynamic path selection. And with VMware SD-WAN, we take a further step away with our secret sauce, which is DMPO, dynamic multipath optimization. It will leverage all the circuits. It will break your single session traffic session into per packets, into small packets, and it will send across multiple links. So your user traffic will go on all the available circuit, and on the other end, where the VMware SD-WAN gateway or the hub or any VMware SD-WAN data plane devices, we are going to reorder the packet. That's the key here. So per packet, sub-second, that's where this dynamic path selection comes to play. We continuously monitor all the circuits, and if there is any link impairments like latency, jitter, packet loss, we will adapt to it in sub-second fashion. First of all, I think the very key important thing here is you need to make sure that you detect it sooner, and that's where that sub-second comes to play. And we'll talk about this later in the slide. And the fourth key pillar is simple interface, simplicity, which is built into the VMware SD-WAN product. And this is where three key component comes to play: the management plane, the orchestrator. From a single place, you can manage and monitor your circuit. Edges, the CPU device, which could be hardware, virtual, which goes onto your branch, which goes onto your data center as a hub device. And then the third key piece, very important, is the cloud delivered, the cloud-ready gateways, which has a global footprint. So if I have to access any SaaS application, your traffic from the branch will redirect it to these gateways, and then we are milliseconds away to the SaaS cloud or to the internet using these gateways. So we have 1,000+ gateways across the globe. That's where, and why choose VMware SD-WAN? I think we talked about it. Cloud adoption, that's where the gateway comes to play. Assured application performance, DMPO, we talked about it. Simplification, simple, like zero-touch provisioning to kind of instantiate when I drop ship the edge device to your location. With simple clicks, you can zero-touch provisioning, you can kind of activate your edge device and you are ready to go. And then flexibility in the security solution. And that's where VMware SD-WAN comes to play. And now talking about those transformation, I think deployment simplification, that's the key we will talk about first. And this is where I want to show that zero-touch provisioning when the edge device is drop shipped to your home or branch office. And this is where I'm going to kind of share a video and talk through it, what it is about. So as an enterprise admin, you will create a site from the orchestrator. And once the site is created, let's say the device is drop shipped to a remote location where a non-IT person will kind of unpack the device, power on the device, connect the internet cable to any of the WAN ports. You don't have to worry, or you don't have to call the IT support to which port should I be connecting to. So just connect the power cable, connect the internet cables, and then you will receive an activation link from the enterprise admin in your email. So just use your laptop, mobile device, or an iPad and connect to that email, access that email from that device, and click on the activation link. Once you click on the activation link, then the magic happens. The edge device will talk to the orchestrator, exchange security tokens, and that's it. It will get activated. Once it is activated, you don't need that non-IT person, or you don't have to call a remote admin sitting at that branch location to do any modifications or any configuration. You can do everything from that centralized orchestrator management plane, which is also sitting in the cloud, managed and hosted by VMware. It's again a multi-tenant in nature, the gateways and the orchestrator. So you can see the activation process here. Once it's activated, enterprise admin from the orchestrator can view that edge device, and they can kind of use that device to do the further configurations and monitoring piece of it. So let's move away from that video, and now let's talk about that DMPO piece of it. DMPO piece of it. This is where DMPO comes to play. Continuous 24/7 link monitoring we do, so we know at any given time how the links are performing. So we can do link steering in sub-second fashion. Even when we have a single link, we can do on-demand remediation and aggregation. First, we detect the application, because all of our edge devices runs a deep application recognition engine, what we call it as API. So today we can recognize 3,000 plus different application. We already built up a secure overlay from the edge device to the hub device or to cloud where the gateways are, or from branch to branch. So all your application traffic which is going inside this SD-WAN overlay tunnel is continuously monitored, and we know at any given point how the links are working. Just to give you kind of a quality score, like a before and after. Before is where, let's say, your traffic has started flowing through this one of the ISP link out here. When you see these red and yellow marks, this is where the WAN impairments are happening. We will try to either remediate these situations, or we'll try to do the link steering if the other link has a better SLA for it. End-to-end, what you need to remember with the application performance is this key thing: continuously monitor, dynamic per packet steering, and on-demand remediation when you have a single link. With on-demand remediation, we do the jitter correction, error correction, automatic steering when there is a blackout and brownout condition. On a single link, we do the on-demand remediation for a brownout condition. And this is just a use case for a business collaboration application. Let's talk about the architecture for the cloud. Like I mentioned, one of the key components, the gateway, is in the cloud, globally across the cloud. Today, we have 1,000 plus gateway around the globe, which has a footprint globally. And these are kind of sitting in the same core facility where the SaaS providers are. That's the key to it. So we are kind of milliseconds away to the SaaS cloud. And you can see here now from the branch, I can directly, the traditional approach was to backhaul to the data center and then go to the SaaS cloud. But now with these gateways, you can just redirect the traffic to the gateway and then it goes to the SaaS cloud. That's where VMware SD-WAN gateway comes to play. Flexible architecture, you can place there is no rip and replace kind of a thing for VMware SD-WAN CPE devices. They come in different form factors. VNF, you can have pre-installed on hypervisors. We also can instantiate these edge devices over the cloud. So any kind of topology is supported. There is no rip and replace kind of here. You can augment with your current topology. Even if you have a third-party kind of a router, you can place your edge device here and you can run a VRRP, or you could run it in a fashion where you have internet connections and the MPLS is going through the CE router for the service provider, and it has a pairing with the PE router for the service provider. At the same time, you can get rid of the CE router and you can use our edge device where it is terminating all the public and the private connections. And you can also connect to a non-SD-WAN site using this overall topology. At the data center, you can stack up multiple edge devices to form a cluster. And that's where that flexibility comes to play. When we talk about security, that's very important. We give multiple options. Like I mentioned, we have a built-in firewall, which takes care of your traffic inspection. At the same time, you can still use that backhaul to the data center where you are running the next generation firewall, let's say. So you can still use that legacy approach. There are still some enterprises which leverage that because of some compliance reason. You could also instantiate a third-party firewall on selected SD-WAN edge devices, and even those are supported. The fourth is the secure web gateway, where what you are doing is you are kind of, like I mentioned in the problem statement with the legacy architecture, the branch is running multiple network functions. So it's heavy, it's a thicker branch. So what we are doing is we are taking the complexity away from the branch and putting that in the cloud. So in this case, we are putting the security functionality like CASB providers like Cloud Access Security Broker, or other functionalities of SASE, which I'm going to talk about there in a second. But what it means is we're taking the security functionality away from the branch and you are putting it in the cloud. So the SD-WAN task here is to provide you with the transport and the WAN improvements. And that's where that SASE approach comes to play, where you are taking the security functionality in the VMware SD-WAN gateway. So all those SASE components like DLP, CASB Secure Web Gateway, web access firewall, all those things are there in the cloud, and SD-WAN will make sure that you have the WAN acceleration and connectivity to the cloud. And there is plus more, the visibility and the monitoring through Nyansa on the branch LAN side, and then the monitoring on the WAN side with the vRealize network, what we call it as warning. I think this is what I have for the session out here. You understood the problem statement, where the VMware SD-WAN comes to play, and what are those 5 things we talked about which can transform your network from your legacy architecture to an VMware SD-WAN. This is what I have. Thank you.
Hello, everybody. My name is Darren Schmitz, and today I'm going to be here to talk to you about VMware Cloud Foundation and deployments that involve your existing investments. So again, my name is Darren Schmitz. I'm a senior principal engineer from Dell Technologies. And so here we go. Today on the agenda, I'm going to give a brief VMware Cloud Foundation overview, talk a little bit about the benefits of using external storage with VCF, dive a little bit into VCF and vSphere with Tanzu, and last but not least, I have a live video demonstration of deploying a workload domain using the new iSCSI vVol storage in VCF 4.1. So with that, let's get going. So for VMware Cloud Foundation, if you're not familiar with the product, there are a lot of there's a couple major use cases for it. So the primary use case for deploying VCF is private and hybrid cloud. So in my opinion, one of the greatest things about VCF is it's basically the on-prem version of VMware Cloud on AWS. So you can provision your infrastructure, stand up your legacy apps, and then using the NSX networking, basically make a bridge between the on-prem and the cloud for hybrid cloud. The second primary use case for VMware Cloud Foundation is modernizing applications. So either you're developing a new application, a containerized application, or you're converting an existing legacy application into a more container-based architecture. Cloud Foundation is great for that. And last but not least, one of the other use cases for VCF is automating a Horizon VDI deployment. And by that, you can download a couple of modules, and it basically wizardizes, if that's a word, the deployment of a Horizon into VCF. When we look at VMware Cloud Foundation, there is the bill of materials is basically the listing of all of the software that kind of brings up, it's what makes up the SDDC, or the software defined data center. So at the top of the list, you're going to see SDDC Manager. And when you first have a VCF deployment, what you do is you deploy a OVA, a virtual machine called Cloud Builder, and you feed it some parameters, and it goes off and it deploys vSphere, vSAN, NSX, and vRealize Suite Lifecycle Management. So, and then last but not least, it deploys a virtual machine called the SDDC Manager machine to look over everything. So that's the main software components of VMware Cloud Foundation. In addition, there's a couple of add-on components, most of them in the vRealize suite of products, also Workspace ONE access. Those are all things that you can additionally add in if you need. So let's start looking at the hardware, physical hardware overview, because a lot of people are curious, you know, what does this look like if it's sitting in my data center? So when we look at Dell EMC storage and helping the portfolio, really with VCF, you start with a minimum of 4 nodes. And this can be expanded to a rack, a full rack, many racks. You add some top of rack switches, maybe even a management switch. The key is that you're adding a bunch of compute and basically servers that you know, don't all have to be the same. You know, you can have high-powered servers, medium-powered servers, and whatnot, and throw them in a rack and start creating what they call workload domains. But in any case, the first 4 servers that you deploy for VCF have to be the management domain, and that's a minimum of 4 servers, but depending upon how big you're going to scale, it can scale up to the vSphere configuration maximums. So like I said, if you were to grab a bunch of hosts, any number of hosts, again, this conforms to the vSphere maximums, you can create what's called a workload domain. 1, 2, 3 workload domains, racks full of workload domains if you want. Now, some of the key things that I'm talking about today is really the add-on of Dell EMC storage, or any storage in general, to a workload domain. So in my lab, obviously, since I work at Dell Technologies, I have a bunch of Dell EMC PowerStore and Unity arrays. Or you can create a workload domain with PowerMax, Platinum Storage, depending upon the workload. So that's part of what I really want to drill home today is that you don't have to, you know, the deployment with VCF is super flexible, especially with VCF 4.1. So let's look at some of the storage options. So as I said, the first 4 servers, the management domain, those have to use vSAN. The vCenters, everything that gets rolled onto that is, it's mandated that the management domain is backed by vSAN. However, the workload domains that I was just talking about, they can either use vSAN or external storage. And when we talk about external storage, there are 2 terms that I want to introduce to you if you haven't heard them before: principal and secondary storage. And by no means does principal mean a class of service with the storage. It's not that the principal is like the tier 1 storage and the secondary is the tier 2 storage. No, when I say principal and secondary, all I'm referring to is the order in which it's deployed. We call the first data store that's deployed the principal storage, and any data store that's, once the workload domain is up and running, any data store you add after that is secondary storage. So again, the principal and secondary does not denote the class of storage. It's simply when it's deployed. So for those principal storage options, like I said, new to VCF 4.1 is the vVols, and that's supported by iSCSI, Fiber Channel, or NFS. But for principal, you can use vSAN, obviously, NFS v3, or what they call VMFS on Fiber Channel. Now, supplemental storage options, the two options that you just simply can't use to deploy a workload domain is just NFS v4 and VMFS on iSCSI. The rest of everything is available for supplemental storage options as well. So from the customer point of view, one of the key, in my opinion, some of the benefits of external storage is obviously with VCF is leveraging your existing storage array investments, right? So if you have an array in the environment that may be underutilized, has extra performance that you don't really want to, go by the wayside, obviously you can use this for storage in a VCF environment. Storage array is an important and sometimes expensive investment, and it's best, some customers like to leverage that. And so the second benefit, I think, with VCF and external storage arrays is that you can scale storage independently of the workload domain compute. And that's important because when you're using vSAN, you often have to scale the storage with the compute. And if you have a really compute low type workload and you have that requires just a ton of capacity, it's nice that you can attach a SAN to externally and scale that independently. The third benefit for using external storage is obviously if your business is dependent on some features that are embedded in the array that are important to the business: replication, deduplication, metro cluster, stuff like that. So that is one additional reason for external storage arrays. But the final reason is just basically performance. So there are certain high demand workloads that just require external storage. So if the workload, if vSAN is not desired for a particular workload, then that's where maybe an external array can fill in and fill that gap. So let's talk about vSphere, vSphere with Tanzu on VCF. So in my opinion, one of the greatest things about Tanzu on VCF is that it is super easy to deploy. Basically, you create a workload domain, as you see on the right-hand side of the diagram. You basically create a workload domain. This deploys NSX. After that, you deploy an edge cluster. You enable workload management, and basically, it's up and running. You can run TKG on top of that. Maybe load up Harbor, whatnot. But the greatest thing about this is that it is completely lifecycled by VCF. So it takes care of updating all the components when it's time to get to the next version of stuff. This is great, obviously, because as we are moving on to the next generation of apps, this allows people, obviously, to make new containerized applications or convert existing in-house applications to container-based. So if we bring this whole thing together, I think one of the greatest benefits of VCF, especially when you pair it with external storage, is that you can have your virtual machine workloads, which are maybe even your traditional virtual machine workloads, side by side with the cloud native applications, right? So this gives the administrators a one-stop shop, a single pane of glass to administrate everything and work on everything. And because of that, that obviously simplifies modernization initiatives. If there's applications that are being converted in the environment, all the better. So the cool thing about external storage, especially when we're talking about vVols being brought in as principal storage into VCF, is that these containerized applications that require the persistent storage can utilize any data store. So as you're adding supplemental storage or principal storage to the workload domain, all you need to do is add a tag to that data store, which tells the Tanzu, the Kubernetes, that is eligible for containerized persistent storage. So the great thing about that is that you can have different storage types underneath. Kubernetes doesn't care about it. And obviously with that, SPBM is utilized you can use that in the environment. If there's one thing I want to convey is that VCF with external storage just simply adds flexibility. You're really getting the best of both worlds. External storage and that flexibility really adds to the on-prem environment. And from there, that could be extended into the cloud or hybrid cloud where you have certain apps out in maybe a VMware Cloud on AWS that talk back to the on-prem application. The great thing about this is that, as I said, flexibility, apps can live anywhere. So with that, I'm going to get to the live demonstration. So with VCF 4.1, we have the addition of vVols as principal storage. So in my lab, I'm going to show setting up an iSCSI workload domain that is backed by vVols. So the first thing I want to show you is in the network settings. When we create the network pool and give it a name, you're going to notice that the new thing in VCF 4.1 is a network type. They added a dedicated iSCSI networking type for iSCSI traffic with VCF. Now, previously they had NFS, but in 4.1, it adds iSCSI so that when you create that workload domain, it can basically create VM kernel interfaces for the iSCSI traffic. So you'll see we add these networks and we hit save, and that basically creates our network pool. From there, the next thing that we need to do is add our VASA provider. So to do that, there's a new section called storage settings. And as you can see, I have multiple different arrays in my lab, but I need to add my PowerStore array because that's one we're using for iSCSI today. So when we add the VASA provider, all we're doing is adding a name, the URL to the VASA provider, the username, password, matching up the container name and the protocol. And then we can hit save. So again, multiple arrays in the environment, you can add multiple VASA providers. To set this up, previously, all we did on the ESX host is basically we went into the iSCSI and enabled it, cut and paste the IQN, and then added the dynamic target to the bottom. And basically that prepares the ESX host to talk to the array when the workload domain is rolled out. So on the array itself, the only thing that I had to do, this is my PowerStore array in my lab, is all I had to do is go in and add all the hosts. And as you can see, what I did is I simply added the host and pasted the IQN in there. If you'll notice, it's not active yet. There's no active sessions to it yet. It's just simply waiting for the connection when the workload domain gets rolled out. So when we flip back to the SDDC manager, the next thing we need to do is commission the hosts. So I click on that. Here's the checklist of all the things that need to be done to the hosts. As you can see, I already completed those. Now I'm going to import a JSON file to make this a little bit faster. I upload that, and then I can basically start the validation for commissioning the hosts. And I'm going to fast forward this. so that we don't have to wait several minutes. This does take a minute or so for that to complete the validation. But once we do that, I can click on next and commission. So while this is commissioning the host, we can basically go out and look at the tasks. As you can see, it's running, and the commissioning takes about 2 minutes in my lab. And once the hosts are commissioned, they are all ready to go for creating a workload domain. So we flip over to our workload domains, say workload domain, VI workload domain. And here's where we choose for our principal storage type. And in this case, we're picking vVols because we're going to use iSCSI vVols. And we say begin. And I'm going to cut and paste basically all the information into this. But the information is just basically, names, cluster, the vCenter information is what I'm putting in now, and putting in the passwords for vCenter. Here's where we put in the networking information for NSXT. Again, we're putting the managers, the FQDNs for the managers in there. It automatically does the name resolution for the IP and put in the passwords and say next. This next screen is where we specify the vVol storage that we want to use. So I'm using iSCSI, and that's going to allow me to select my power store. And then we pick the storage container that I'd previously specified, the username I want to use, and then I can just paste in a data store name for that particular data store and say next. On the host selection screen, I basically am just picking the 4 hosts that I want added to this workload domain, and I say next. I select my licenses and say next. I review the object names for the switches and object types, and then I say finish. And this gets the workload domain deployment started. So if we drill down into the task, we've got to wait a second for the task to be populated, but in a second it will be there and we can click into it. As you can see, there's dozens of tasks that the workload domain needs to do, rolling out vCenter, rolling out NSX, deploying a bunch of stuff. I'm fast forwarding this, but in my lab it took about 49 minutes to deploy the workload domain. But when that's done, what I want to show you is that when we click on the workload domain, as you can see, it is listed as, the storage is listed as vVol storage type. If we click into the domain and we open up vCenter, if we open up the vSphere client, this is going to bring us to our workload domain. It's a linked vCenter. So as you can see, my 4 hosts are in there. And to demonstrate vVol is working, I'm just going to basically create a brand new virtual machine just to create the vVols for this particular virtual machine. So type in a name for it. I select the cluster. I select the data store that particular virtual machine is going to be put on. I select the operating system and I say next. Verify all of that information, click finish. And in a few seconds after that virtual machine is created, it's all done. And we can flip back over to the array to see it all in action. So if we click on storage and go into our storage container, you can see my VCF storage container that I specified earlier. If I flip over to the virtual volumes, you can see all of the demo VM virtual volumes and the cluster service vVols that the workload domain rolled out for that particular domain. So again, external storage is really beneficial when you add it in with VCF. As I said, there's tons of benefits, but the main benefit is adding flexibility to your deployment. So there are a couple of additional resources if you'd like to learn more. One of the documents that I maintain is the validated designs Dell EMC storage with VMware Cloud Foundation. If you Google H17921 or click on the dell.com/storage resources and drill into the one of the PowerStore or Unity section, the document is in there. This guide is a step-by-step walkthrough on if you're a EMC customer or Dell storage customer. It really is a step-by-step guide on how to implement any of the storage arrays in the Dell EMC lineup as principal or supplemental storage in your environment. Obviously, the VMware Cloud Foundation link is out there for additional information about VMware Cloud Foundation. And with that, I want to thank you very much and have a good day.
Hello everyone. Today I'm going to be covering the considerations and constraints for running VMware Horizon on VMware Cloud on AWS. My name's Dean Lewis and I work as a technical account manager at VMware. You can contact me through my blog, vTechTalks.co.uk, and also on Twitter, SaintDLE. As there's going to be a lot of information we're going to go through in the next 15 minutes for this recording, you can grab all this by going to the short link theexpert.me/VMC-Horizon, and I'll show these links at the end again as well. Just a quick overview of the agenda. Essentially, we're going to be looking at what Horizon is, what's special about it when it runs on VMC, talk about those considerations and constraints throughout, and then finish off on a final summary as you'd expect. Okay, so first and foremost, I'd like to start with Horizon 7 running on top of VMware Cloud and AWS is not desktop as a service. For those of you who may not be familiar with the VMC offering, it is a VMware managed service. We run the underlying vSphere platform for you, and you consume it by bringing your own virtual machines to the mix. By running Horizon 7 or 8, also known as 2006, which has just been recently announced, as an IaaS model, it means you bring the platform or the virtual machines onto the MC and you run it yourself. So this will be self-managed, you are the tenant. This is in contrast to our Horizon Cloud offering, which is available on IBM SoftLayer and in Azure as well, which is a managed service from the Horizon platform itself. If you are using the Horizon Cloud platform, you will bring your virtual machine images and you will ask to deploy those images into a pool, which can be used by your users. But you will not have to manage the Horizon platform itself. Today, we're only going to be talking about running the IaaS model of running the IaaS components on the MC itself. Just also want to make a quick note. In VMware Horizon, we also support the cloud architecture. The reason why this is important is typically a lot of customers looking at running Horizon in VMC today already run Horizon in their on-prem data centers. You can extend your Horizon environment by using cloud architecture into the environments running in VMC and running in your on-prem vSphere environment. That creates a flexible, highly available platform. You will have to keep the platforms in sync with one another from a version and control point of view. But other than that, it's the exact same kind of architecture and references you'd be looking for to running cloud architecture if you were keeping all of your environments the same on-prem, but maybe between different data centers. Okay, so I'd like to allude to what is the big difference from a usability point of view for Horizon once it's stood up and running the VMC. And the answer is not much. It's a small little tick box. When you connect your vCenter server to tell the Horizon environment where it can deploy its resources to the platform, you tick the little box that highlights its VMware Cloud and AWS as highlighted by the big red arrow. And this lets the Horizon environment know that there is a limited RBAC model in place as part of the VMC platform because it is a partly managed service by VMware. I'd also like to note that there are some feature support that you need to take into consideration as well. So for example, we don't support View Composer linked clones in VMC. We don't support running security servers, which are the Windows-based Horizon servers using your DMZ. It's preferred to use the Unified Access Gateway. And also there's no ability to use things like vVols, for example. This isn't applicable for VMware Cloud and AWS because we provide you a single vSAN workload data store. vRealize for Horizon monitoring. We don't actively support it. It can be granted on an individual basis to feed to your Horizon SME that you're aligned to if you're looking into running a Horizon project. And then finally, the just-in-time services, the JMP servers, you can use them in the Horizon Cloud Console instead of running them yourself as well. But again, some of this information as we start to release and ramp up with the GA dates for Horizon 8 will once again change again. So for example, just going back to the lack of linked clones, if you were deploying the latest version of Horizon, we only support instant clones anyway, so it's not as much as a consideration going forward. On our cloud.vmware.com website, we do have a reference architecture that takes you through the minimal viable product to start building your Horizon services in VMC. So let's look at some of the typical considerations and constraints. So the first one is always about your underlying platform. Identity management is always going to be key. proximity to your Active Directory. So if you don't run any VMC services today and you're looking at this being your first foray, you need to consider at least a read-only domain controller stretching from your private or on-prem data centers into VMC, and ensure that you configure sites and services correctly within Active Directory so that when users are authenticating to any services running in VMware Cloud and AWS, it authenticates against the local domain controller and doesn't go across your VPN or WAN links back to your on-prem data centers. File shares is always the biggest one because files access is your end user experience for most users. When they log on, they want to run Word documents, PowerPoint presentations, images that they may have edited. So again, proximity of these file shares to the user's desktop running VMware Cloud AWS is key. For the user documents, consider using technology such as Microsoft Distributed File Services if you are stretching between your on-prem environment to VMC. We also support native services within Amazon that you can bring across into the VMC environment as well, in particular the Amazon FX for Windows File Server service. So this is where you would spin up a Windows server as an EC2 instance, add the Amazon FX technology on top of it, and then use it to host the file shares back into your SDVC. User profiles. I'm pretty sure for those of you that have been sysadmins for many years, user profiles have been the bane of your life as much as have been for myself. Consider using technologies such as user profile management. So for VMware, that would be our Dynamic Environment Manager, previously named UEM, where you can dynamically build configurations for users on the fly as they log into the systems. This minimizes the need for GPOs and replication, and also as well can give the user the feeling of persistence, especially in non-persistent desktop builds where those desktops may be deleted when users log out. We also do support user profile concept systems such as Microsoft FX Logic, which is a cool technology which kind of containerizes profiles as well. However, that's a little bit newer to the market and may take a little bit more changes in your environment to get up and running so that it works as you need it to. And then finally, one of the big things for me is image management. So at the moment, Horizon doesn't support the use of content libraries, which is using content libraries, you can synchronize images between environments. So unfortunately, there is going to be some manual parts to how you operate the data operations and push updates out into your tools as well. So you need to consider about running those golden images. Do you run separate images in your on-prem environment and in VMC? And if so, how do you update them in lockstep? So that's going to be more about how you control your standard operating procedures for the time being. And again, image management today, I know that it is going to be one of those things that's a little bit tricky for yourselves, but by feeding back how you'd like this to work to your VMware SMEs as well really helps because we can work with our engineering departments to meet your needs. So for me, the biggest considerations and constraints when running in VMC to an on-prem platform is the networking and security side. When running Horizon, as you've kind of already noticed, we've not really talked about in the Horizon admin console itself, for example, because everything kind of feels and looks the same, but the networking and security piece is really key. So you're going to have to create yourself some LAN and DMZ segments in the VMC console. As you can see by the screenshot that I have for my test environment, I created a DMZ, a network to run my RDS farm, which is linked to Horizon, and then also a load balance segment as well. Moving on to load balancing, VMC is a bring your own load balance environment. So although the underlying platform uses NSXT, the load balancing functionality isn't exposed to the end user. So what options are available? You could use things like AWS Route 53, which is fantastic, especially if you want to use the cloud pod architecture. You could use the AWS Elastic Load Balancer, so again, leveraging those native services of AWS as the diagram shows here at the moment. But you also need to consider the traffic. So the user will be terminating from the public internet to those native services, and then will need to be passed from that VPC of those native services into your VMware SDVC. Or you can bring a load balancer directly to the SDVC within VMC itself, such as Avi Networks, also now renamed NSX Advanced Load Balancer. The difference being here in the second screenshot is that that traffic will terminate on the compute gateway, as all of your other traffic will within the SDDC, and then the load balancing function is going to happen in your environment. That's also very obvious, but some of the considerations you need to take there is by running them virtual machines on your platform, you're consuming the compute and storage of the SDDC, whereas you may not have those considerations if you're running the native services within AWS. And then finally, you're obviously going to be running desktops up in the environment, and typically nowadays a lot of people go down the non-persistent route, which also means using DHCP. In VMC, the options are very limited. DHCP is available as a relay now, and for an environment, especially where you're looking at running hundreds or thousands of desktops, it's recommended to set up a DHCP on a server running in VMC. Run it just on the subnets that you need, but it also gives you more granular control. Also moving on for the security side of it, we have two types of firewall. So we have the gateway firewall, which looks after north and south traffic. So that's everything entering and leaving clusters or the SEC to the outside world. And then we have the distributed firewall. So this is your east to west traffic or microsegmentation services you've probably heard from the NSX technology, protecting communications between virtual machines. You should see me highlighting that there at the moment. You need to use the distributed firewall to create a DMZ for your UAG services and load balance services. So what does that look like in VMC? In my environment, I created a section. I've put all of my rules going back and forth between my UAGs to the various components of the Horizon platform, so such as my connection brokers, my load balancers. And at the end, it's very simple. I've created two rules. So I block any traffic which hasn't already been allowed going to my UAGs, and then finally deny any traffic going from my UAGs to anything else in my environment. This creates a DMZ. If I don't add these deny rules in, then because I'm using routed networks in VMC, my UAGs will be open to route around my network. One of the things I'd also recommend that you do is look at vRealize Login Site Cloud. You get a limited service offering as part of being a VMware Cloud and AWS user, and you can monitor your NSXT firewall logs up to 1 gig of logs per day, and these are easily sent to Login Site as built in as part of the service by just clicking the option to enable logs on your firewall rules. And here we can just kind of see in this diagram, I'm querying on the NSXT firewall, and then we can just see some traffic which has been allowed and disallowed through the environment. Okay, so let's wrap up with some final considerations. And again, I will share the links at the end of this presentation because I know I've shared a lot of information so far. Consider your use case. A lot of customers are looking at the data center evacuations being one of the use cases. You may already have an on-prem Horizon environment running on aging hardware. So do you want to use cloud pod architecture to give the user a seamless interface between consuming on-prem resources and resources in VMC? Or will you run them as separate Horizon instances? So again, what versions you run your Horizon environments will help also make that decision. What are your constraints when building this environment? So think about sizing your Horizon environment. How many users are you going to need to support? Then consider the maximums in terms of soft limits and hard limits. How many hosts per cluster can you have within your SDC? How many clusters per SDC? And what regions do you need to operate in? Desktop to host ratio is always a key thing for VMC. So do your users run intense workloads such as multi-monitor setups? If the answer is yes, you're going to get less desktops to host ratio, which then pushes up the numbers of clusters that you need. And then finally, networking. So what's your connectivity into VMC? Are you using things like IPsec VPNs, which will add an overhead into your traffic? Or are you using the AWS Direct Connect technology, which is faster links, dedicated, but also come at a high cost? And some of the resolutions for this. So you could scale out across multiple SDDCs to help with cluster limits, desktop to host ratios, and also as well splitting out maybe that traffic if you're using IPsec VPNs across different tunnels and different connection endpoints as well. If you were to do this across multiple SDCs, as we can see up here in this diagram, then you can also use cloud pod architecture just in VMC to link these Horizon environments together to give you seamless experience. Okay, thank you very much everyone for this whirlwind tour of Horizon on VMC. Again, you can find all of the links at vexpert.me/VMC-Horizon, or you can also scan the QR code in the top right hand corner. Thank you very much.
Hello, and welcome to the session about bootstrapping VMware, the infrastructure as code way. What we're talking about in this session is BYO infrastructure. It's an approach to automating VMware at the bare metal level and then upwards. I'm Rob Hirschfeld, your guide for this session. I'm co-founder and CEO of RackN, and I've been doing data center automation and VMware data center automation for over 20 years, believe it or not. You can find me online. I'm at Zehicle, and I've been very active with something called the2030.cloud, where we talk about a lot of advanced futuristic concepts in DevOps. And so what we really want to talk about here in an infrastructure as code sense is to look at this traditional infrastructure stack that we've built. Because we know that if we fix things at the bottom, that physical layer, then everything we build on top of it, and this is a totally standard VMware infrastructure stack. It's something you would see in other vBrownBag presentations. As a matter of fact, it's modeled on them. So what we've seen is that while people like to squeeze the physical layer at the bottom of this down into this tiny part of the stack, it's actually a complete stack in itself. It's not just a small box. It's actually compute, storage, and networking components that you have to get right, and actually very carefully right, in order to make everything we build on top of it work. And so at RackN, we spend a lot of time thinking about exactly this problem and how do we treat these components like a cloud. And a lot of what that means is, how do we take DevOps automation pieces, infrastructure as code concepts, and automate that physical layer also? Because if we can do that and use the tools and techniques and all the great cloud-like style, we can really make a huge difference in what it's like to actually run a data center, really transform it in very positive ways. And that's what we want to talk about. It's worth mentioning RackN Digital Rebar is this product that we have that's designed to help companies self-manage VMware. So we're not a consultancy, we're not a service provider. We're literally helping companies manage their own VMware infrastructure, whether it's legacy, new, or edge infrastructure. And so that's really about automating infrastructure, securing it, and making it portable so that you get reuse out of the problem. So we see this quite a bit. We're helping multinational customers and service providers automate VMware and do it themselves. So we have a lot of experience with this. And what we've learned in this is that there are really 6 key factors in design that you need to understand before you even write a line of code or a line of infrastructure as code in this case. And so in those factors, we have an organizational component where you really have to be able to say self-management is possible. I can do this myself. I don't have to turn it over to a VxRail or an HCI vendor or a cloud. That you can actually do it, right? And believe that you can do it. To do that well, you have to have human understandable operations. So people have to be able to see what's going on as we automate it. And then once you've done that, it has to be continuously repeatable. We don't look at infrastructure as code and think that it's a one and done thing. You have to be able to keep redoing this. One of our customers calls this repaving their data center. And they literally roll through upgrades and patches in a 30-minute window, and they repave entire 100 system VMware clusters in that time window. And that is how they create these repeatable, robust data center infrastructures, by being able to just click a button and rebuild everything in their data center. And then on the technology side, we also have to approach infrastructure as code in a systems way. So when we look at this, we're not just trying to solve one problem. Can I provision a machine or can I configure it? We're actually connecting a whole bunch of pieces together, from certificate management and inventories and manifests and DNS. All has to be done together. Otherwise, we're really just creating little islands of automation. To make all this stuff work, it has to be observable. So black box things where something happens by magic do not create reliable infrastructure as code things. Any place where you're pointing to a black box and saying Darby Dragons, you're going to have a problem with your automation and in your code. And that's a lot of what we're trying to do, is take everything that we do from an automation perspective and put it in a code repo so that it's available and you can see it and inspect it and make sure it changes and that you know it changed. There's no people running around behind the scenes and flipping bits to make sure everything works. And then we're creating connected automation. So chains of automation that all work together as a system. So a complete integrated workflow. So I want to take you through how these 6 principles really fit together into deploying VMware from the ground up. This is what we do on a normal basis. The first couple build slides of this builder are just our normal discovery process. We take every piece of hardware, ARM, Intel, whatever vendor you have, cloud or physical, through this standard process. And then we'll actually be able to inventory, verify its hardware, set RAID and BIOS configuration, do out-of-band management, all these processes just to get the machine up and understand what the machine is. Perfectly normal. We do that in every case. And then for VMware, we extend that where we actually use the net boot that VMware has available. We'll pixie boot into ESXi, and then we'll install VIBs that can take additional actions in ESXi. And this is a really important point in automating this infrastructure. In order to do this effectively in an automated way, you can't create an island where ESX requires its own automation or its own manual steps. What you really need to do is come back and have a way to complete the ESXi infrastructure inside. And that's security, setting patches, installing certificates, making sure that your networking configuration, getting off VLAN 0, all those bits and pieces have to be done correctly to do it. And our VIBs are actually signed, so we can do this all with a secure boot infrastructure, which is also absolutely critical to building really robust, reliable infrastructure. And then we can hand off to downstream infrastructure. So if it's Cloud Builder or something else, that's where we now have enough information that however you want to automate on top of that, you have the information that you need, whether it's Ansible or Terraform or whatever mechanisms, or if you're back into CSV spreadsheet land, you have the data that you need to make that all work together. And that's really where we start pulling together these infrastructure as code concepts, because everything I'm showing you in this list are all components and modules that fit together. It's not a big bash script or an Ansible playbook that works, if you put in a whole bunch of value. It's actually things that you plug servers in and just the right things have to happen. And that's what makes infrastructure as code really interesting. And it's not just another HCI story where buy this exact hardware, put things together in exactly the right way. People's data centers are different. And for good reasons, they're different. And so we have to be able to accommodate those differences and let people bring in their own infrastructure and their own legacy infrastructure. And as we go migrations from 6 to 7, you have to be able to take what you have. You shouldn't have to buy completely new infrastructure. And so here's what we hear for customers talking about their needs from infrastructure as code. They need to have useful abstractions. And we're going to go through each one of these. And I'll show you an example of how that looks, and orchestration. But at the end of the day, what we're really doing is working to eliminate manual steps and silos. It really is that simple. That's the goal for infrastructure as code. So when we look at modularity, the idea here is that we're not just looking at a single script. What we're looking at doing is taking big problems. How do we automate a system start to finish, breaking it down into small pieces and making sure that each one is modular and then ultimately understandable. And that lets us build a catalog where things that aren't VMware specific or Linux specific or Windows specific can actually be downloaded and reused, right? RAID and BIOS configuration, while tricky and finicky, is not unique. No customer has unique BIOS configuration. They might have different settings, but the process and the way you do that is something that we can standardize and we can pull in and get code reuse from. And that's really important. And then really importantly to us is if you change it and you extend it or you add to it or you add your own magic sauce, which everybody has, then you have a way to code that, manage it, create your own catalog. Because infrastructure as code, the as code part, a lot of that comes from how you store it and manage it and version control it. All super important. And then from there, you have to be able to understand how these pieces work. And that means that these big modules don't just break down into big modules. They actually have to have clean and understandable inputs and outputs with good documentation and types and clear delineations. And then the big steps have to break down into smaller steps that you can understand. And that can go for us, it goes from workflows into stages into tasks. Tasks actually can decompose into templates because we want to get reuse. And that means that if we solve a problem once, we want to be able to rebuild new modules, click things together in ways that actually create reusable pieces. And that is really helpful because when you're building an infrastructure start to finish like this, we're crossing teams. There's a human element component to how all this stuff works. And so that means that we have to be able to show another team what we've done in a clear, concise way. And then we have to have a handoff so another team can do that work. And that's okay. They have clear inputs and outputs. They put their pieces together, and then we fit everything together into a simple workflow. And that's really a key component for this, because it's not just about, can I provision a machine? It's, can I build a cluster? Can I build clusters and more clusters? Can I go to remote sites? And so there's a concept of building workflows that actually go through and pull all these pieces, these infrastructure of code pieces together. So if you have a Terraform template and an Ansible playbook and a bash script and a pull this ticket and this person has to go turn on a network port, that's not really an infrastructure as code workflow. It's a collection of tools, but they're not built together to deliver a consistent long-term deliverable. That's really what we're talking about, what we would call intent-driven infrastructure. I need you to build a cluster, start this process, everything else should be able to flow out of that. And then from that perspective, that sounds very cloud native, it is. And it's this way of thinking about API-driven infrastructure where you're asking for a request and things are getting done for you. In a lot of cases, we don't expect people to use our system directly or sit in the UX, right? This should be, I need to build a cluster. That should be triggered by external events or other systems or things up stack from where we are. That API-driven mentality is essential to building good infrastructure as code. Once again, it's all codified infrastructure. Those APIs become the gateway between different systems and help you connect all these pieces together. And then finally, one of the most head-shaping things that we've had to learn in this is that building infrastructure of code means that you have to cross context boundaries. So in the work that we're doing and the thing that we found to be really powerful in making it all come together is this idea that I can bounce my context back and forth. I can do work in a machine. I can pull up to a cluster level, verify that things are right, return back to the machine. And this ability to move back and forth from a context perspective really changes the game and how you can automate something, because you can build a single workflow that has different security contexts, collects information, can work across the cluster, and coordinate activities in a way that is absolutely essential to accomplish this end-to-end system driving perspective. So I hope this helps you understand how we see infrastructure as code and really where the industry is going, because this isn't pie in the sky things. This is actual work that's being done by customers in the field. They're using these techniques. They're actually building data centers and clusters based on infrastructure as code practices that are repeatable, safe, and secure. Whether it's a brownfield system, it's a greenfield system where they're bringing in new ideas and new capabilities, and then being confident that the things they've done aren't going to be locked in for the next 10 years, and they'll be able to change and keep revisiting how things go. If this is exciting and interesting, please, we'd love to have an extended conversation with you at rackn.com. And everything I'm talking about, we have people doing. You can try yourself. You can just download Digital Rebar, try the VMware pieces, build your own clusters. The stuff we're doing is really designed to be that simple, because we're helping people self-manage their infrastructure, not take over control from them. So, thank you for spending a couple minutes with me learning about infrastructure as code. This is Rob Hirschfeld from rackn.
Hello, welcome to the vBrownBag with Dell Technologies. Today, we are going to talk about ProperTech Data Manager and how to protect your Kubernetes environments on VMware. Hi, my name is Nivas Iyer. I'm the product manager here at Dell, managing the data protection for Kubernetes and cloud native solutions. So the Dell EMC PowerProtect Data Manager is an enterprise-grade data protection for your Kubernetes, the virtual machines, and applications. So it's a single platform that provides a protection for your entire environment. It provides you with a management for both the enterprise IT teams and also for the cloud native administrators. So both of them will be able to simultaneously work and collaborate on a data protection. And finally, it is built using in collaboration with Velero, and it encompasses a cloud native architecture, and we support the Kubernetes community. So you have one protection experience to back up your entire VMware cloud environment and the cloud native storage with PowerProtect Data Manager. So just to give a quick pictorial overview, so regardless of whether your applications like Oracle and SAP, if they're running on bare metal servers, like on operating systems, or if they are virtualized environments like your Microsoft Exchange server and SQL server, or your containerized applications running on Kubernetes, such as MongoDB and MySQL, you can protect all of them with just one product. So this is the first and only enterprise-grade protection solution for virtual machines, applications, and Kubernetes. And we are really excited to talk about it today. So just to give a brief overview of PowerProtect and our integration with Tanzu. So currently we can support VMware Cloud Native Storage. So what that means is when you have a VMware a storage environment with Kubernetes running on top and you're leveraging the VMware Cloud Native Storage that's exposed to the Kubernetes environment, we can protect those using special APIs that we have worked with VMware. Secondly, you can run either your Tanzu Kubernetes Grid, that's TKG, formerly known as Essentials PKS, or your TKG Integrated or TKGI solution on the VMware environment, or any other Kubernetes environment such as OpenShift or Anthos that leverages VMware Cloud Native Storage on the VMware environments. You can protect it using PowerProtect. So technically, any distribution of Kubernetes that can leverage the VMware Cloud Native Storage can be protected using PowerProtect Data Manager. And here's the exciting part, right? So we are currently actively working on with VMware to protect guest clusters. So what that means is when you have project-specific based environments, so which allows you to create these special namespaces that allows you to run Kubernetes and virtual machines and native pods all side by side in the same namespace, you can protect them all using PowerProtect Data Manager. And this feature we are expecting to be releasing around the Q4, and we are actively engaged with VMware to protect this. So this gives you a very integrated solution. So for your IT, as your IT team is moving to project specific and you need a enterprise grade solution to protect that entire environment, you need to look no further. PowerProtect Data Manager can protect it all. Another feature that we currently have with our current PowerProtect Data Manager releases, you can protect your AWS workloads. That is, if you're running Kubernetes environments on AWS, you can protect them. We currently have DDVE currently available on AWS, and that allows you to protect all your Kubernetes environments and containers running on EBS, which is the AWS block storage, and you can protect them directly to DDVE. And the good part is that the PowerProtect Data Manager can run inside AWS, or it can be, technically it can run anywhere. It can run on your on-prem environment, it can be on another private cloud. Doesn't matter where the PowerProtect Data Manager runs, it can run and manage your entire AWS clusters from virtually anywhere. Now, this brings up to the challenges that we have. Now you have multiple Kubernetes environments. As we see, a lot of organizations today having multi-cloud solutions. If you have multiple Kubernetes environments running on-prem, maybe on VMware or on AWS or on Azure or other cloud vendors, and then you want to replicate data across all these clouds, that's a huge challenge. I mean, it reminds me of the scene from the 36th Chamber of Shaolin, one of my all-time favorite kung fu movies, and in which scene the hero has to carry huge buckets of water across a very thin, narrow bridge with knives attached to this, armpits. And that's very similar to the pain that we are currently seeing the IT teams having to move S3 buckets or like huge amounts of data across different clouds. And without an efficient deduplication, a compression, and efficient replication, you are essentially transmitting huge volumes of data across multiple clusters. So what this will do is going to cause delays in terms of hours, weeks, and months to replicate. When you're talking about petabytes, maybe terabytes of data, you'll be unable to meet the SLAs. And finally, the egress costs equivalent to the knives on the armpits, right? So they're going to cut you, and they cut your organization budget. So what you need is a very efficient solution that can help with replicating data across the cloud. And that's the challenge that we have undertaken as part of our solution. That with PowerProtect Data Manager, we are hoping to today manage your Kubernetes environments across multiple clouds. As we talked about, we can currently support vSphere. We can support AWS today. We are adding additional capability to support other clouds pretty soon. And also we are allowing the capabilities to support a diverse array of protection storage, which includes your data domain, the object store that you currently have, or data domain virtual edition, and all of this combined to allow you to replicate across sites, tier to object, and to support secondary use cases. So regardless of where your Kubernetes environment is, whether it's in the data center or the cloud or the edge, we can protect all of them and provide synchronized enterprise-grade policies, providing dedupe and compression, application consistency for a wide range of databases in the Kubernetes cluster. In addition, providing replication, cloud tiering, SLA compliance reporting, and also centralized, and most importantly, a centralized protection for not only your Kubernetes environment, but also for the VMs and apps. So all in all, this is a complete package to protect all of your enterprise needs. And here's a quick look at the architecture for how we are going to protect your Kubernetes environments on VMware, right? So with PowerProtect Data Manager, when we discover clusters, we install a couple of namespaces. So there is the Velero namespace here. Velero, again, the open source solution, currently sponsored by VMware. And when we have a PowerProtect namespace, which is our components that we have developed here at Dell. And together, we will be protecting our applications. And we take snapshots using the VMware's exclusive partnership that we have with VMware to take cloud native storage or FCD snapshots. So what this results in is you get incremental snapshots, not like full snapshots, and all of them highly deduplicated and compressed and highly efficient to move it to your backend storage. And that's easy. So now you have, instead of having huge volumes of data, you're having very small amounts of data being protected back in your protection storage, so your footprint doesn't grow. And all this data can be easily replicated and migrated across multiple clouds or wherever your digital transformation projects lead you. So I'm really excited about talking about our PowerProtect Data Manager and our product and journey. For additional details, please visit our website. And thank you for watching.
Hello, welcome to VMworld 2020, the remote edition. This is Richard Kenyon, and I am giving a presentation called Catastrophic Failure, Tales from the Trenches. I've been a vExpert for the last 3 years. I've also been for the last 3 years the Buffalo VMUG co-leader. You can reach me at Twitter and LinkedIn via the hashtag you see there. And I've been in the IT industry for about 20 years at this point in varying capacities. I used to be a web developer. I used to do some coding. I used to do some databases. I even used to do some help desk as well, which is what everybody should do at least once in their career. And I have moved up the power to be a virtualization and storage engineer at Synacor in Buffalo, New York. And I would like to give this talk and let you know one of the issues we discovered when we went to do a NetApp maintenance. So if you've ever been at a bar with your friends, you're out drinking, you start telling war stories about, what's happened to you in your career and things like that. This is my story. So first of all, here's your beer, and I'm going to give you the story of what happened, and then we're going to walk through how it actually happened and all the troubleshooting that went along with it. So to give you the point of reference, my company has a DR facility located in Dallas, Texas. The facility is completely virtualized. That runs on a storage infrastructure of NetApp. We have about 250 ESX hosts. We have a DR vCenter, and we have a development vCenter that's hosted in the data facility. One of the DIM modules in our NetApp ended up having some errors on it. So we failed over from one node to the other node, which is standard operating procedure. And in the process of doing that, the technician, which we were in communication with on site, ended up pulling out the node to replace the DIM, as one does. And as soon as he did that, the rest of our environment completely dropped and went read-only. Our first assumption was he bumped the power cord, he bumped some fiber cables, he bumped the switch cable that's in the chassis, he knocked over a circuit in the rack. He must have done something. We come to find out within about 20 minutes that he actually didn't do anything. There was a bug in the specific version of ONTAP, which is NetApp's operating system that we were running, that had a specific version of motherboard firmware, which had a specific version of network card firmware that had a bug in it that just had a loose counter. When the counter went over 1,000, it caused a kernel panic in the NetApp node that was running and dropped that one and rebooted it. And that happened all within the span of about 90 seconds. So that then caused all of our DR environment and about a quarter of our development environment to go read-only. And then when the node came back up online, it was like basically pulling the hard drives out of all of our running VMs. We had then no customer impact, which is great because it's the DR facility and development facility. And then we had to spend the next 4 hours, kind of piecing our environment back together and learning a few different things in the process. So that is the story of how that actually happened. And this is actually what happened from the point in time we realized there's a problem until the solution came to be, which was some assistance through NetApp as well as a lot of our other teams on site. I'm telling you this because everybody's been in this situation before, and sometimes having a person tell you the story of how they solved it might help you in your environment. So the first thing that we start with is, something just broke. What just went wrong? We have to figure out how it broke, what happened. So our first set of questions, once we realize there's a problem, is what can I as a virtualization and storage administrator hit right now? What's up and running? What's functional? What pieces are a problem? And that obviously is your vCenter, your storage controllers, as well as your general administration boxes. Okay, now that we can figure out what we can and can't hit, let's figure out what scope this is. What data center are we in? We're in our DR facility. What cluster? It's our administration cluster, our production/DR cluster, and our development cluster. Next question would be, if you are a service provider like my company is, the next immediate question is, which clients are down? Do you have any revenue generating events? Do you have any people that are going to be calling you asking questions? Do you have any customers who are using your client's application stack for their own purposes? And the answer to that in this case was no, nothing like that in our production facility because it's DR. The next thing that we ask is our network operations center, always has a bunch of dashboards up. They're looking at traffic for our clients. They're looking at our data center facilities. They're looking at all of the different things that they are responsible for. So we ask them in chat, hey, we're doing a storage change right now. What do you see? What is going on your end? And unfortunately, in this case, the next screen I'm going to show you is quite literally exactly what they saw. Everything broke. Literally, their entire monitoring solution got overwhelmed with as many problems as they've seen. Because if you think about it, when you have 1001 VMs automatically go read-only, each VM could have up to 60 checks, if not more, and it just overloads the monitoring facility. So our network operations center currently is a newer set of employees that doesn't have a lot of experience. And as Fry is showing you, basically they thought it was the end of the world because they had never seen their monitoring solution break like this. So that's a little bit of an added stressor into what they started to panic and have all these issues come up. And they're like, oh my God, what do I do? And I and my team had to kind of walk them through, relax. We're all here together. Let's fix what's wrong. And then we kind of told them, here's what happened. Here's what we know of at the moment. And kind of brought them back from the brink. But it was quite funny to see in chat that a bunch of people just went, everything just broke. So first we had to tell them where the stack broke. And this picture is where myself and my teammates have control of. Our storage administration team and virtualization team control the following stack. We control the data center square footage, the power. We help the networking team arrange their equipment to be delivered, installed, and then managed at the data center co-location itself. And the network in our instance consists of fiber as well as Ethernet. We then move down the stack to storage. And in our case, we have object storage systems, and we also have block and we have file storage systems. Then that ties into our server infrastructure, which are physical machines, as well as physical VMware hosts. And my team's responsibility is the VMware side of that equation. Once you move down the stack a little bit further, you hit the guest operating systems. And the guest operating systems in this case are mostly Linux CentOS and a little bit of corporate infrastructure for the Windows. When we break it into the storage side of things, this picture is exactly the hardware that broke in the data center that I am referring to. So it's sometimes rare when you can see physically what actually broke, and it helps in presentations like this, as well as having good pictures of your data center. So our NetApp system was the one that went down. The block and file side of the equation went down. Object store was a different setup, so that was fine. And the picture right there is an AFF 8080EX, and the back of the picture shows the relatively well done wiring that the technician was working with. So we can immediately see that he could have hit a power cable for the switches, which are up top. He could have accidentally knocked one of the fiber cables offline to the node he was not replacing and working on. He could have hit one of the SAS cables, or he could have hit one of the power cables to the secondary node as well. So any one of those things at the time when we first noticed an issue was our first, here's what's going on. So now we've moved to the storage. Which pieces have failed? Which volumes are down, which network interfaces are okay, and which HBAs are okay. Everything from the NetApp point of view at the time when we checked seemed to be perfectly fine. All the volumes were online, all of the cards were up, all the NICs were up, all of the volumes and pieces, everything seemed to be fine until we checked the uptime of the cluster and realized the secondary node we had failed over to had rebooted, which shouldn't have happened. So the next thing we do is say, okay, now we need to check DNS, make sure that's working, because that's usually one of the first things that we check. And DNS wasn't working. And then we move down to, okay, that's a virtual machine. Let's make sure our vCenters and our PSCs are functioning. We were at 6.5U1, and the vCenter and the PSCs were read-only. So we had to go and find those, make sure that they were doing their FSCKs and come back up. Rebooted perfectly fine, and we had network connection, and now we can start fixing our environment. In the time of about 20 minutes where we have gotten to this point, we now have our network operations center a little more calmed down. We are letting them know what's going on bit by bit. and we're feeding them information. They then ask us, as is our chain of command, do you need an incident manager? And an incident manager is responsible for communication between all of the following teams: the network operations guys, the database guys, systems administrators, email administrators, web operations portals, an internal program called VAM that we have, the storage team, myself, and then the network team as well, because all of the pieces of this data center broke. So all of these teams are going to need to have a person in charge of fixing their individual pieces. And an incident manager, while they may not necessarily be technical, always comes in with this face. They know nothing. They don't know what's going on, and their role isn't technical troubleshooting. It's being a frontline communication for all of these teams to ask a question to, so that these teams can do troubleshooting themselves. They also then report up in case this was a client impacting event. They would be responsible for communicating to the clients as well as our internal executives, who usually would start asking questions if it was a client impacting event. They are a very important piece to let the technical teams troubleshoot without getting bugged every 5 minutes. What's the status? What's going on? Why did this break? They are the front line in letting the teams that are doing the work do the work, as well as feeding the executives information they need to know, as well as the clients of the company of Synacor what they need to know. They're very good at what they do, but it's sometimes funny when they come in at 3 o'clock in the morning looking like that. So what actually broke? Here's a list of the VMs that we have. The left side is the DR facility. The right side that's expanded is the NetApp cluster that went down. So as you can see, organization is a very key part of your network and making it sure you can quickly see what broke where and how to fix it. So if we didn't have the data stores and the VMs organized like this, it would be very difficult for us to bring 1001 VMs back online after a reboot, because they went read-only, without knowing exactly where they broke and exactly which pieces went down. The right-hand side is actually especially interesting to note, is because that's actually our data stores. A lot of people don't quite realize that you can make folders for your data stores. And in this instance, if you have multiple different types of hardware, you can very quickly find out which data stores broke, because you know which hardware they're on, because you know which cluster they belong to. So this was an invaluable piece that I really hope a lot of virtual administrators utilize, and it makes for a very well laid out plan for day-to-day maintenance, as well as you can kind of see what things lie in different places. As I said, we had about 1001 VMs go read-only, which means we now need to bring them back online with a set of reboots. And because vCenter is as it is, sometimes it's hard to make a large change like that. So we ended up doing a PowerShell script at the time I didn't know existed. You can actually do open VMRC, and it ends up giving you a quite wonderful screen of things that look like this. So you can bring up on your 50-inch monitors all of the VMs that you've rebooted and watch them reboot to make sure that they are FSCKing properly, and bring them back up to functioning states. And every so often, you might have one that just gets stuck, and you can easily pinpoint it by having a screen that looks like this. You can also open a web console with PowerCLI, but I found doing the Open VMRC a little bit easier, because it sets, in Windows at least, a taskbar group for things that you can cascade, you can stack side by side, or in our case, you can just tile and watch them all come up at once. We broke it apart by doing our email infrastructure for the DR side into groups. So we did like SMTP servers, we did POP servers, we did migration servers, and we did our LDAP controllers all in separate groups so we can watch the bits and pieces come up. We also obviously brought up our DNS, our corporate LDAP, our corporate Active Directory, our corporate domain controllers up in the same way. It just helps if you group them all together, which, as I said in the previous screen, you can see on the left where those pieces reside so you can script against them. So now that we have our environment back up and running after a few hours, we can figure out what actually happened. And in this instance, NetApp jumped on immediately because we opened up a P1 case with them as well as we had a early case open to saying, hey, we're doing some maintenance. So they immediately called us and went, this is something you should never see, is an emergency root volume not working properly when the nodes came back up. So they actually, to their credit, it's one of the reasons I enjoy working with the NetApp hardware, they called us immediately and said, hey, what's going on? How can we help you? What broke? We filled them in. We gave them a VDI to make sure that they had WebEx into the environment, and they started working and looking at how they can help us while we were bringing up our environment on the other side of that screen. They waited for about 4 hours. They did their research, they did their logs, and they found out that, as I had mentioned earlier, we had a strange issue of firmware versions on top of your OS versions being kind of funky. They said that this can be fixed with a workaround, which we then did. I'll show you that in a minute. And then they said that they also wanted to check our other prod facility and make sure that wasn't impacted. And it was to be fixed at a later date. So we now know that we had to fix that. So they were very, very helpful in working with us and being there when we needed them. And so we had, So we had the DIM, we had the panic, we had the root vol issue when it came back up, and NetApp did a quick give back once they did the thing. And here is the actual item that is the problem. The counter on the membership report sent, in our case, was above 1,000. And then our production facility, one node was affected and one node was not for further RCA. So that is the horror story that we have of an entire DR facility going down and being brought back up within 4 hours. If you have any questions, comments, or concerns, I hope you enjoyed your beer over my story, and I can be reached at the following information. So thank you very much, and enjoy the rest of VMworld.
Hi, this is Milind Halpet, Global Cloud Practice Vice President with vTechTalks. And today we are going to talk about how do we provide a consistent experience from cloud to edge with boundaryless data protection solutions. Next slide, please. So when we look at the cloud trends, the reality today is, the cloud spends are going to go from 260 billion per year to almost 927 billion per year. At the same time, we see enterprises embarking on the digital transformation journey, and the adoption of cloud across enterprises are accelerating. And this actually points to one outcome. The volume of data that is getting generated in the enterprises are skyrocketing, whether we look at data that is structured or unstructured. And at the same time, organizations are going through certain challenges. IT needs to do more with less resources. And at the same time, data protection is at the center of the entire transformation. Anything with respect to the data protection issues that may lead to revenue loss, it may lead to brand problems. So it is actually a critical problem for any enterprise to solve. And when we look at some of the common investment priorities, in fact, data protection is the number one priority across the enterprises. Enterprise needs to manage the data lifecycle management all the way from the backup, retention, disaster recovery, archival, and long-time retentions. So with this backdrop, I would like to move to the next slide where we'll deep dive a little bit into the solutions. Just a little bit of background about our partnership. Wipro, Dell, and VMware have a solid partnership going on for decades. With a very rich system integration, transformation, and managed services experience, Wipro has been innovating in the market along with the Dell to release the cutting-edge solutions to the market, along with VMware as well. These solutions actually span across data center to cloud to edge and to the end-user devices. And some of the most important considerations while we talk about the solution sets is, do our solutions offer lower cost and high value? Does that actually integrate with the other ecosystems within the enterprise? How automation becomes an important tenet of the solution? And finally, these solutions have to work seamlessly. So are our solutions service assured? And are they trusted solutions backed by VMware as well as Dell? So with this, let's go to the next slide. So to solve these kinds of problems within the enterprise, we have a platform, what we call as the boundaryless enterprise, or the BLE. There are multiple components within the BLE. It has a hybrid IT fabric. It has got the engine to manage the modern application development using the Kubernetes ecosystem, as well as it has to be blended into the entire data management strategy, and protection needs to be looked upon in a holistic fashion. From an application perspective, we know that applications are now moving away from the traditional monolithic applications into digital applications. Then there are COTS applications within the enterprises, and these applications are spread across, integrated infrastructures. Converged. Most of the applications are now running on speed, immediate backup and recovery options. At the same time, organizations are trying to cut the cost by using cloud as a backup option, long-term retention options. So these use cases will have to come together, and a single pane of glass is important to orchestrate these use cases in a seamless fashion. And when we talk about these solutions, the solution has to be scalable. It has to have a high level of cloud performance. And at the same time, it has to protect all kinds of enterprise-grade data protection services. At the same time, we know that organizations are embarking on a new journey where they're innovating on the digital applications using Kubernetes, VMware Tanzu, and some of these related technologies. So the good part of this entire solution is it works for the digital native application landscape as well. We can protect data that is coming out from the Kubernetes ecosystem. And at the same time, the cloud native architecture that we are talking here, it supports the entire Kubernetes community. So the key message here is we can actually look at backing up the Kubernetes clusters and the persistent volumes. That is the part for the digital workloads data protection. At the same time, it manages the traditional data protection, the ones which are running in IaaS data protection. So basically, it brings all kinds of data lifecycle management across clouds, across deployment models, and heterogeneous applications into a single pane of glass. And that is the power of the partnership that we are talking here. With this, I'll move to the next slide. What are the customer benefits? End of the day, when customers are embarking on the digital transformation journey, innovation is the key requirement. While organizations are trying to innovate and get into a next generation business model, trying to create a competitive advantage and opening a new digital channel for the business, the time to market and time to innovate is of supreme importance. The second one, enterprises do not have a lot of funds available to drive this transformation. So always there is a push to reduce the run spend and champion the change fund. The third component here is architecture really matters. How can we simplify this architecture? The complexity that I talked about, multiple clouds, multiple deployment models, different application patterns, and data protection is one common denominator that has to connect all these models together and protect the data and make sure that replication, snapshotting, the long-term retentions, the policies, everything works according to the enterprise standards. The last but not the least, compliance and making sure that we are creating a flexible consumption model, which is very transparent for enterprises. And the entire 4 pillars of this benefits has to be very simple. It has to be consistent operations, which can abstract the complexity while there is technology underpinnings below that. So these are the boundaryless data protection is one. Round off by mentioning this architecture and are committed to drive enterprise transformation.
Hi there. In today's session, let's discuss about Dell Technologies cloud storage solutions for VMware-based workloads. On the surface, transformation to cloud appears as if customers are transforming towards simplicity. Cloud offers enormous flexibility and scale. They also offer agility, and with all the wide next-generation applications available in cloud, innovation is what customers look at as they move to cloud. Cloud also offers pay-by-the-drip consumption model, which makes the offer even more sweet. Sophisticated cloud models have always included on-premise element associated with it. And as far as on-premise element is concerned, repatriation appears to be a real thing. As per the recent reports from IDC and ESG, majority of customers have on-premise data centers as an inclusive element as part of cloud strategy. With all these data points, it's clear that cloud is not a destination, it's not a one-size-that-fits-all model, but it requires an operating model that requires thoughtful consideration for effective implementation. Let's take a look at some of the use cases that enterprise customers implement as part of the cloud journey. Customers would typically want to take their on-premises environment to the cloud, which means they would have to extend their data centers to cloud and expect the same levels of operational consistency. Customers would also want to set up disaster recovery solutions for their on-premise environment and expect to have the same level of operational consistency again when they switch to the cloud. Organizations can also look at migrating certain enterprise applications to the cloud without doing any refactoring or rework associated to it. For effective implementation of cloud strategy, it requires customers to have a flexible dev test environment to ensure that data can be moved back and forth as part of development experience. Customers will also look to scale up and down effectively in minutes to ensure that they can effectively implement strategies around cloud. With all the use cases that we mentioned, let's also take a look at some of the complexities associated with it. Organizations typically would look at having multiple clouds as part of their strategy. In fact, as part of IDC's report, 83% of customers look to have multiple cloud strategies. When we talk about multiple cloud strategies, it could either be a combination of public cloud or a private cloud, or it could be a combination of multiple public clouds. In either scenarios, every cloud offers its own management tools. So what this would actually mean is customers are dealing with disparate management solutions. When you have disparate management solutions, operations becomes a serious complex issue that customers would have to deal with. It has the potential to slow down operations if customers have to deal with multiple systems. Not only that, but customers would also need to have resources tagged onto different clouds, which makes migration of resources from one cloud to another cloud a real task. Customers would have to ensure that they would have to refactor applications as they migrate resources from one cloud to another cloud. When you have multiple clouds associated with it, it requires organizations to train the right set of folks with the right tools and processes associated with cloud. Last but not least, there is a security angle to it. Cloud in general is very open. It requires customers to ensure that they have the right level of security understanding as they migrate resources from one cloud to another, or migrating resources from their on-premises environment into the cloud. To ensure all these complexities are addressed, Dell Technologies introduced cloud storage solutions. Dell Technologies Cloud Storage Solutions not only addresses all these complexities in an effective manner, but also ensures services that we launched as part of this solution. One is multi-cloud connections to VMware Cloud on AWS. This service, imagine, this service provides customers with the flexibility of subscribing to store choice, and it also provides the flexibility to natively replicate using the native replication technologies that the array provides. Let's go deeper into our solution. With Dell Technologies Cloud Solution for Multi-Cloud, customers have the option to expand into any cloud of choice. They can expand their on-premises environment, they can replicate, or they can migrate their resources into multi-cloud and present it to any cloud of choice. They can present the same resource to multiple clouds at the same time, truly leveraging the flexibility that our solution provides. It is 100% data consistent, and it is available all the time, so customers would not have to worry about the lack of availability zones. With our solution, you could also have automated disaster recovery. You could leverage on the tools that VMware provides. It could either be VMware Site Recovery, or you could also leverage on the native replication technologies. Last but not least, you can also integrate with multiple applications that various clouds provide, and you could operate on that with the data that we present to multiple clouds. So there is enormous freedom with the way you could operate. So with VMware Cloud on AWS, we truly provide one cloud experience with consistency and choice. You can migrate or replicate your data seamlessly from your on-premises environment to cloud, either using vSphere replication or array-based replication. You could move your data back and forth without any egress or ingress charges. And since you replicate your data with on-premise from your on-premise environment into cloud with array-based replications, you can maintain the same levels of application consistency. And there are no additional technology complexities associated with this. You can also tag compute as and when you need it, which means you can actually keep your operational costs really low. So it's a truly cost-effective solution that we present to you. Moving on, disaster recovery solutions with VMware Cloud and AWS is our other service, wherein customers can set up DR solutions for their on-premises environment into cloud. You could again replicate your data using either vSphere replication or array-based replication. And this solution is completely automated. So you could have very low levels of RTOs and RPOs. So you could set up disaster recovery solutions for high-performance compute kind of workloads. And you can maintain the same levels of operational consistency that you would have as you have in your on-premises environment. So with Dell Technologies Cloud, you can make the cloud work for you. We have solutions for multi-cloud, for disaster recovery solutions, and we are very tightly integrated with VMware Cloud on AWS. So do check us out on our webpage, that is Dell Technologies Cloud Storage for Multi-Cloud. We do have resources, we have videos, white papers, and interactive demos. And if you're interested, we could further discuss about it. Thank you.
everyone. everyone. Thank you for joining. My name is Jason Bakke. I'm a storage development principal engineer with Dell EMC. I've been with the company about 9.5 years. In this session, I'm actually going to talk about and actually demonstrate the migration of VMware's vCloud Director from a traditional Linux cell with an external Microsoft SQL Server database to the embedded Postgres SQL database within a vCloud Director 9.7 appliance. A little background information on this environment that I'm using for the demonstration. This is an environment I built for our technical marketing group about 9 years ago. I deployed it. I've been maintaining it over the years, upgrading it. And like many VMware products, early on, we used a Microsoft SQL Server database backend. And so I've been using this, it's actually on SQL Server 2016 today. But what's important to note is as of VMware vCloud Director 9.7, support for the SQL Server backend database externally, that goes away. So we need to shift this environment to PostgreSQL with the embedded vCloud Director 9.7 appliance. So I'm actually going to perform both of those steps in one shot here. The migration to the appliance off the, I think it's a CentOS cell that I'm using today, as well as embedded PostgreSQL. It's actually not as complicated as it might sound. I've actually been through these types of migrations 3 different times, and this is the 4th migration that I'm performing. You simply follow VMware's documentation. The documentation is very well laid out, and it boils down to 4 major steps. And you can see those on the screen on the presentation display here. Step 1 or stage 1 is upgrade the existing environment to vCloud Director 9.7. That's important because VMware wants us to be on the same exact version for the existing cell when we make that jump to the new appliance. So the second stage is to deploy the new vCloud Director 9.7 appliance. The third stage is to migrate the SQL backend database to PostgreSQL. And then the last step or last stage is to copy any shared transfer service data, which we will do. And optionally, if you use certificates beyond just the self-signed certificates, we need to migrate those as well. I do not demonstrate the certificate migration in this video, although that is a fairly easy and well-documented step. So we're going to go into the lab demonstration now, and we're actually going to watch this migration and deployment take place. So again, the first stage is to upgrade our existing environment to vCloud Director 9.7. Now, in the interest of time, I have a 15-minute presentation slot here. I've already actually gone ahead and upgraded my existing cell. I've been through these upgrades many times over the years. You've probably been through the upgrades. Here, I'm just going to go and verify that we're on version 9.7, which is going to be the version of the appliance that we're going to migrate to. I'm also going to just kind of float around, spend about 30 seconds here, just checking the health, make sure that my vApps are up and running. There's no error messages. We get a couple different looks here at the vApps that are deployed. And those are the types things that I want to see when we're done with the migration. Here I'm going to use an application called Dell EMC Replay Manager. I want to make sure that I have a good snapshot or backup before we go through the migration. So I use Replay Manager. As you can see, we're quiescing the virtual machines that I'm using as a backup. So I have a point-in-time backup of not only the vCloud Director 9.7 cell, I also have a backup in a application and data consistent snapshot of the SQL database. And here you can see, using the Dell EMC plugin, I can verify that I've actually just taken a snapshot of both in their application and data consistent. Stage 2, we're going to deploy the new vCloud Director appliance. Now, before I do that, You'll see in the documentation steps that VMware has, and I'll post the link at the end of the video here. We need to create a new NFS share for the vCloud Director shared transfer service data. For this particular environment, I'm actually using a Windows NFS share. So I'm creating a new share here, allowing no root squash for that share, which is important. Click apply, okay. And we'll actually go back and revisit this screen a little later after the deployment and verify that the vCloud Director, the new vCloud Director cell has actually written the information into there. It's very important that that shared transfer space is working properly for the health and well-being of the vCloud Director environment. Now I'm going to open up a web browser and we're going to go ahead and deploy the vCloud Director 9.7 appliance. Okay, so I used some time compression here. I think I used 8x. This is simply the deployment of an OVF appliance, and this step actually takes about, I want to say, 10 minutes or so, not only to fill out all the information, but for the completion of the deployment, as well as we're going to actually power on the vCloud Director cell, watch that boot up, and then we'll pick up where that leaves off. But I'll show it all here. You can see I'm not skipping anything important. So our vCloud Director cell has now deployed. The first thing we need to do now is to power it on, and I'm going to open up a web console and just kind of watch the boot up sequence. You will see a couple of error messages there. That's quite normal. But it's going to, upon first boot, it's going to run some post-deployment scripts or installation scripts based on the information that we provided in the deployment of the OVF. And again, I use time compression here because it's not a good use of time to sit and watch that. I wouldn't be able to finish this video within 15 minutes. So you can see our cell has deployed. We're at that blue screen at the end. That signifies that we're done. And we can now actually open a web browser and go to the vCloud Director provider page. And I'm doing that now. So we're going to log in for the first time as administrator. There's no other accounts linked to this provider instance. We've provided really no configuration, and we've not imported any configuration from our previous vCloud Director cell. So this deployment is happening in parallel, and then in the third and fourth steps, we'll migrate over the database and bring over the configuration data. So you can see just by looking at the screen here, this is an empty, unpopulated cell waiting for configuration. I'm going to actually SSH as root into the new cell. And the first thing we're going to do, again, I'm following VMware's documentation, very good documentation on these steps. We're going to stop the vCloud Director service. First, we'll check the status, but we will end up stopping those. I'm getting ahead of myself. We're checking the status of vPostgreSQL. And now I'm going to tail the cell.log. Really what I'm looking for here is just to look at performing some health checks of the new cell that I deployed, making sure there's no abnormalities or errors. Because if there are, we want to stop and correct those errors before we continue. Now we can see, now I'm actually looking at the NFS server, and we can see that the new cell has populated information into that shared transfer service. That verifies that my NFS mount is working correctly. We have no permissions issues. Okay, I'm going to log into now as root into port 5480 and check PostgreSQL health, and that looked good. Stage 3 is going to be migrating the SQL database. So now we've got two cells, the old, what I'll call the old cell or the existing cell, running side by side with the new vCloud Director appliance. So I'm going to log into or SSH into the both cells. The old cell or the existing cell will be in the upper left corner. The new cell is going to be in the lower right, and we'll do a little bit of work in each of those cells to perform the database migration. So this is the portion where we're going to stop the vCloud Director service or daemon on both cells. Use the same command on both. And now we're going to continue our work in the new cell. Now, according to the instructions, we need to perform or actually create an allow rule on the Postgres database to allow external traffic in the form of the database migration that we're going to perform. We do that by creating this text file, okay? And we provide the IP address and the account and group that we want to have access to the Postgres database on the new cell. I've done that using VI. I've verified with a cat command that that new file and information was populated. What that does in turn is actually populates yet another file under var VMware with that allow rule information. So now that allows us to go back to our old cell, and we're going to perform the database migration. It's you can see the command in there. We're telling the cell to migrate the database using the cell management tool to the new vPostgres SQL database, listening on IP address 188.144.114, or sorry, 14. There's a password in there that I've pixelated out. And this process actually doesn't take very long. It could vary based on the size of the environment, but when it's done, what we're looking for is data migration succeeded, a success, 0 failures, 0 skips. Again, if you see anything other than that, probably stop, reattempt the migration. So the last stage, or last step, is to migrate the shared data information. So we're going to copy over some files from the old environment to the new environment. And aside from the SQL database that we just migrated, these, I think it's 5 files. These 5 files hold the configuration of the vCloud Director environment. We're actually going to use these files once we copy them over to perform an unattended or scripted installation of vCloud Director in that new environment. So you can see we've copied over global.properties, response.properties, certificates, proxy certificates, and trust store over to the new cell. Okay. And once we're done with that, these files will be used for that unattended installation. Now, because of the nature and the security implications around using the SCP command, I have to provide the root password for each of the 5 files that I'm copying over. Okay, so this is where we're actually running the unattended installation using those files. This is the opt VMware vCloud Director bin configure command with a whole bunch of switches. And again, the documentation provides those switches, but this imports the remaining configuration data into the new vCloud Director cell appliance. So now we're going to start the vCloud Director service on the new cell, and I'm actually going to tail the cell.log file and watch for any errors or abnormalities here. And once this is 100% completed and we don't see this file continuing to write, that's a good indicator that the cell daemons are now started, and we can actually log in with a web browser and perform a quick health check and verify that all of our vApps have been migrated and the health of the database is intact. And we're just about there. And cell startup is complete. Took 59 seconds. It actually takes longer to start up the cell than it does to migrate the data. So now we're going to log in to the provider console of the new cell. I'm going to use the administrator account here, but at this point, my other domain connected accounts should exist because they were copied over as part of the configuration. Now we can see, and there they are. There's the 3 users that I have imported. And we can see I've got it pixelated out, but our license file has been migrated over as well as part of the configuration. And there's our tenant, TechSol, and there are all of our vApps are now populated in the new cell by way of the database migration. And we can look at just another view here in the My Cloud view. See our various vApps and the VMs within those vApps. We've got a couple steps left here. I'm going to take a look at the vCenters here, and you can see that our NSX manager on the right-hand side has been carried over. That's also important for the deployment of VMs. One of the last steps we want to perform is we need to delete the old cloud cell. And that's quite simple. Right-click, choose delete. So now the only cell we have left in there is the single cell of our new deployment. Now we're going to power off the old cell, and we're going to delete it. Remember, we took a snapshot or a backup of this, so if at any point in time something went sideways here, we have a good rollback point and we can fix and reattempt. I've pixelated out some of our VM names here in this environment, but you can see we're looking at VCD cell 2, and we are complete at that point. So I showed all of the steps. I didn't skip anything. I did use time compression on some of them in the interest of time, but following the detailed documentation, it's not a complex procedure. Just make sure you have some form of backup. Use array-based snapshots if you can. I would also recommend using quiescence if you're going to snapshot your SQL database and your cloud cells while they're online. If you do not have the ability to quiesce the data to get app and data consistent snapshots, one method you could do is request an outage from your tenant and shut down both the SQL server and the old cell, and then take a snapshot that way. Then you're sure that we've lost no data in flight, then power them back on. That's the end of the presentation. I'm going to leave you with links to two documentation resources. They both point to the steps required that I followed to perform this migration. One is simply the online documentation on the top. If you prefer reading PDFs or printing out PDFs, there's the vCloud Director 9.7 installation guide on the bottom. Skip right to page 115, and it's really, I think it's about 3 or 4 pages, not even 4, to follow these steps. But you follow these steps and you'll be successful, and you'll have your migration completed. And at this point in time going forward, you will be off SQL Server and you'll be in your new embedded vPostgres SQL environment. Thank you all for joining, and I wish you all a wonderful VMworld.
Hello, everybody. My name is David Klebanov. I'm with a company called Alkira. And today we're going to talk about a pretty exciting topic. We're going to talk about networking. Like, when was the last time that networking was exciting, right? But today we're going to make it exciting. And what we're going to do, we're going to talk about networking, not just networking in general, but we're going to focus on networking in the context of a cloud. Like, what does happen to networking when the cloud era hits? And specifically, our agenda is going to be around three individual topics. We're going to recap the different options that exist today for cloud networking. We're going to talk about what are the challenges around cloud networking today, how are these challenges being mitigated. So spend some time talking about that, but then really talk about the Alkira solution and see what we bring to the market with what we call an Alkira Cloud Services Exchange, which is really focused on solving this networking and other issues for the cloud era. And at the end, I'm going to give you a bit of a glimpse on a couple of deployment use cases or main deployment use cases that that this technology can be applied to. So let's play out an interesting scenario in here. So think about this three personas that you see on the bottom of the screen. And in fact, these are the two categories of personas. The first category of the persona is the networking and security person, right? This is the traditional infrastructure, IT personnel dealing with all the networking and security aspects of the infrastructure. And then next to it, you have the cloud architects, the cloud administrators, and the application developers. So these are the folks who are dealing with directly with the cloud aspects of it, from the compute standpoint, from the storage standpoint, from the application standpoint. And now look at the collection of these clouds, right? Now, some of these clouds are familiar to us as an infrastructure as a service clouds, which are the three main ones for AWS, Microsoft Azure, and Google Cloud Platform, the GCP. Right, but we also have the SaaS offerings, and there's quite a few applications that really kind of a part of that software as a service offering. But some of the most prominent ones are Office 365, Salesforce, Box, Dropbox, all kind of software as a service applications. And then, of course, we have the internet applications, which are more of a generic in nature. So when we see, from the persona standpoint, when we see the cloud folks, how do they perceive these clouds? They're really enjoying the day, right? These clouds were built for compute, storage, application, microservices in mind, and really cater to the needs of the cloud folks. And if you think about some of the key attributes that are really playing very well in that space, are the time to service, the agility around time to service, the ability to do on-demand capability delivery, right? The as-a-service consumption, which is extremely important element that we're going to come back and circle to a couple of times. And then the ability to do scale up and scale down for the infrastructure. Now, these are all great. At the same time, when you look at what happens to the network and security aspects when it pertains to the cloud, you can see the plethora of challenges that network and security architects and engineers are facing around scalability and the expertise that are required, and security and visibility and over provisioning. So quite a few challenges that these folks are facing. So how is the industry coping with this? What are the several sort of solutions that exist on the market today that allow the networking folks and the security folks to try and address the networking needs for the cloud? So the first one that we're seeing quite a lot is the use of the co-locations, right? It's a very proven, very solid model. However, it comes with certain drawbacks. Many times co-location deployments carry a high provisioning cost, right? A complexity of provisioning, because many times they are anchored on a physically deployed gear, physically deployed equipment, right? Routing between different regions of the same cloud or across multiple clouds becomes very cumbersome, because the traffic needs to be extracted from the cloud to swing through the co-locations, especially if network services such as firewalls are deployed in those locations. So the suboptimality of routing is something that strikes the tone with the co-locations. The second approach that we're seeing is a cloud-native approach, where organizations are leveraging the cloud-native capabilities of the three major clouds, the AWS, Azure, and GCP, in order to deliver these networking capabilities. So some of the drawbacks we're seeing is that it's really dependent on the cloud provider. Every cloud provider addresses this differently. So every solution that is built on top of these clouds in a cloud native fashion is very specifically tailored for that cloud. Lack of expertise from the networking and security folks becomes very, very challenging because, again, the clouds have been built with compute storage application in mind, not quite with networking and enterprise-grade networking in mind. And when you figure this all out and you somehow deploy this, you are hitting quite a lot of restrictive cloud limits, especially for networking and security, because these clouds were really not, like I said, were not envisioned to be built with networking, security, visibility, and other elements inside. Now, the third one that we're seeing is the do-it-yourself approach to cloud networking. This is where the organizations are leveraging either automation, orchestration, or provisioning tools in order to automate some of those tasks that would otherwise be done in sort of mundane manual fashion. Doing this, using this automation, orchestration, provisioning tools, still in a do-it-yourself fashion, but a little bit more sort of elegant. Now, those obviously provide an evolution over the previous methods, but yet they also carry a certain degree of suboptimality regarding learning curve around those tools, the disruptive nature of deploying those solutions because of the need to download software into your existing cloud environments, and to some degree, a large failure domains that are created by the fact that these do-it-yourself networks really span multiple clouds without any means to constrain problems, routing-related problems that could arise from human errors, misconfigurations, or things like that. So when we think why these problems exist, the thing that really strikes the tone is that the cloud and the network really operate based on different characteristics. When you look at the clouds, you really see the clouds operating on the level of principles, on the intent-based approach, while the network is operating on the level of primitives, which is really understanding these nitty-gritty details and all of these nut and bolts that need to be sort of operated in order to build the network solution for the cloud. Now, where we really want to transition is really want to bring the network philosophy and the way of thinking closer to the way the clouds operate, and by doing that, we really empower the network to behave like the cloud and have those cloud-like attributes, and that is going to create this cohesiveness between the cloud and the network, and is going to allow the network to really deliver on the cloud promise. Now, let's look really quick on the Alkira offering in this space and how we are mitigating some of the shortcomings that we talked about prior to that. So the service that we are offering is called an Alkira Cloud Services Exchange. It's a solution. It's anchored on what we call an Alkira Unified Network Platform, which is a foundation for an entire solution. It comprises of a collection of what we call an Alkira Cloud Exchange points, which are, think about those as a virtualized cloud, multi-cloud points of presence. These are not hardware-based. These are not VNFs. This is a completely autonomous software stack that is deployed on top of the hyperscale infrastructure and really allows the organizations to bring the resources, be those single cloud resources, multi-cloud resources, on-premise resources, users, SD-WAN fabrics, whatever lives on-prem, into this unified network platform through the connectivity through this Alkira Cloud Exchange points. Now, if we think about some of the key attributes that come with that type of approach, is an ability to completely design your network using a digital design canvas. Basically, draw your network on the design canvas to express your intent, and then click a button to implement or provision that intent onto the actual virtual infrastructure. The ability to insert network services such as firewalls, load balancers, DNS, DHCP, IP address management systems, and others into this network, leveraging this digital design canvas, and then using the intent-based policies in order to steer the traffic. Now, the elements around segmentation, encryption, which are the security aspects, the day-to operations around visibility and governance for this network. And again, at the end is the chargeback billing elements of the solution in order to really kind of have a deep understanding of what are the resources that are being consumed and pay only for the resources that are being consumed as part of the solution. Now, the three really key things that I wanted to kind of leave you with on this slide is a delivery of this entire solution as a service, which is a very very sort of significant contrast to the do-it-yourself approach that we talked about previously. The ability to provision everything in a single click using the digital design canvas and the integrated network services marketplace, and the ability for this entire intent to be provisioned on top of the infrastructure and really be ready for use in minutes. So these are the three things I really wanted you to leave with this, from the understanding of the solution. Now, let's quickly look at three popular use cases that we're seeing being deployed out there. The first one is pure networking use case, right? And you can think about this as an end-to-end cloud or multi-cloud networking use case where you have multitude of cloud workloads from various clouds that are being connected into this cohesive network infrastructure. Right. So we're talking about multi-region or multi-cloud in some cases, multi-account in cases where you have different departments that are leveraging different sort of credentials to access their workloads. So all of that is being cohesively brought into the Cloud Services Exchange solution. The ability to provide an end-to-end segmentation across these multiple workloads and micro-segmentation to sub-segment certain workloads within a segment, right? The ability to do a global route propagation within this segment, so keeping the segmentation end-to-end, yet providing the global route distribution and route propagation across the regions, across the clouds, be that within a single cloud exchange point or be that across multiple cloud exchange point really on a global scale. Now, the sizing of those cloud resources and the ability of the network to really accommodate the sizing of these workloads as required. So when sort of a compute administrator deploys a workload that requires large or extra large capacity, a network can play along with it and provide the connectivity that accommodates those needs from the compute standpoint. And as I mentioned earlier, the ability to really just pay for the services that are being consumed in form of billing or perform a chargeback to the organizational units that are consuming those resources, so IT does not really become a single bearer of the financial responsibility for the deployed solution. The second use case that we're seeing a lot is the use case around stateful security. So as these applications move into the clouds, we're really seeing the need for the security to be extended into the clouds and really maintain the same security posture that existed for these applications where they were on-prem, and maintain this posture when now these applications reside in the cloud. Now, I'm giving here an example of the Palo Alto Networks firewall, right, and how firewalls being deployed within the Alkira Cloud Services Exchange with auto-scalability to accommodate an increased and shrinking demand for capacity, and the ability to do firewall zoning in order to segregate different resources, be those in on-prem resources, sites, users, SD-WAN fabrics or whatnot, cloud resources, AWS, Azure, GCP, but also in external resources such as extranet connectivity through mergers and acquisitions, partners, or just a plain internet-based resources. And all of these are just mapping into this zone-based approach inside these firewalls that are deployed within the Cloud Services Exchange. So really the ability to bring that stateful security from not just an on-prem data center applications, but all the way into the cloud applications. And lastly is the use case around operational visibility for network and security. Now, obviously, when you deploy networks, you have to make sure that operational elements, visibility elements are accommodated. And here, there's a really multitude of different visibility, troubleshooting, health, visibility elements around networking, security, and the entire operations of the environment. Now, I know this was quick, just to give you guys a bit of a sample of what we do and how we solve these cloud networking challenges. If you want to learn more, we invite you to go to www.alkira.com, watch videos, read briefs, schedule demos, and take the next step in that networking journey for the cloud. With that, I wanted to thank you and wish everybody a pleasant day.
Hi, everyone. Welcome to this TED Talk, The Next Frontier, Deploying Object Storage with VMware Cloud Foundation. I'm Lawrence Chu from Dell EMC, and here's my cohort, Gopala, from VMware.
Thanks, Lawrence. Hi, everyone. Welcome to our talk. This is Gopala. I'm the product manager in VMware, focusing on stateful services and cloud-native storage. All right, so before we delve into the work that we are doing together, Dell and VMware on object storage, I would like to motivate the problem a little bit by talking about why we are building this platform and why we are integrating object stores on vSphere. What we're seeing is applications in the customer enterprises are changing. The applications that were consisting of a few VMs, depended on a few databases, were mostly easier to manage in the traditional space, are now becoming more complicated applications wherein you have not just one database, but these applications depend on a variety of stateful services, right? So object stores are the centerpiece of these stateful services and have become the de facto storage platform for these modern applications that are Kubernetes based, that use containers, that use all of these newer mechanisms like functions, etc. Object stores have become almost the de facto standard for storage for such modern applications. The reason we are seeing the shift is that developers no longer depend on a ticket-based system like they used to before for their storage needs. Rather, they use self-service S3 endpoints for their storage needs, and they directly deploy their stateful volumes and persistence over these object stores. So object stores are also very flexible in the sense that they will service big data applications, analytics applications, as well as regular test dev applications that need ephemeral storage. So object stores come up as a very compelling use case for our modern applications in the enterprise. Likewise, we also see several other applications like MongoDB, Cassandra, and other modern databases, Redis, Kafka, and such other stateful services to suit these modern applications requirements in the enterprise. So, not just the nature of these applications is changing. We're also seeing a huge increase in the number of such modern applications coming to the enterprise. So you're seeing some of the statistics on the screen here. We are seeing that for the first time, the line of business is spending more on IT because they are seeing a huge increase in the number of applications that are coming in. And also by certain estimates, we will see around 500 million applications in the next few years, right? So enterprises are spending a lot of time in developing these applications, and VMware wants to make it as efficient and seamless for these enterprises to build applications. And that is the reason we have acquired a few strategic companies, as well as in organically investing in building the support within VMware. So what we are introducing today is the data persistence platform on vSAN, which is essentially a platform and a framework which we offer where the ecosystem partners like Dell EMC can bring in their modern stateful services like object stores, and together this integrated platform and the service layer offer that simplified operational model, right? We offer developers that self-service, automated service deployment, cloud consumption, etc. on vSphere and vSAN, while we are providing a lot of simplified operations and management for our vSphere administrators, right? So they get that simplified operations, integrated monitoring, and we are also introducing the vSAN direct configuration, which is allowing customers to go directly to the underlying bare metal devices that are attached directly to vSphere ESXi nodes to get that cost optimization and storage efficiency from these underlying storage. So in a nutshell, with this platform and the integrated services, our customers will be able to run these modern stateful applications like object stores with lower TCO. They get better bang for the buck from their storage. They're able to get their developers to innovate much faster, develop applications much sooner, and become more agile. And overall, their management and deployment becomes much simplified for their vSphere administrators while they're operating object stores and other stateful services on this platform. So I will hand it off to Lawrence now. I'll stop sharing and he will share his screen.
Thank you, Gopala. I'm Lawrence Chu, product manager of the Dell EMC object storage product line. So the reason for S3 compatible object storage, as you heard, really lie in the transformation of how applications are developed. Right now, we are now in a day and age where we have software-defined data center, and with Cloud Foundation, application users can quickly get access to an infrastructure, lifecycle management, and all the other automated service out there. But what about storage? What you're going to need is a reliable storage. What you're going to need is a reliable storage that simplifies how you access and then scale those storage infinitely. S3 compatible object storage such as the Dell EMC ECS, and object scale is such a target, right? Object storage is born of the belief that HTTP is the most ubiquitous protocol and that practically unlimited global scaling is required to support next generation of application growth. Without worries about like mounting shares, fiber channels, or other such details, object storage is the one that can give you the simple flexibility, hybrid cloud compatibility, and they also DevOps friendly. By the simple action of provisioning a bucket, you're ready to start. We're now introducing the Object Scale Early Access Platform. It is a simple S3 compatible object storage. It is Kubernetes based. It's a scale out software defined product, and it's also multi-cloud ready. Dell EMC Object Scale Early Access is defined as a pre-general availability beta program for organization to test object scale code base in your environment. And you can use it on many such existing environments. So how does it work? With vSAN and now with Data Persistence Platform, you can provision persistent volume and management of multiple of these storage services. So Object Scale builds on top, of this, vSAN and Persistent Volume Foundation. So, and then we add our own internal databases, data protections, and many other storage-specific features to give you a true scale-up architecture. And with these container services running on vSphere, the result is scalable storage that's easily manageable, configurable, and scalable. Now, when you build application storage, it's exceedingly simple. So with objects, and in enterprise object everywhere, your applications everywhere can run object storage. This object storage is available, everywhere that vSAN persistent data platform and Cloud Foundation would operate. And with software defined, you can accelerate your development, because you don't have to pre-provision a dedicated appliance, which you typically only use none of it on day one. And you can spin up as much or as little storage as you want in your internal cloud environment. And lastly, it offers the same VMware experience. Use the same tools that you know and love. Now let's drill down a little bit into more of the benefits. After all is done with provisioning, then you can grow this storage as you need it, right? So Dell EMC, storage with either ECS or object scale enables you to have like cloud scale, built with a scaled out, geo-distributed architecture, so you can keep pace with the capacity demands, wherever your data center resides. You can have global accessibility. You can stand up, remove, add capacity for object scale wherever vSAN data persistent platform runs, right? So edge or in the cloud, right? Have your storage easily co-locate where your application runs. It's your choice. And you can utilize, existing resources, deploy on existing pool of virtualized infrastructure. You can secure, you can stay assured of the security and compliance, with what we have, such as data at rest encryptions, erasure encoding, and all such data protection schemes that we have, it allows you to have peace of mind. And lastly, it's enterprise proven, right? We are the same team that brought you the industry leading object storage with ECS. And we have a long legacy of building storage and the privilege of supporting, many of the largest customers in the world. Let us help you. Now, accelerating, modern apps. What we're looking at here with cloud-native applications, storage is not really one size fits all. Sometimes you may need more metadata services. Sometimes you need higher throughput. And on the right side of the screen, what you're seeing is some example of our microservices in support of various workloads. Our microservice architecture allows us to transparently scale up, down, across the appropriate services at the optimal ratios as you need them. And we take care of managing all the possible failure domains to ensure data availability and resiliency across all the physical assets that you have. Using the tools you know. The simplicity of using the tools you know just cannot be overstated. I mean, obviously the benefits of running object storage containers on Kubernetes alongside your traditional virtualized resources in a single unified experience, and your ability to take advantage of automation that VMware Cloud Foundation gives you. And ultimately, it's really about aligning development and IT, right? Data center operators can use the tools they know to apply policies, assign quotas, and so forth, whereas developers can easily provision infrastructure services on demand while complying with IT data center policies. A couple of examples to just kind of give you like a feel of how you can take advantage of such a global archive, right? So your new application anywhere can directly store data on an object store and then have it, be replicated to all around the world. So say you have like a sensor IoT data, you can generate them worldwide, and then, at a later time, you can analyze them as a central location. So those are most of the use cases. And for traditional clients, what you see in the middle of the screen here is a GeoDrive, and it's one of the ways you can take advantage of this utility, which gives your clients, say Windows clients or Mac clients and so forth, an easy way to store data and present an efficient object storage as like a virtually unlimited file share available everywhere. Also, here's an example of how you could deploy it, right? So vSphere and vSAN are in many places now. You can run it on commodity hardware, or even more easily on hyper-converged infrastructures. There are many vendors, that sell those hyper-converged infrastructures. And HCI is already available in edge and core locations. And with vSAN persistence, data platform, you can now take advantage of any excess capacity and at any of these locations and easily turn those into a dynamic, scalable global archive, right? So all without the need of separately managing a dedicated appliance, right? So it gives you tons of flexibility in how you deploy it, how you want it, when you want it. So let's quickly jump into a demo of our current early access. What you're looking at here is currently running, vSphere cluster, running the vSAN, data persistence platform, and within the vCenter, what you're able to see is what object scale running alongside other type of services, all manageable and seen at one place. So with object store, it's really easy to look at, what you have available and what state they are at. Right. So, for example, if you want to start a new object store, what we can do is just easily jump to the new object store. You type in the name, right? So you can select the version of software you want to run. You can decide on which encoding and protection you want, and for this particular demo, we can, for example, use vSAN, right? And then you just click next, And they give you a sizer, right? Give you some flexibility on how you want to size up this workload. Depending on how many workload you may have, you can add and then remove it. And these resources will dynamically help you size based on your expected growth and how long you plan to use it. And then there are other optional customization you could choose as well, right? So at the end, depending on how you want your workload size, by the amount of throughput, or other type of characteristics, then you can jump to, how other optional S3 services. So, for example, this screen allows you to specify, different service type. For example, load balancer, taking advantage of NSXT, for instance, and then at the end, you can review it, and then all you have to do is just apply. And then in about 10 minutes or so, typically, then you have like a newly configured object storage. It works just like an appliance, but it is manageable in the within the vCenter environment, all in one place. So I have some like object storage that's already configured here. Right. So, for example, creating new buckets, setting up the different users attributes, as well as certificates are really simple, all in one place. So you could easily manage events to see who has logged on and so forth in one place. And additionally, if you want to see how your object storage is performing, you can easily go to our Grafana dashboard, for instance. And you can see, how, for example, this example, bucket that I have, how it's performing, right? So the performance metrics, obviously, this is not under heavy load, for this particular cluster. But if it were, you'll be able to see, spikes and valleys, depending on the workload and the times you run it at. So you can do a lot of drill down, as well as, debugging, about your storage performance, very simply. So it gives you a very effective way of managing storage. And once you have the buckets, you can create the new buckets here, or you can create, like a, new bucket, like typical with S3, say an S3 browser, access. So for example, this is an, S3 browser. So what I have here is, for example, I just create a new bucket. I can easily create a new bucket here. I can, see, what are the different files or objects that are in there, right? So this way you can interact with them, very easily. This is just one example. All these are really RESTful API access. So your applications, without going through any of these browsers, can directly access this deep scalable object storage. So now let's quickly jump back, to the end of our presentation here. So what we are, what we have here is, I just want to thank you all, for joining this particular tech talk, this quick tech talk about, object scale and coming to learn more about the vSAN data persistence platform. And if you have more questions, please, do join us on this early access, beta program, and use the link to enroll objectscale@dell.com, and let's show you what it can do.
Okay. Thank you, everyone.
Yeah, thank you. Thank you, Gopala, and everybody.
Hello, everyone. My name is David Santos. I'm an NSX engineer, and today we're going to take a look on NSXT 3.0 and what we can do with that. So NSX 3.0 has three main use cases, and we're going to talk about each one of them. The first one is automation. As automation, we can understand that as network virtualization. So create like logical suites, logical routers, logical firewalls. We can like create those on our virtual infrastructure or align with a broader automation strategy with VRA, VIO, or like Kubernetes. The second use case is security. So increase the security posture inside the data center, applying security rules to the east-west traffic, or like to the traffic that's coming in and out from a VM or a container. And the third use case is the business availability. So NSX can stretch the data centers and easily provide like multi-site architectures and disaster recovery strategies. So we're going to start with the first use case, that's automation. The benefit of NSX for automation is that it's a single endpoint for network virtualization. So here in the left, we have like VRA, VIO, vCloud Director, Kubernetes, Terraform, can also have Ansible and other platforms. And those orchestrators will deploy VMs and containers. However, for those workloads to communicate, we need to also provide networking. So NSX will provide layered firewall, security, network connectivity, routing, and also load balance. The other thing that's really good about NSX is that it also has governance among all those objects. So when it creates a logical suite like a layer 2 network, it will know what's connected there, and when the workload is removed, that connection is also removed, and together with all the firewall rules that belongs to that object. So this way we can control the life cycle of like a workload or like any application. To start with automation, we do our Hello World in NSX. In this case, the Hello World is a layer 2 network. We're gonna create a logical switching, and we're gonna connect two workloads here, Web 1 and Web 2, and we're gonna do that in the NSX UI. Here we are in the Web 01. We're gonna try to communicate to Web 02. The communication doesn't work, so we're going to create a new network called Web, and create that on NSX in NSX UI. After that, we can go to vCenter and connect both workloads in the same network. The network will be available in NSX UI, and we just need to consume that object. After connecting both VMs in the same network, the communication works. So we have layer 2 connectivity between Web 01 and Web 02. The next step is the routing. So the communication between workloads connected in different subnets. To do that, we're going to use an object called T1 gateway or T1 router. It will be the default gateway for each one of the segments that will be created in NSX. T1 gateway or T1 router are kernel-based routers. So they're going to be distributed routers that will work at the hypervisor layer. This way, we're going to have the same IP address for routing, like in all networks, in all the hypervisors that are part of the NSX domain. In this case, we're going to create a T1 gateway that will be the default gateway for segment web and also for segment app, where we have the app01 VM. Here we are again in the web01, and we're going to start to ping the default gateway. We don't have a T1 gateway yet. We're going to create the T1 called T1 vBrownBag. After creating that, we just need to configure that as a default gateway for our web network. Here I select my T1 and I choose the IP address that will be the default gateway. After configuring that, I successfully can ping the default gateway, and I will start to ping other network, in this case, the app network. I'm gonna configure that network to use the same T1 gateway and configure the IP address. After that, we also have connectivity between web and app in a router basis. After that, we need to figure out how this virtual network will communicate with the external world. So to do that, we're going to have a router here called T0, and we're going to connect the T1 with T0, and here we're going to share the routes using a mechanism called routing plumbing. This will automatically redistribute the routes that are connected, and also can redistribute the routes that from NAT and for load balance for VPN, and also can create route maps to select which route we're going to redistribute automatically to T0. And after that, the T0 will redistribute, will exchange routes with the physical router using BGP. In this case, I will try to ping my web01, and I can see the ping doesn't work. So I'm gonna access my T1 gateway and connect that to T0 and select the connected segments to be redistributed. After that, I can ping my web01 successfully. The next step is the security. So the security part we can use with overlay or not. We can deploy a security posture in the environment, like in the data center, even without using NSX overlay, which means that we can deploy that using a regular VLAN. In this case, we have like two VLANs here. We have the VLAN 100 and the VLAN 200, where we have vSphere workloads, also KVM, Kubernetes, and some bare metals here. So what NSX will do, it will deploy element called DFW. DFW is the distributed firewall of NSX, and it will take a look, actually it will enforce the security posture at the VNIC level or in containers at the CNIC level. This way, if you have like a communication that's not allowed, you will block that communication at the nearest point of the application. In the case of a pod, it will block in the pod port. In the case of VM, it will block at the VNIC. It will also can in our environment, we will deploy a security rule that will block the communication between web and app, and you allow the communication of like HTTP. Here we are at the Web 01, and we're gonna ping the Web 02. The communication works successfully. We also can do an SSH, and you can also access that using curl. So here I have the our distributed firewall. I'm gonna create here a section called DFW vBrownBag, and I'm gonna include some rules here. So here we're gonna create a new security group. This security group will be called Web vBrownBag, and I will select the members. So I will select it this way. I did it manually, so those VMs will be statically below HTTP traffic, either in L7 and L4. And something that's really nice about this UI really well. So here I'm allowing the HTTP for L4 and L7. And after that, I can try to ping the communication. It will be prohibited. And if I try to do also an SSH, it will be prohibited. However, the web application still works, either from inside or the outside world. The next step is business continuity. So we can use NSX to extend our data centers and easily deploy a disaster recovery strategy or a multi-site strategy. In this case, we have two clusters here, cluster A and cluster B, and they are different clusters. In this case, we're using the same vCenter for those clusters, but they can be different vCenters. In the version 3.0, I think we can integrate up to 16 vCenters to NSX. And so having the work like the processing, the hypervisor layer identical, you're gonna use the NSX to provide L2 connectivity between the data centers. This way, you only need to do a vMotion to have that workload running in the other data center, and all the network parameters like IP address and DNS entries or DFW rules will be maintained in the second data center. For north-south traffic, in this way, we are using like an active standby where we have edge node for T0 active in site 1 and a standby node in site B. To do that, this way you have a maximum latency of 10 milliseconds. If you have less than 10 milliseconds, we can use that. Otherwise, we need to provide other kinds of strategy for north-south. And also, the ads are exchanging BGP with like the physical layer. And once the edge node edge node 1 got failed, and the site B will start to use the edge node 2 as active, doing BFD. So BFD allows the fast converse between fails. What we're gonna do for our testing, we're gonna start a ping to Web 01, and after the ping, we're gonna do a vMotion and see how the L2 stretches across sites. So here I'm doing the ping to Web 01, and I'm gonna migrate my Web 01 to the site B. Here I'm gonna select the host in site B that I want to host that VM now. In this case, will be Web01. The network will be the same. And after the vMotion, we can see here that the vMotion worked successfully and the communication didn't stop. That's all I have. Thank you very much and see you next time.
My name is Marco Abella, and I'm part of the Dell EMC Storage Product Management Division. Here today, I will talk to you about running virtualized applications inside a modern storage platform using Dell EMC PowerStore apps on. PowerStore is the next generation mid-range offering from Dell EMC that is built from the ground up for NVMe. Its design principles are centered around three main themes. The first is data centricity, with the ability to run any workload, whether physical or virtual, block-based, file-based, or container-based, in a performance-optimized appliance designed for NVMe that can scale up in single drive increments as well as scale out, all with always-on inline data reduction. Next is intelligence, with a programmable infrastructure that enables DevOps and automation through integrations such as VRO and Ansible. PowerStore also has built-in AI and ML, which simplifies typical storage administration tasks, such as optimizing system resources, and also uses it to provide proactive health analytics to reduce risk by predicting potential future issues and needs. Last is adaptability, with a flexible container-based architecture that can be deployed as a traditional external storage array or with VMware's ESXi hypervisor integrated to allow virtualized applications to run directly on PowerStore. This offers flexible deployment models to modernize infrastructure regardless of location and provides choice, predictability, and investment protection through flexible consumption models and data-in-place upgrades. PowerStore is built around the PowerStore OS, which is a container-based active-active architecture which is optimized for next-generation technologies such as NVMe media, is able to provide multi-dimensional scale with the ability to scale up, scale out, and even scale down, all while providing always-on inline enterprise data services. In following a modern container-based architecture, the PowerStore OS is made up from a group of modular containers, with each container providing a specific service. Examples of running containers in the PowerStore operating system include a container for the control path services, a container for the data path, a container for data mobility, which handles things such as replication, one for serviceability, and even one for file services. This modularity provides two main benefits. The first is the ability to restart and upgrade specific containers without impacting other containers. For example, if a specific library needs to be updated due to a security vulnerability and that library resides in the control path, we can upgrade that specific container without any impact to I/O. Where with the traditional monolithic stack architecture, you would need to take down the entire stack and fail over I/O. Second is the ability to go to market faster with best-of-breed services across Dell technologies. For services that are common across the storage products, rather than have each individual storage product group build their own version of an offering and have it behave completely and have inconsistent experience across the products, we can have a common engineering team that focuses on delivering best-of-breed shared technologies, which when delivered as a container can be easily consumed as part of this architecture, which is exactly what we're doing, for example, with our serviceability and file services. By building PowerStore from scratch, the new data path created around NVMe, we're also able to build new leading data reduction technologies. If you look at the Dell EMC primary storage portfolio today, XtremIO leads in terms of DRR with an average DRR of 3.75 to 1. With PowerStore, our expected DRR is 4 to 1, made possible by having a compression offload and fine granular dedupe that is always on and in memory. And in fact, we are so confident in this that we even guarantee it. Now, PowerStore can be deployed in two primary different deployment models. The first is with a standard traditional deployment model, which is the PowerStore T model, in which PowerStore serves storage to external hosts as a traditional storage array via fiber channel and iSCSI. But what's so radically different about this platform is our hypervisor-based deployment, also known as AppSon. Now, if you look at the PowerStore appliance and really think about it, the two nodes that run the PowerStore OS and provide the active-active HA capabilities are really just purpose-built servers with each of the two nodes having dual-socket CPUs in memory. With the AppSon offering in the PowerStore X model, the ESXi hypervisor is loaded onto each of the two nodes, and the PowerStore operating system is running active-active as a VM on each of these two nodes, providing the exact same data services on the exact same hardware. What this allows is local compute to be exposed so that virtual machines can be run directly on the same PowerStore appliance using the same VMware tools to administer this that the majority of companies have already standardized on today. This is ideal for storage-intensive data-hungry applications, OEM solutions, and infrastructure consolidation use cases where PowerStore provides the ability to run applications protected in an active-active HA manner with enterprise data services all in a single 2U appliance. In addition, this deployment model is multi-personality, in that apart from allowing applications to run on internal compute, it also simultaneously acts and serves storage to external hosts via fiber channel and iSCSI like a traditional SAN, offering the ability to modernize while protecting existing infrastructure investments. Both of these models, the PowerStore T or the PowerStore X with AppSon, run on the exact same PowerStore hardware, which is fully redundant dual node appliance, with each node having dual socket Intel CPUs that can scale from 16 to 56 CPUs per node and 192 gigs of memory to 1.28 terabytes of memory per node. And again, it's 2 nodes per 2U appliance. In terms of drive support, as the base enclosure of the appliance is all NVMe, supported capacities are 1.92 terabytes all the way up to 15.36 terabyte NVMe drives. And for customers looking for the highest levels of performance, SCM is supported in 375 gig or 750 gig capacity points. Additional drives can also be added via expansion shelves. Now let's look at some deployment scenarios where PowerStore can be utilized to modernize infrastructure starting at the edge. Usually requirements for the edge are low latency, high availability, and small footprints, as these locations don't typically have primary data centers, so space really comes at a premium. PowerStore with apps on is ideal for these edge site requirements, allowing streaming data from devices to be captured at the edge site with the edge site application running directly on the same appliance for ultra low latency. As mentioned before, PowerStore models support the same core features. PowerStore has built-in native replication, which allows these edge site locations to replicate to a core data center where cross-edge site data can be aggregated and analyzed. And since both models are fully interoperable, the PowerStore X model with apps on can replicate to a larger PowerStore T model residing in the primary data center. By leveraging the industry-leading ESXi hypervisor, we also automatically inherit some core native services that come as a part of it, such as vMotion. Using vMotion, customers can move workloads around from existing external ESX servers onto PowerStore with apps on as needed, including existing HCI solutions such as VxRail as a complementary extension. And remember, the apps-on model of PowerStore also acts as a traditional SAN in that it also provides storage to external servers, whether bare metal or virtualized via Fiber Channel and iSCSI. Now let's talk about all the innovation, all the IP that went into the apps-on architecture. So first is through work done as part of a three-way NDA with Intel and VMware. PowerStore leverages Intel's VMD technology for a direct private PCIe domain, which pass-throughs the ESX hypervisor, enabling bare metal NVMe performance. This also provides full support for NVMe plug-and-play, which enables our fully online single-drive scale-up capabilities, as well as supporting PCI fault containment. The second benefit or the second innovation that went into this architecture is that we solved around a noisy neighbor problem. The PowerStore OS resources, which are used for serving storage, are completely separated from user space resources, which are used to create and run virtual machines, guaranteeing consistent and predictable storage performance at all times so that no resources are trespassed to the other side. Next is the multi-personality, which I talked about before. The PowerStore X model with apps on is multi-personality in that apart from allowing VMs to run on the internal nodes, it also simultaneously acts as a traditional SAN array, serving block workloads to external servers via Fiber Channel and iSCSI. These external servers are external ESX servers. Again, you benefit from inheriting native ESXi data services, such as vMotion, allowing to move workloads around from external ESX servers to the internal ESX servers that make up the PowerStore X model as needed. And next, which we'll talk a little bit more on in the next slide, is a really tight vVol integration that we have spent a lot of time on. So let's spend some time to talk about PowerStore's efficient vVol implementation, which includes some very cool integrations that we have done to give customers the best possible experience with vVols. The first is a turnkey vVol setup. There's nothing to configure. You simply register your vCenter server and PowerStore will take care of the rest, allowing you to use vVols instantly. VASA provider registration, protocol endpoint creation, storage container creation, and even the vVol data store is created automatically. In addition, all data services, such as data reduction services, are fully on and always running on vVols. Next is end-to-end VM visibility, which provides the ability to track capacity utilization, VM compute performance, storage performance, alerting, protection, and display individual vVols that make up a VM. From the PowerStore Manager, a user can view all these VMs running and utilizing vVol storage from the PowerStore array. Next is integrations with VMware's SPVM. We currently expose quality of service through SPVM, and we will continue to expose more and more storage policies in the future, such as local protection and replication. And last is integration with managed snapshots. Snapshots can be taken on demand or via a protection policy assigned to a VM from the PowerStore Manager, which are then displayed in vCenter. Meaning, if a snapshot is taken from the PowerStore Manager of a vVol-based VM, those snapshots are visible in vCenter by right-clicking a VM and do manage snapshots, so that a VMware administrator has access to them as needed. But it's also vice versa. A snapshot taken from VMware via right-clicking a VM and selecting Create Snapshot, those same snapshots are displayed and available in the PowerStore Manager. But our VMware integration doesn't stop with vVols and truly is unmatched. In addition to our vVol integration, we also have integration with VRO for automation, along with PowerStore being supported as an external storage array to workload domains under VMware's VCF. Last, I want to display a use case highlighting the power of AppsOn in a customer scenario. So an example of PowerStore with AppsOn in action is in the healthcare space. Medical informatics offers a suite of applications called SickBay that unlock over 300 data points created by bedside devices, from heart rate monitors to ventilators. All this data is collected at the edge and then both stored and streamed to both local and remote nurses stations where multi-patient monitoring can happen from a centralized location. This requires a solution that can provide ultra-low latency, high storage to store years worth of patient data, and is easy to use, and provides high availability in the smallest possible footprint because these locations, again, don't have typical primary data centers. Leveraging PowerStore with AppsOn, the SickBay application suite can run directly on PowerStore, taking advantage of both local compute and enterprise storage in a single consolidated system. Typically, patient data disappears within 48 to 72 hours, but now leveraging SickBay and PowerStore, data can be kept for much longer so that a trend can be created for each patient to provide new insights. Streaming data can be collected at the edge from bedside devices and placed in front of a physician in real time while ensuring performance and availability in a small footprint. This is the power of AppsOn. Thank you very much, and I hope you enjoyed this session.
Hello everyone. Today I'm going to be covering the considerations and constraints for running VMware Horizon on VMware Cloud on AWS. My name's Dean Lewis and I work as a technical account manager at VMware. You can contact me through my blog, theeducate.co.uk, and also on Twitter, SaintDLE. As there's going to be a lot of information we're going to go through in the next 15 minutes for this recording, you can grab all this by going to the short link theexpert.me/VMC-Horizon, and I'll show these links at the end again as well. Just a quick overview of the agenda. Essentially, we're going to be looking at what Horizon is, what's special about it when it runs on VMC, talk about those considerations and constraints throughout, and then finish off on a final summary as you'd expect. Okay, so first and foremost, I'd like to start with Horizon 7 running on top of VMware Cloud and AWS is not desktop as a service. For those of you who may not be familiar with the VMC offering, it is a VMware managed service. We run the underlying vSphere platform for you, and you consume it by bringing your own virtual machines to the mix. By running Horizon 7 or 8, also known as 2006, which has just been recently announced, as an IaaS model, it means you bring the platform or the virtual machines onto the MC and you run it yourself. So this will be self-managed, you are the tenant. This is in contrast to our Horizon Cloud offering, which is available on IBM SoftLayer and in Azure as well, which is a managed service from the Horizon platform itself. If you are using the Horizon Cloud platform, you will bring your virtual machine images and you will ask to deploy those images into a pool, which can be used by your users, but you will not have to manage the Horizon platform itself. Today, we're only going to be talking about running the IaaS model of running the IaaS components on the MC itself. Just also want to make a quick note. In VMware Horizon, we also support the cloud architecture. The reason why this is important is typically a lot of customers looking at running Horizon in VMC today already run Horizon in their on-prem data centers. You can extend your Horizon environment by using cloud architecture into the environments running in VMC and running in your on-prem vSphere environments. That creates a flexible, highly available platform. You will have to keep the platforms in sync with one another from a version and control point of view. But other than that, it's the exact same kind of architecture and references you'd be looking for to running cloud architecture if you were keeping all of your environments the same on-prem, but maybe between different data centers. Okay, so I'd like to allude to what is the big difference from a usability point of view for Horizon once it's stood up and running the VMC. And the answer is not much. It's a small little tick box. When you connect your vCenter server to tell the Horizon environment where it can deploy its resources to the platform, you tick the little box that highlights its VMware Cloud and AWS is highlighted by the big red arrow. And this lets the Horizon environment know that there is a limited RBAC model in place as part of the VMC platform because it is a partly managed service by VMware. I'd also like to note that there are some feature support that you need to take into consideration as well. So for example, we don't support view composer linked clones in VMC. We don't support running security servers, which are the Windows-based Horizon servers using your DMZ. It's preferred to use the Unified Access Gateway. And also there's no ability to use things like vVols, for example. This isn't applicable for VMware Cloud and AWS because we provide you a single vSAN workload data store. vRealize for Horizon monitoring. We don't actively support it. It can be granted on an individual basis to speak to your Horizon SME that you're aligned to if you're looking into running a Horizon project. And then finally, the just-in-time services, the JMP servers, you can use them in the Horizon Cloud Console instead of running them yourself as well. But again, some of this information as we start to release and ramp up with the GA dates for Horizon 8 will once again change again. So for example, just going back to the lack of linked clones, if you were deploying the latest version of Horizon, we only support instant clones anyway, so it's not as much as a consideration going forward. On our cloud.vmware.com website, we do have a reference architecture that takes you through the minimal viable product to start building your Horizon services in VMC. So let's look at some of the typical considerations and constraints. So the first one is always about your underlying platform. Identity management is always going to be key. Proximity to your Active Directory. So if you don't run any VMC services today and you're looking at this being your first foray, you need to consider at least a read-only domain controller stretching from your private or on-prem data centers into VMC. And ensure that you configure sites and services correctly within Active Directory so that when users are authenticated to any services running in VMware Cloud and AWS, it authenticates against the local domain controller and doesn't go across your VPN or WAN links back to your on-prem data centers. File shares is always the biggest one because files access is your end user experience for most users when they log on. They want to run Word documents, PowerPoint presentations, images that they may have edited. So again, proximity of these file shares to the user's desktop running VMware Cloud AWS is key. For the user documents, consider using technology such as Microsoft Distributed File Services if you are stretching between your on-prem environment to VMC. We also support native services within Amazon that you can bring across into the VMC environment as well, in particular the Amazon FX for Windows File Server service. So this is where you would spin up a Windows server as an EC2 instance, add the Amazon FX technology on top of it, and then use it to host the file shares back into your SDVC. User profiles. I'm pretty sure for those of you that have been sysadmins for many years, user profiles have been the bane of your life as much as have been for myself. Consider using technologies such as user profile management. So for VMware, that would be our Dynamic Environment Manager, previously named UEM. where you can dynamically build configurations for users on the fly as they log into the systems. This minimizes the need for GPOs and replication, and also as well can give the user the feeling of persistence, especially in non-persistent desktop builds where those desktops may be deleted when users log out. We also do support user profile concept systems such as Microsoft FX Logic, which is a cool technology which kind of containerizes profiles as well. However, that's a little bit newer to the market and may take a little bit more changes in your environment to get up and running so that it works as you need it to. And then finally, one of the big things for me is image management. So at the moment, Horizon doesn't support the use of content libraries, which is using content libraries, you can synchronize images between environments. So unfortunately, there is going to be some manual parts to how you operate the data operations and push updates out into your tools as well. So you need to consider about running those golden images. Do you run separate images in your on-prem environment and in VMC? And if so, how do you update them in lockstep? So that's going to be more about how you control your standard operating procedures for the time being. And again, image management today, I know that it is going to be one of those things that's a little bit tricky for yourselves, but by feeding back how you'd like this to work to your VMware SMEs as well really helps, because we can work with our engineering departments to meet your needs. So for me, the biggest considerations and constraints when running in VMC to an on-prem platform is the networking and security side. When running Horizon, as you've kind of already noticed, we've not really talked about in the Horizon admin console itself, for example, because everything kind of feels and looks the same, but the networking and security piece is really key. So you're going to have to create yourself some LAN and DMZ segments in the VMC console. As you can see by the screenshot that I have for my test environment, I created a DMZ, a network to run my RDS farm, which is linked to Horizon, and then also a load balance segment as well. Moving on to load balancing, VMC is a bring your own load balance environment. So although the underlying platform uses NSXT, the load balancing functionality isn't exposed to the end user. So what options are available? You could use things like AWS Route 53, which is fantastic, especially if you want to use the cloud pod architecture. You could use the AWS Elastic Load Balancer, so again, leveraging those native services of AWS, as the diagram shows here at the moment. But you also need to consider the traffic. So the user will be terminating from the public internet to those native services, and then will need to be passed from that VPC of those native services into your VMware SDDC. Or you can bring a load balancer directly to the SDDC within VMC itself, such as Avi Networks, also now renamed NSX Advanced Load Balancer. The difference being here in the second screenshot is that that traffic will terminate on the compute gateway, as all of your other traffic will within the SDDC, and then the load balancing function is going to happen in your environment. That's also very obvious, but some of the considerations you need to take there is by running them virtual machines on your platform, you're consuming the compute and storage of the SDDC, whereas you may not have those considerations if you're running the native services within AWS. And then finally, you're obviously going to be running desktops up in the environment, and typically nowadays a lot of people go down the non-persistent route, which also means using DHCP. In VMC, the options are very limited. DHCP is available as a relay now, and for an environment, especially where you're looking at running hundreds or thousands of desktops, it's recommended to set up a DHCP on a server running in VMC. Run it just on the subnets that you need, but it also gives you more granular control. Also moving on for the security side of it, we have two types of firewall. So we have the gateway firewall, which looks after north and south traffic. So that's everything entering and leaving clusters or the SEC to the outside world. And then we have the distributed firewall. So this is your east to west traffic or microsegmentation services you've probably heard from the NSX technology, protecting communications between virtual machines. You should see me highlighting that better now at the moment. You need to use the distributed firewall to create a DMZ for your UAG services and load balance services. So what does that look like in VMC? In my environment, I created a section. I've put all of my rules going back and forth between my UAGs to the various components of the Horizon platform, so such as my connection brokers, my load balancers. And at the end, it's very simple. I've created two rules. So I block any traffic which hasn't already been allowed going to my UAGs, and then finally deny any traffic going from my UAGs to anything else in my environment. This creates a DMZ. If I don't add these deny rules in, then because I'm using routed networks in VMC, my UAGs will be open to route around my network. One of the things I'd also recommend that you do is look at vRealize Login Site Cloud. You get a limited service offering as part of being a VMware Cloud and AWS user, and you can monitor your NSXT firewall logs up to 1 gig of logs per day, and these are easily sent to Login Site as built in as part of the service by just clicking the option to enable logs on your firewall rules. And here we can just kind of see in this diagram, I'm querying on the NSXT firewall, and then we can just see some traffic which has been allowed and disallowed through the environment. Okay, so let's wrap up with some final considerations. And again, I will share the links at the end of this presentation because I know I've shared a lot of information so far. Consider your use case. A lot of customers are looking at the data center evacuations being one of the use cases. You may already have an on-prem Horizon environment running on aging hardware. So do you want to use cloud pod architecture to give the user a seamless interface between consuming on-prem resources and resources in VMC? Or will you run them as separate Horizon instances? So again, what versions you run your Horizon environments will help also make that decision. What are your constraints when building this environment? So think about sizing your Horizon environment. How many users are you going to need to support? Then consider the maximums in terms of soft limits and hard limits. How many hosts per cluster can you have within your SDC? How many clusters per SDC? And what regions do you need to operate in? Desktop to host ratio is always a key thing for VMC. So do your users run intense workloads such as multi-monitor setups? If the answer is yes, you're going to get less desktops to host ratio, which then pushes up the numbers of clusters that you need. And then finally, networking. So what's your connectivity into VMC? Are you using things like IPsec VPNs, which will add an overhead into your traffic? Or are you using the AWS Direct Connect technology, which is faster links, dedicated, but also come at a high cost? And some of the resolutions for this. So you could scale out across multiple SDDCs to help with cluster limits, desktop to host ratios, and also as well splitting out maybe that traffic if you're using IPsec VPNs across different tunnels and different connection endpoints as well. If you were to do this across multiple SDCs, as we can see up here in this diagram, then you can also use cloud pod architecture just in VMC to link these Horizon environments together to give you seamless experience. Okay, thank you very much everyone for this whirlwind tour of Horizon on VMC. Again, you can find all of the links at theexpert.me/VMC-Horizon, or you could also scan the QR code in the top right hand corner. Thank you very much.
Hello, everyone, and welcome to my webinar on taking the guesswork out of VDI troubleshooting for your work from home workforce. First of all, I would like to thank the vBrownBag team for putting this together so quickly, especially us having a stage set up last year to having a webinar this year so quickly and easily. In this particular webinar, I'll be talking about the VDI troubleshooting process, and over the past 6 months or so, especially since I've been moving more towards VDI to basically make their employees work from home. So in this particular webinar, this is the agenda. We'll be going over some of the main VDI complaints that we see on a day-to-day basis. What are some of the VDI components and their stress points? We'll be looking at a troubleshooting flowchart that we have put together in order to quickly understand where the issues could lie, and to have a systematic approach into troubleshooting a VDI. A couple of examples to show you how you can troubleshoot an infrastructure or networking VDI complaints. So firstly, a lot of people, it takes too long to log in. So this could be quite a few, this problem could have quite a few folds. It could be something Kerberos or LDAP servers. Also, it could be something on the connection server regards. It could be something on latency. So there are a few different things that we can talk about in this perspective. But this is one of the complaints. The second is not being able to access the application down to the VDI desktop. The mission critical application, such as the ER, becomes inaccessible, or where there is very high responses. Thirdly, it could be sluggish user experience for the application. A sluggish user experience could be due to quite a few different scenarios. It could be the internet connection. It could be the home network. They could have multiple people using their home network, streaming Netflix or any other applications, especially in the work from home scenario. When you have multiple people in the same house working, it becomes even more harder to maintain a specific level of user experience. Next is the performance challenges during certain times of the days. During certain times of the days, there could be certain batch processes that you may not necessarily be able to find out in just one go, where one VM or one VDI desktop or multiple VDI desktops may end up having this particular issue. And lastly, you could just have random session drops. Typically, random session drops do not happen mainly because of some kind of a network-related issue where there's a complete network outage within the data center. That could be like a one-off scenario, or it could just be scenarios where a particular VDI desktop does not maintain connection. Some of the view agents inside the desktops probably crash or something of that sort. So there could be a few different scenarios with regards to these, with regards to some of the most common complaints that we have seen with regards to VDI desktops. So in this particular section, I'll be covering what are the most important VDI components and its response. But before I do that, I would like to quickly show you how people look at the bottom of my chart. You can quickly see that there are a lot of RDS traffic. So before VDI desktops became more popular, people used to RDP into their work computers and then access the application traffic desktop, going through a firewall, through a VPN, accessing the application from there. Similarly, if you wanted to access the application directly, you would use home VPN through the firewall and directly access your ERP servers, databases, and any other applications that you needed to. But with all this, there are definitely some security risks associated with that. And that's why VDI has gained a major popularity over the past few months, especially when security has been put in the forefront of many organizations, along with the ability for them to work from home. When it comes to VDI, there are a few different components that you need to be aware of. First of all, again, just like a regular VMware environment, you need to be aware that they all run on top of an ESXi host. You have multiple virtual machines or VDI desktops that are running inside. Apart from the VDI desktops, which are the most critical components, you have your connection servers, your security servers, and other components that are associated with VDI itself. You also have your on-premise applications that all these VDI desktops need to be able to access. Again, just like your databases, ERP servers, if it's a medical organization, any medical softwares and things of that sort. So you can quickly see all that. And similarly, when it comes to a remote workforce, they need to be able to access the VDI desktops from their homes, either using a public IP address that is set up on the VDI desktop pool or the connection server, or through a VPN that has to go, that will basically divert traffic through the firewall into the data center to look into the connection servers itself. So looking at such a complex setup, you can quickly see that there could be multiple areas where there could be potential stress. So let's take a look at some of these areas. Firstly, on the VDI desktops itself. On the VDI desktops itself, you can quickly see, you should be able to quickly see if there are any potential problems with regards to the compute, CPU, the memory related information. Are they spiking up? Is your GPU performing optimally? This basically helps in the user experience of that particular end user. Secondly, you want to see the ESXi hosts those VDI desktops are sitting on. Do those VDI desktops, do those ESXi hosts essentially have enough compute, enough storage, and processing capability to have the number of VDI desktops inside them? Thirdly, you want to see the connection between these VDI desktops to the application servers. Are there any network latencies between your VDI desktops to the application servers? Is there any application delays or application response times between the two? You would want to take a look at this to ensure that your application performance between the VDI desktop and the enterprise application is seamless. Next, you would want to see the traffic, you would want to see the VDI on-premise user experience when it comes to your thin clients that are inside the environment. So there could be any issues such as networking issues between the VDI thin clients to the VDI desktops itself. Another thing could be the firewall. The firewall could be blocking certain packets, could be causing packet drops that could impact the end user experience as well. And finally, you want to take a look at, for a remote worker, the most important aspect is the connection. There could be an issue with regards to the internet being slow or the home network being slow. So you would want to take a look at the connection, the network connection between the VDI remote user to the VDI desktop tool itself. So a simple troubleshooting flowchart would begin as you see over here. You would always want to keep your end user experience in mind when you start your troubleshooting process. You would want to see whether the issue is due to a network response time or an application response time. Say if it's due to an application response time, you would want to see the VDI performance. The VDI performance can be split up into a couple of different things which you would want to troubleshoot, which is either the VDI session setup or provide you with the desktop activities and resource provisioning. So desktop activities include all the different processes that are running in that particular VDI desktop. And once we understand all that, we could provision the resources accordingly. Second, when it comes to application response time, you would want to look into both their application dependency maps to basically see the flow of your enterprise applications. As you know, most of your enterprise applications are multi-tiered. So you would want to see if there's an issue in the database, the web servers, and so on to quickly troubleshoot any problems. Next, you would want to see any transaction analysis. Are there any particular errors that are taking place between the different queries when it comes to the application response times itself? When it comes to the network response time, there are a couple of things to look at. One is to look into the north-south traffic within the environment to quickly see if there are any bandwidth limitations, any band link issues between your north-south traffic, and also see if there's any network switch or router related issue with regards to traffic diverting to the internet. Secondly, with regards to the LAN east-west traffic, you would want to make sure that you have adequate east-west traffic visibility so that you can see all the connections between your VDI desktops to your application servers, or even between the different VDI desktops in between different hosts and things of that sort. And finally, you would also want to see the network edge performance to see if there are any particular issues with those remote sites within your environment as well. So this would be a very, very simplistic troubleshooting flowchart to quickly see what's going on within your environment. So in this, I'll discuss a couple of scenarios where there are infrastructure challenges. First, in order to see if there's any infrastructure challenge, monitor based on the different VDI desktops and quickly see if there are any issues in your compute, in your storage related information. And in this particular case, you can quickly see that there is some memory health related issues for a particular VDI user. Second, once you identify those memory related issues, you can drill down to see the level of spikes in each of those VDI desktops and the resource constraints and challenges that they have. Finally, once you have all the resource constraints, you can drill in and try to find out what are the different processes that are taking place within the environment. This could be done using either a specific tool, monitoring tool, or you could also use drill into the OS from the task manager as well to get this level of data. Next, a scenario to look into some of the networking challenges. First of all, when you want to view your networking challenges, you would want to visualize the end-to-end dependencies for applications, right from the thin clients all the way to the databases of the applications itself. Once you get that information, you would want to see what are some of the issues. And in this particular case, you can see network response time is higher than usual. So using this, you can isolate the issues to the virtual network. And finally, once you get this information, in order to understand what is causing the network response time, you would want to isolate the issue further to see what's causing the issue. And in some cases, issues such as virtual packet drops can be the root cause of your high network latency within the environment itself. So once again, everybody, thank you for listening to my presentation. And I would like to thank the vBrownBag team for giving me the opportunity to do so as well. And if you have any questions, feel free to reach out to me on Twitter or LinkedIn. And my website is also listed down below. Once again, thank you very much.
Hello, my name is Rich Colbert, Field CTO for Dell Data Protection. The topic of this presentation is how does Dell Technologies offer a low-cost data protection solution? Today, organizations are experiencing rapid data growth and diversification. Therefore, effectively managing the cost of data protection has become a priority. Data now spans the edge, the core, and the cloud across a multitude of applications and platforms. And in response, organizations are deploying and extending data protection solutions to protect that data and those applications where they reside. The saying that you get what you pay for still holds true, but in the multi-cloud world, it's probably more accurate to say you pay for what you get. In other words, consumption is rapidly becoming a leading factor in determining the costs associated with data protection. That leads us to the key point for our conversation today. Architecture matters. It's not a new concept. Technology innovation and progress has always placed a premium on developing superior architecture. But this is no longer an engineering conversation about building a better mousetrap. Architecture has a direct impact on consumption, and consumption is a leading factor in cost, along with a whole list of additional business values. What this means is that architecture is now a business conversation. And as such, there is additional focus applied to making the business case. It's no longer acceptable to simply compete with academic arguments in the marketplace of ideas. Architecture conversations need to be tied to measurable outcomes with validated metrics that impact the bottom line. These are the 4 pillars of the Dell data protection strategy that are the keys to our architectural advantage. The first is highly differentiated deduplication. Not all dedupe is created equal. And in this category, being second best simply isn't good enough. The second is distributed deduplication, also known as DD Boost. This innovative and unique approach to protection storage provides numerous benefits that we will cover in some detail. The third is our storage appliance architecture known as SISL, or Stream-Informed Segment Layout. This is our secret sauce to provide industry-leading performance and scale. Fourth, and finally, is our data and vulnerability architecture. At Dell, we haven't lost sight of the fact that it isn't just about managing data. It's about protecting data. When we say deduplication, we're really talking about compounded data reduction. Data deduplication and compression work together to reduce the amount of usable capacity required to store protection data. With daily backups retained for typically 30 days or more, data protection requires many logical copies of very similar data. In fact, protection copies can account for up to 95% of an organization's entire data storage footprint. So efficiency is the key to driving down the associated costs. Based on proven data domain technology, Dell's deduplication is inline with variable segments. Inline is important because it eliminates the need for a landing zone, which reduces the storage required in half right off the top. Variable length segments are even more important, and the smaller the segment size, the better. Our segment size is an average length of 8 kilobytes. Variable segments encapsulate changes in the data patterns to allow the system to find duplicate data, regardless of whether that data has been copied, appended, or even updated somewhere in the middle. And this algorithmic approach works well for both structured and unstructured data. But what matters to the business are the results, and how does that compare to the industry? Dell's technology is typically anywhere from 30% to 3 times more efficient than alternative solutions. And I'm making a direct and practical comparison. I'm talking about the basic question of how much usable storage is consumed and how much network traffic is generated to back up and replicate the data. What does that mean for the business? It means that Dell can protect your data using a right-size solution that requires significantly less storage and less bandwidth than the alternatives. And now take that one step further. What about the cloud? where you pay for your cloud provider for that storage consumption and that network bandwidth every single month. Protection storage on premises generally accounts for anywhere from 8 to 20% of an organization's total storage spend. But organizations who use ineffective data protection in the cloud can see those costs skyrocket to over 50% of their cloud infrastructure consumption costs. Dell Data Protection can reduce that exorbitant level of cloud spending dramatically. That is why effective data reduction matters. And that is why Dell Data Protection customers are protecting over 4 exabytes of data in the public cloud today. But no matter how effective your deduplication is, you give up almost all of the real benefits if you still have to send 100% of your data over NFS every time you back up. Backup execution can be broken down into 3 logical steps: process data, send data, and store data. When deduplication happens at the storage device, the upstream processing of sending and storing data is unchanged. And that is a whole lot of data to sift through and send across the wire every single day. A number of alternative solutions still use plain old NFS as a data transport. But distributed deduplication is a powerful innovation that takes the task of identifying unique data and moves it closer to the data source, so that far less data is processed or sent in the first place. We call this technology DD-Boost. DD-Boost is an embedded technology, and it can be found in all sorts of places. DD-Boost can be found embedded in backup agents, both provided by Dell and by a number of third-party DD-Boost partners. DD-Boost can be embedded in VMware infrastructure, leveraging VADP and bringing source deduplication directly into the virtual infrastructure. DD-Boost is also deployed inside database backup utilities like Oracle RMAN or Microsoft SQL Management Studio and many others to bring the power of source deduplication to DBAs and application owners. DD-Boost can also be embedded in Linux and Windows file systems so that modern application backup tools can take advantage of distributed deduplication simply by utilizing their basic file export utilities for backup and recovery. So, what are the benefits of deploying DD-Boost? The first is faster backups. Backups using DD-Boost can complete in about half the time compared to backups that send all the data to the target. The second is network utilization. DD-Boost reduces backup traffic on the network by as much as 98%. Third is the performance of the backup storage itself. Many hands make light work, and therefore by offloading a little bit of work to hundreds or even thousands of backup clients, the overall performance of the data protection storage can nearly double when using DD-Boost. And the performance implication of running DD-Boost at the client is also significantly less than running a normal backup. And possibly the biggest payout is eliminating data movers. DD-Boost sends data from the client directly to the storage device, eliminating the complexity and the expense of running multiple backup servers to act as middlemen between the client and the protection storage. The impact to the business is tremendous cost savings on infrastructure. And there are also benefits to people and process. By enabling application backup utilities and elevating them to equal standing with central backup agents, organizations can share the work of backing up between the central IT folks and the application owners. And once again, many hands make light work. But the impact goes beyond the division of labor. Oftentimes, application teams are already doing their own backups to expensive primary storage. And then IT comes along and sweeps up those backups in an unreliable and redundant dump and sweep process. Organizations can now reclaim all of that primary storage and eliminate dump and sweep while maintaining application owners' ability to do self-service backups and restores. Backup and recovery stresses a storage system in a totally different way than a typical storage array. Primary storage is sensitive to latency and IOPS. Protection storage requires higher stream counts and greater effective throughput. Protection storage targets can expect to see hundreds or even thousands of high-speed write streams at the same time. Dell Protection Storage, powered by data domain technology, is built with a unique set of attributes that we collectively call SISL, or the Stream Informed Segment Layout. The first challenge this architecture addresses is performance. SYSL is a log-structured file system that is append-only. This allows alignment with the underlying physical storage so that data is only read or written in full stripes. This also means no expensive data insert or update operations and no parity recalculations. The second challenge this architecture addresses is caching. In a normal array, caching applies to data that has been recently seen. However, in backup, and especially with deduplication, there's little to no benefit to caching recent data. Instead, it is far more valuable to prefetch data that the system is about to see again. This is the magic that makes high-speed inbound streams possible. With deduplication, the key to performance is the ability to decide quickly what to do with the data. Is it unique data that needs to be stored to disk, or is it duplicate data that can be referenced with a simple pointer? It turns out that the first question can be answered much more quickly than the second one. Once the system gets the slightest hint that a data segment is unique, it can stop comparing and start writing. It's the duplicate data that needs to be rigorously validated before determining that a simple pointer is actually appropriate. The SYSL architecture uses some very clever memory structures to keep track of what's what, because while it is impossible to keep all of the data signatures in RAM, it is also incredibly slow to keep looking for them on storage. The innovative architectural approach employed by SYSL is the main reason why the data domain platform has been able to hold its position at the top of the protection storage market, both in terms of performance and scale. But being purpose-built is not limited to a physical appliance. Data Domain Virtual Edition takes the architectural enhancements even further. Storage in the public cloud is very different from storage on premises. On-prem, block storage can be constructed with as much performance and resiliency as you want. But in the cloud, the public storage cloud providers have made object storage more affordable and more resilient than their block storage offerings. Data Domain Virtual Edition in the public cloud uses intelligent data placement to take advantage of the lower cost and higher resiliency of object storage, while also using a minimal amount of block storage when it provides a performance advantage. All the while, Data Domain Virtual Edition maintains the same effective deduplication that it provides on premises in order to maximize the efficiency and performance of your cloud solution. Last, and certainly not least, is the idea of the storage of last resort. Protection storage has an implied responsibility for data integrity and durability. If you are recovering data from protection storage, it just might be the last copy of that data that exists anywhere in the world. Dell Data Protection Storage has a group of native capabilities that we call the Data Invulnerability Architecture, or DIA. A number of these capabilities are a natural extension of the SYSL architecture we just described. The data domain file system, which again is a log-structured file system, is append-only. Aside from the performance benefits, this also protects existing data from ever being changed by new data. Data is never overwritten, but instead is cleaned through an asynchronous garbage collection process. The file system is self-healing and provides continuous validation. Data is stored with strong checksums, and the file system performs read-after-write verification to ensure that data was stored correctly. Data in flight is also protected in NVRAM while awaiting write confirmation, so that any data that has been acknowledged by the system to the client is fully protected. The data domain file system is unique in that it validates 100% of the data it receives, but that's just the beginning. The file system is constantly scrubbed in search of data errors, and due to the strong checksums, if any errors are found, they can be corrected. And most importantly, when data is read from the system, either as part of a restore, or as it's being replicated to another system, or copied to another storage medium, the data is once again validated and can be corrected on the fly if needed. The data domain file system also has some advanced security features. It has 2 levels of retention lock, which provide immutability and allows for the system to prevent accidental or malicious deletion of data. Data domain systems also allow the creation of a security officer user to prevent sysadmins or root users from deleting data without authorization from an independent authority. Also, cybersecurity is top of mind for many organizations today, and that is why we offer an enhanced solution called PowerProtect Cyber Recovery. With PowerProtect Cyber Recovery, we provide an air-gapped cyber vault that includes industry-leading capabilities to isolate, detect, and recover from a malicious cyber attack or insider threat. PowerProtect Cyber Recovery includes machine learning, data entropy detection, automated immutability, and nearly 200 powerful analytics to ensure your most valuable data is recoverable. Dell's PowerProtect Cyber Recovery is the only solution certified by the Sheltered Harbor Organization, the gold standard in financial information security best practices. Collectively, Dell views data protection storage as the storage of last resort. It has a special responsibility to ensure your data is safe and secure. When it comes to data protection, architecture matters now more than ever. Dell's unique data protection solutions provide unparalleled efficiency, scale, performance, and resiliency. Two of the leading factors driving unexpected and additional cost to a data protection solution are running out of capacity and exceeding backup windows. I talked to many organizations who chose a solution based on a very compelling sales story, only to be surprised by the need to buy more capacity and more performance a very short while later, or to be surprised by an unexpectedly high cloud bill at the end of the month. At Dell, we want to help you avoid the hamster wheel of continuous and unexpected data protection expenditure. So we offer a solution that will be sized right the first time and that will truly deliver a predictable outcome with the lowest cost to serve. So most importantly, thank you. Thank you for stopping by and hearing about how Dell offers a low-cost data protection solution. We have a number of data protection sessions at this year's VMworld, and please check out as many of them as you can and as your schedule allows. We've got a few very exciting announcements, and I can't wait for us to share them. So have a great VMworld 2020, and let's keep your data safer together.
Hello, my name is Emma Kazimierz. I'm from the Data Protection Division of Dell Technologies. And today I'm going to talk to you guys about how we're providing data protection from the edge, the core, the multi-cloud. So as you look out today at organizations, what we're seeing happening is that they're looking at their data, they're looking at their software, and they realize that within their application as a whole, there's a competitive advantage that they're going to be able to take advantage of. Now, in order to harness this advantage, they're embarking upon this digital transformation, and more importantly, these application transformations are ongoing. And they can't just throw their data out into the public cloud or introduce Kubernetes into their environments and expect that they're going to be able to actually take advantage of this competitive advantage. They're having to take a step back and really do an application rationalization and determine what makes sense to really get the most out of that application transformation. And so as a result of this, what they're doing is they're looking at their applications from a top-down approach, and they're determining, does it make sense to rehost that application? You know, what we used to refer to as lifting and shifting, picking it up from its existing deployment and deploying it in a private or public cloud experience. Does it make more sense to re-platform or containerize that application? Or do we need to just completely rewrite it and refactor it, move it from being, say, a traditional Oracle deployment into, say, a MongoDB instance? Where, you know what, I don't even want to deal with this application anymore. I'm just going to pay somebody else to manage it. I want to move it, repurchase it, and go SaaS. Great example of this, getting off of Exchange and moving on to 365 with Microsoft. Now, there are also applications out there that it just doesn't make sense to rehost, replatform, rewrite, or even repurchase. The juice just isn't worth the squeeze. At the end of the day, it's going to be cost prohibitive to even do one of those. And in those instances, we're just going to retain them and keep it business as usual. Now, across all this, though, if we've rehosted, replatforming, rewritten, or repurchased, what happens to those legacy applications? We have to think about how we're going to retire them. And we may have compliance that requires us to keep them around for 3 years, 4 years, 10 years. And it doesn't make sense to have them living on expensive all-flash storage once we've retired them and moved on to rehosting, replatforming, rewriting, or repurchasing. And so it becomes critical here that we take into consideration data lifecycle management and have the ability to tear it down to the most cost-appropriate storage so we can actually get the biggest TCO and cost reductions out of this. So while this is occurring now from a top-down approach, what we have to take into consideration is the bottom-up and how we support this from an infrastructure perspective. And so when we look at this from an infrastructure lens, on the left side there we have our traditional applications, our physical Windows and Linux, our non-x86 platforms, AIX, Solaris. And then we have everything that we've gone through the process of moving from physical to virtual, from being to being in that virtual environment. And on the left, really, this is a construct methodology. In order to support these applications as they're being onboarded, we're constructing the underlying infrastructure to support them. Now, as we move into the world of infrastructure as a service, containers as a service, or platform as a service, whether this is on-prem in our private cloud or up in the public cloud, more and more, this is in a multi-cloud world. And so in order to support this, this is really a consume methodology here. Now, I like to think of IaaS, PaaS, and PaaS really as terms of a metaphor for a house. In an infrastructure as a service environment, I show up, my foundation's already been poured for me, I have all my lumber, my drywall, my bricks, my shingles, I go and build that house. In platform as a service, that house is already built, and I just move right into it. Containers as a service, I have a shell of a house, and every day I'm picking out what the floor plan is going to be, what the colors of the walls are, what the cabinets are going to be, and it's tear up, tear down. And that's how containers had been when they were just stateless. But now what we have happening is organizations are starting to containerize applications, and they're moving from being stateless to becoming stateful. So in that same instance here, I'm picking out the floor plan, colors of the walls, the cabinets, but I now also have a file cabinet in that house. And every day, more and more is growing to that file cabinet. And I need to have the capability of reverting back to 3 days ago, 5 days ago, 2 weeks ago. And I just don't need the status of that file cabinet, but I also need the status of that house. I need both the application consistent and the crash consistent. The challenge is the way that I protect those environments is different than how I go about protecting my infrastructure as a service or platform as a service. And so it makes things very interesting as organizations are going through this transformation on how they're approaching these things. And so when we look at this here, what's important to understand is, where things fall. And in conversations that I'm having with my customers, what I see is that on average today, about 30% of customers' environments fall into that traditional bucket. About 60% fall into that virtual bucket of applications that have gone through the process of being moved from physical to virtual. And then 10% is a scatter shot across the board of IaaS, PaaS, PaaS, and SaaS. Really varies from organization to organization where they are on their digital transformation journey. While this is all well and good to look at where organizations are today, we also have to take into consideration where they're going to be in the world of tomorrow. So looking out to the year 2023, what we see is an interesting shift in these workloads. What we find is the traditional applications are only going from 30% down to 20%. And at first, it kind of makes you scratch your head, but when you double click on it, it actually makes a lot of sense. And the reason for this can really be compared back to the whole mainframe conundrum from the early 2000s. Mainframe was supposed to die in the early 2000s, yet here we are 2 decades later, and the majority of Fortune 100 customers are still running mainframe in their environments. The same is true for these traditional applications. These are the cornerstone applications that have been ingrained in environments for years, non-x86 platforms, things that are very difficult to try and rehost, replatform, rewrite, or even repurchase. They've been so customized, and they continue to do very important aspects on the environment, and trying to get off them is near impossible. But where we really see this shift into the consume methodology is on the virtual workloads, going from 60% down to 10%. And really this is being driven by two key things. The first is automation and the ability to take these workloads and automate them into those consume environments. And is really allowing organizations to streamline their adoption and drive their digital transformation forward. Now, when we look at this from a data protection lens, it's important to understand how all these different components need to be protected. From that traditional side of the house, we know how to protect those environments, right? Your physical servers, you're going to put an agent or a client out on them. You'll have your backup server, your media server, and you're going to write it to a target. When it comes to those virtual workloads, we should be using VADP, the VMware API for data protection. We should be doing image level backups. We don't want to be having a bunch of guest clients out there that we want to be managing across the board for hundreds and thousands of VMs. Maybe we're also going to be leveraging some proxies to accelerate that data transfer. But again, it's landing on a target. Now, as we move into the world of consume, whether I'm deploying a virtual machine, an application, or a container, I need some sort of portal for my end users to interface with to drive this model out there. And 9 times out of 10, what I end up seeing is that portal ends up being ServiceNow. But ServiceNow on its own is really just a ticketing system. I still need some automation tools underneath there to drive the deployment of these production VMs, applications, or containers. And so the market leading vendor out there from an IT automation tool set is VMware. So having native plugins into the VMware automation tool suite becomes critical. But it's also important to understand that as part of organizations' digital transformation, they may be leveraging additional automation tools. They may be using things like Ansible, Puppet, Salt, Terraform, Otter, or whatever the next one is that hits the market. So it becomes critical that not only do you have native plugins into the market-leading automation tool set, but that you also have open REST API capabilities so that you can integrate in those automation tools into your data protection solution as you go through your transformation, so that you can integrate into the Ansibles, the Puppets, the Chefs, what have you, and have that flexibility and choice. Because the last thing that you want to do is stand up your entire automation deployment for your production environment, but then still have to manually touch it from a data protection side. It's counterintuitive. As your production workflows are being deployed, the protection capabilities should flow with them as well. Now, once I get to this point and I've stood up this framework, I've got to answer 5 key questions. And based on the answers to these 5 key questions, is going to determine where this data is going to live. And that comes down to cost, availability, performance, location, and compliance. Based on the answers to those 5 things, the data is either going to go one of 2 places. It's either going on-prem or it's going off-prem. It's going off-prem, it's going into AWS, it's going into Azure, it's going into GCP, or it's going into VMware Cloud on AWS. If it's going on-prem, it's being deployed as a converged or a hyper-converged instance, or as a software-defined solution on the hardware of your choice in your private cloud environment. Now, we still can't forget, though, about those applications that we've decided to outsource and repurchase. You know, we may have more compliance requirements for those resources than what those vendors are providing. Some of those vendors may not be providing any protection capabilities at all. So we have to make sure as we go down the path of repurchasing applications and moving those into SaaS models that we have the ability to protect them that meets the internal compliance requirements of our organization as a whole. Now, when we get to this point, we see a need still for 3 key things. The first is integration with object storage. Going back to the beginning here in that application transformation that's occurring, for those applications that we've retired, the ability to integrate in with object storage becomes critical, and having the ability to tier that down to the object storage of choice based upon policies of age becomes critical, so that we no longer have to maintain them living on expensive all-flash storage. But in addition to this, being able to leverage our market-leading IP and data reduction ratios to shrink that actual physical space that it's consuming upon allows us to bring forward the most efficient TCO out there and cost reduction ROI for our customers. And it's not just about integrating into one object storage platform. While we prefer it to be ECS, we understand that as part of your transformation journey, you need to have choice and flexibility. So being able to integrate into the object storage platform of your choice, whether that's S3 infrequent access, Azure cold blob storage, or even Alibaba Cloud, allowing for that flexibility of that journey. We also see a need for object store integration as we start protecting workloads in the public cloud. The last thing that we want is for the most expensive thing in the public cloud to be your protection solution. That's why our technology, when we protect workloads in the public cloud, leverages that cloud native object storage as its consumption of what it's running on and writing towards, enabling our customers to continue to drive down costs and have that cost reduction, allowing them to be investing in things that are actually important to them in the public cloud, things like microservices, things like database as a service, those really things that are driving that transformation forward so that we can keep them protected, but drive down costs as a whole. The other key area that we see a need for is the ability to provide an air-gap copy of the data for those mission-critical crown jewel applications. And where those crown jewel applications are going to shift depending on where organizations are throughout this journey. So the ability to vault down those applications, whether they are deployed as traditional, and whether they are deployed in your private cloud, or vault them down from the public cloud, becomes paramount, so that you're not in a position where you have to end up spending or paying bitcoins to the bad guys to get your data back. And on top of this, it's about not just allowing for that, the ability to protect those critical applications, but also those critical rebuild materials. So, because if you're in a DR scenario, you're assuming that you've got access to the DR site, that you've got asynchronous replication, that you can come back up. In a cyber event, you need to be assuming that you are coming back from nothing. You're having to recover from bare metal, and so you need to make sure that you have those critical rebuild materials, things like Active Directory, things like domain controllers, things like networking templates, so that you can actually bring back those crown jewel applications holistically in your environment. And the final key piece here that we see a need for is the ability to provide one common management plane. Whether you're protecting traditional or virtual resources in your construct environment or protecting workloads up in the public cloud, having one common management plane that gives you visibility across the board so that you are able to have reporting and management through that common pane of glass. Because while we may have automated the ability to protect workloads in your consume environment, we still need to make sure that we're taking into consideration how we are protecting those 30% of workloads down the road that it will continue to be in that construct environment. And having that one common management plane that's built on HTML5 is something that we're providing for customers today. So when you look at our portfolio, this is really what we're focusing in on for our customers and what we're delivering on for them across the board. And this is really kind of specifically due to our focus and our strategy as a whole. And when you look at this, we're focusing in on the mega trends of the industry, providing value to the data that we're protecting applications as they're going through this transformation. And as data now has been distributed to the edge more than it ever has in the past due to things of work from home in the current times we're living in, it becomes critical for us to be able to provide our abilities of leveraging AI and machine learning to look in at the entropy of the files themselves, to identify if the change rate has gone from an average of 3% over the past 18 months up to 98%. Make sure that the file type still matches the extension, and to identify attack vectors that we see that are common in environments to address them. And we're doing this by continuing to provide that proven technology and leadership that we have in the industry around simplicity and automation, efficiency from a protection standpoint, and driving efficiencies in customers' environments, being able to provide protection at scale, and being able to provide that protection performance as customers continue to drive, while also focusing in on delivering modern innovation, being able to provide that native cloud protection, autonomous protection for applications as they move from the edge to the core to the cloud, and also being able to introduce new services and recovery options for our customers as they move forward. That's what we're doing here at Dell Technologies, and that's how we're providing protection for our customers from the edge to the core to the cloud. Thank you, and have a great day.
I'm Ian Breitner from the Storage Solutions team at Dell Technologies, and thanks for joining. Today we're going to talk about edge computing and how that's going to impact application modernization plans. Now, everyone's heard of the 5 Ws. Perhaps they may be more familiar this way. We'll go through each of these in turn, and the order in which we may do them will make sense to me, perhaps not to you. So let's start with the what. What exactly is edge computing? Edge computing is defined by processing data at or near the source of the data. It is essentially a distributed computing environment. Data volume is growing, and IDC estimates that in 5 years there will be about 79 zettabytes of data from roughly 42 billion devices. As the volume and velocity of data increases, so too does the inefficiency of streaming all this information to a cloud or a data center for processing. Edge solutions are designed to complement data center and cloud services. Edge computing serves as the decentralized extension of the campus network or cellular networks or data center networks or even the cloud. Santosh Rao from Gartner says, organizations that have embarked on a digital business journey have realized that a more decentralized approach is required to address digital business infrastructure requirements. So here's a simpler architectural view. Both cloud and data center have a part to play, but we now have a need to service new devices by delivering compute power close to the device itself. And those devices are proliferating at a great rate. And spoiler alert, it's not just compute power that's needed, but networking and storage as well. So why? We've defined edge as bringing compute in proximity to the source of the data. Edge computing is designed to complement existing public cloud, data center, or co-location deployments, and edge data centers offer advantages that none of these possess. It's due to the compute proximity to the data that is the core strength of edge computing. Its ability to support applications that demand a significant amount of bandwidth, require rapid response times, are latency sensitive, or any combination of them. And network traffic performance is much less of an issue at an edge location than with a data center or co-location deployment, or even the public cloud. In these latter cases, data needs to be moved from the location where it is acquired to a central location for processing. Doing so incurs latency. We still have not been able to communicate significantly faster than the speed of light. But across all industries, the digital transformation of products and processes is creating new ways to connect with customers and partner. And this is kind of interesting. The movement to edge computing parallels the cyclical nature of IT trends. What began with centralized mainframes eventually moved to a decentralized approach with client-server networks. Then the meteoric rise of the public cloud shifted computing back towards a centralized approach, only to have the recent rise in popularity of hybrid cloud deployments move the needle back towards a decentralized model. So when is this need for edge computing going to occur? The news, good or bad, is that it is occurring now. In fact, it started back in 2009 when Carnegie Mellon University used the term cloudlet to describe a micro data center, basically an edge data center. However, it was not until 2016 when edge deployments really started. Gartner estimated that only 10% of data was processed outside of the data center and cloud back in 2015. But now they estimate that within 5 years, the amount of data processed outside of a traditional data center or cloud will be 75%. This growth is basically due to IoT devices. These include mobile devices that we all use daily, like cell phones and GPS location services and so on. And they include new data sources, IoT devices that are being deployed in a variety of locations. Growth rates for edge computing are estimated by analysts to be from 11% to 12% compound annual growth rate. And this might well be a conservative estimate. Those smart thermostats, smart utility meters, ever-growing mobile devices with specialized apps are only adding to the data that is being generated. You can see from this chart that the growth of the edge is growing exponentially, and we are here in 2020. So the who? No, not the band. Who is looking to use edge computing? The number of use cases is still increasing, but common ones include supporting advanced Internet of Things appliances and augmented reality applications. So, for example, retailers can leverage AR to improve customer experiences by creating apps that help customers find their way around shops, implement network smart mirrors to try on clothes without a changing room, or run personalized promotions and offers that leverage the consumer's historical purchases and personal tastes. Within manufacturing environments, artificial intelligence can be used for predictive maintenance of expensive machinery, drive down long-term maintenance costs, and significantly reduce the risk of failure. Elsewhere, raw input from IoT sensors can be leveraged for quality control or to reduce wastage. Edge computing solutions can take many forms. They can be mobile in a vehicle or smartphone. They can be static, that is part of a building management solution, manufacturing plant, or an offshore oil rig. Or they can be a combination, such as in hospitals or other medical settings. A wearable health monitor is an example of a basic edge solution. It can locally analyze data like heart rate or sleep patterns and provide recommendations without a frequent need to connect back to a main data center or cloud. The capabilities of edge computing solutions range from basic event filtering to complex event processing. By 2024, edge data centers are projected to exceed $13 billion, with the IT and telecom sectors driving growth. Manufacturers in the edge data center market are providing several effective solutions that allow businesses to adopt edge computing technologies for managing their enterprise data. For instance, Dell Technologies, my employer, is several computing solutions such as PowerEdge, XR2, R740, and R740XD servers that are optimized for mobile virtual network functions. But they also have a new offering, PowerStore, a storage array that not only can scale up and scale out, but can also run virtualized applications on the array itself. PowerStore natively runs ESXi. The management of the storage is handled in a VM, and the array can run user VMs. It appears in a vCenter as another VMware host and acts as with any vSphere host. It is highly redundant with dual controllers, servers if you like, which act cooperatively in managing the storage. The value this brings to edge computing is significant. Not only can PowerStore be used to house the data collected at the edge, it can also run applications that can process that data. And it does this in a very small 2RU form factor, about 3.5 inches high. And if this is of interest, I would encourage you to join Marco Abella's VMworld session on PowerStore or Heather Hitchcock's session on healthcare, where she talks about automating an ICU. So the where. Edge servers can form clusters or micro data centers where more computing power is needed locally. And they can be anywhere. And in fact, they are already everywhere. More complex edge computing solutions can act as gateways. In a vehicle, for example, an edge solution may aggregate local data from traffic signals, GPS devices, and other vehicles, proximity sensors, and so on, and process this information locally to improve safety or navigation. More complex still are edge servers, such as those that are currently being deployed in the next generation, that is 5G mobile communication networks. And these will host applications and cache content for local subscribers. So from connected vehicles to intelligent bots on the factory floor, the amount of data from devices being generated in our world is higher than ever before. Yet most of this IoT data is not exploited or used at all. For example, a McKinsey & Company study a few years back found that an offshore oil rig generates data from 30,000 sensors, but less than 1% of that data is currently used to make decisions. The edge is a focus area of burgeoning distributed computing framework, which is being created due to the latency and bandwidth requirements for new use cases. According to IDC's 2019 Data Center Operational Survey, 79% of United States-based organizations were planning to deploy more IT services at edge locations. Supporting new digital services at scale across many locations requires the ability to deploy and maintain infrastructure and enable connectivity in many locations. Organizations will be challenged to support connectivity needed for physical and data security in these locations. And real estate will play an increasingly role in edge deployments. For example, Walmart is exploring ways to rent out edge computing, leveraging its retail footprint. Retailers have the locations to enable edge computing. And there are several risks inherent in edge computing. So across all industries, the digital transformation of products and processes is creating new ways to connect with the customer and partners. Much of this innovation depends upon having IT service in new locations, that is, at the edge. But if organizations are unable to manage their edge endpoints in a scalable way, the costs of operating and security risks will erode or negate the value of these investments. Managing edge effectively means more than the ability to keep track of endpoints, such as within a factory or a retail location or a remote site. It means the ability to overcome the variability of endpoints, rely on remote management technologies, and scale operations at a new level. Creating an ecosystem that gathers, stores, protects, analyzes, and transports data in a frictionless way across many platforms organizations. Evaluating, deploying, and operating Yes, I can. Already. So there are risks associated with edge computing. Across all industries, the digital transformation of products and processes is creating new ways to connect with customers and partners. Much of this innovation depends upon having IT service in new locations, that is to say, at the edge. But if organizations are unable to manage their edge endpoints in a scalable way, the costs of operating and security risks will erode or negate the value of those investments. Managing edge effectively means more than the ability to keep track of endpoints, such as within a factory or a retail or remote site. It means the ability to overcome variability of endpoints, rely on remote management technologies, and scale operations at a new level. Creating an ecosystem that gathers, stores, protects, analyzes, and transports data in a frictionless way across many platforms will strain the capabilities of even the most advanced IT organizations. Small problems will become magnified as the scaling increases exponentially. The impact could result in service interruption at best, or security breach at worst. As with all rapidly evolving technologies, evaluating, deploying, and operating edge computing solutions has its risks, and they come in many forms, but a key one relates to security. Extending your footprint using edge computing exponentially increases the surface area for attacks. Unsecure endpoints are already used in distributed denial of service attacks or as entry points to core networks. And another concern is that the cost of deploying and managing an edge computing environment can easily exceed the project's financial benefits. Moreover, projects can become victims of their own success. Scalability can become a serious issue as new IoT endpoints proliferate. And of course, there are additional challenges. Network resiliency. While within the edge location this is not an issue, there is still the need to move data sets back to the core, either for additional processing or for archival. Then there's scaling the number of edge locations can be challenging, as noted earlier. Bandwidth and spectrum constraints, and we expect that 5G will alleviate some of these. Another good one is data sovereignty and its application in the EU to collect the data. And this may well extend to other countries, such as Canada and the US. Also, procurement is shifting from CapEx-centric to OpEx-centric. Organizations may not want to own the infrastructure they use, but rather rent it. And then system complexity, as the edge expands, it becomes more and more complex, and there are more complex interactions required. Remember this diagram? This only has 50 devices in it. What happens when you end up with tens of thousands? And not to forget the shortage of skilled labor resources. Organizations are struggling with their cloud initiatives, and edge adds the need for a different skill set, which are even harder to find. Edge computing does help you unlock the potential of the vast untapped data that's created by connected devices. You can uncover new business opportunities, increase operational efficiency, and provide faster, more reliable and consistent experiences for your customers. The best edge computing models can help you accelerate performance by analyzing data locally. A well-considered approach to edge computing can keep workloads up to date according to predefined policies and can help maintain privacy, and will also help adhere to data residency laws and regulations. Developing a successful edge strategy requires taking into consideration the complexity of management endpoints and recognizing that scale and variability is dramatically different from traditional on-premises or public cloud deployments. And with that, I end my talk, and thank you for listening.
Hey, this is Shashi. I am from PowerFlex product management team, and I focus on developing applications and workload solutions with PowerFlex. In today's session, I am going to talk about enterprise databases on containers, specifically with PowerFlex and VMware. So let's go through some of the specific data points as why enterprise databases on containers. So a recent study by Gartner predicts that by 2022, more than 75% of global organizations will be containerized. Again, this is very, very predominant for database deployments also, as database customers are looking for kind of flexibility and then also kind of speed and also some of the key benefits which they can get while deploying containers. And then also some of the other benefits, as you can see, is the startup for container-based deployments will be in the milliseconds. And then there are a lot of advantage with respect to cost, and then also with respect to the speed of the deployment. So, and then also for a lot of customers, again, there is always a question, especially for customers who have already invested and then have standardized on virtual infrastructure. There is always a question, should I do virtualization or should I do containers only? Or is there a benefit of deploying containers on top of virtual machines? So this question, again, the answer to that is definitely yes. There are a lot of benefits of deploying containers on top of virtual machines. Again, the specific, probably I will highlight one or two big reasons. One is the security. And then also the other specific reason is the isoness on VM rather than deploying it on direct bare metal. So especially on a software-defined storage like PowerFlex, which I'm going to cover in the next couple of slides, you get the isolation and then also the consolidation benefits of running multiple container stacks within VM on the same PowerFlex infrastructure. So as I mentioned, let's go through some of the key power positions or key values of what is PowerFlex, and then also what are the key tenets for this software-defined storage are harnessing the software, embrace the change, and deliver predictability. Harnessing the software is through the performance and scalability benefits, including fluidity. And then also the embracing change is with respect to the different kind of deployment architecture you supported. And then also the kind of different consumption models and then the platform support PowerFlex provides. And then also you can be sure of the workload execution predictability here. And then also it provides storage. Again, if you want to go a little bit detail on this. So this is a software-defined storage known for its performance, scale, and resiliency. I talked about performance, how it can provide you that kind of extreme performance. It is due to the unique architecture PowerFlex provides. So PowerFlex architecture, you have like 3 or 4 nodes who are working, who are actually contributing to the I/O. Again, in the PowerFlex architecture, every node of the cluster is contributing with your I/O operations. Again, every single drive on the node is also contributing to the I/O operations. So this is one of the primary reason why you get this kind of millions of IOPS at sub-millisecond latency for any of these kind of enterprise critical applications. So the aggregated resources with respect to nodes and also the drives which contribute to every I/O operation provides you massive performance and also scalability benefits. When I say scalability, again, PowerFlex can be used with a very small footprint. You can start small and then grow big as needed. Again, you can start with like as few as 4 nodes, and then you can scale up to thousands of nodes without any impact to your performance or any latency implications. So the other key thing which is very critical for database administrators is, especially for database deployments, is the resiliency. And PowerFlex provides that 6 nines of availability. So when in a cluster, if for some reason, if there is a planned or unplanned outage, you don't have to, or an IT administrator or a DBA, you don't have to worry about the storage platform because the PowerFlex will automatically heal on its own, and then it will do the rebalancing with the existing nodes. Similarly, once a node is online, again, it knows the node is online, and then automatically the I/O operations are optimized, and then the storage rebalancing happens automatically in the background. So this is really a key benefit, especially for database administrators who are managing mission critical applications like Oracle, SQL, and then also some NoSQL databases in financial and other industries, because they don't have to worry about the backend storage. For the optimized performance, they can focus on their applications, and then also they can make sure that the day-to-day operations are running smoothly. With respect to PowerFlex, again, the other key benefit or the value add is the flexibility with respect to deployment architectures. So in PowerFlex, one of the key differentiation is the disaggregated or the 2-layered architecture. Here, you can have compute and storage resources managed independently, and then also you can scale them based on your need. And also PowerFlex supports if you need a hyper-converged architecture or a hyper-converged model wherein you can have all your compute, storage, and networking resources on the same nodes. And there are also a lot of customers and then use cases where they start with a hyper-converged environment like a 4-node or a 6-node configuration, and then you can, based on your need, you can add your compute resources to the same infrastructure. So you have all this kind of flexibility with PowerFlex, which is very critical for, again, databases and database administrators. And then also I want to highlight the other key differentiation with PowerFlex. Whatever is the kind of application, whether it is like a mission critical databases or a throughput intensive analytic application or like a generic mixed workload or a virtualization or a virtual use cases or a cloud native or container based applications, including AI/ML use cases, and then whatever be the orchestration, whether it is VMware hypervisor or OpenShift or even a bare metal configuration, you can deploy your applications without any performance implications. So PowerFlex supports whether it is bare metal, virtual machine through hypervisors like VMware or Hyper-V, and then also containers on top of bare metal if required. So it provides you this kind of complete flexibility wherein you can confidently deploy different kind of application based on the needs. And then also PowerFlex supports some of the key features which is very much required for databases such as native replication and inline compression, and including a lot of quality of services and also secure snapshots and others. So let us go through a little bit more detail about some of the reference architectures and validations which has been done with PowerFlex and VMware, again, especially on containers for enterprise databases. And I'm going to cover both traditional databases such as Oracle and SQL, including some of the work done with respect to NoSQL or modern databases like Cassandra and MongoDB. So as I mentioned, PowerFlex is an ideal platform for databases as well as containers because of the flexibility which I mentioned. It provides a complete flexible platform, and then also PowerFlex has an orchestration tool which is kind of capable of doing your end-to-end automation, and then also it dramatically shortens your complete life cycle by managing your system end-to-end, including networking, compute, and storage resources. And then also the flexible design, and then also the flexible models, which I explained, like two-layered architecture and the hyper-converged configuration, helps a lot with respect to databases. And then again, especially for containers, you have the flexibility again, depending on your need, you can deploy containers on top of virtualization if required, on VMs, or also on bare metal if required for specific use cases. And then there are also specific use cases where you can deploy some traditional databases like Oracle probably on bare metal if required on the same infrastructure. So this is one of the reference architecture and the validation I wanted to just highlight. Again, this is a SQL 2019 big data cluster, which was actually deployed with PowerFlex, and then also the Kubernetes containers for used with VMware hypervisor. As I mentioned, there are specific use cases, and then there are a lot of advantages of using containers with VMware hypervisor, wherein in this solution, we were able to easily isolate and then also make sure that there are some security aspects are taken care for those containers while deploying this on the VMs. So for this, again, this architecture, as you can see, this was started again, this was like a 4-node PowerFlex configuration, wherein the entire, the big data cluster configuration, whether it is the compute pool and the data pool, everything was configured as containers. And then again, the entire containers were running on VMs on top of VMware vSphere. And then the entire, again, the big data cluster consisted of various data sources like Spark and HDFS, which were used to pull in the data, and then actually the same data was processed through the SQL engine. So this solution, again proved that we can have this kind of a container-based deployment for even like traditional databases like SQL, which is a more effective way of using all the resources. And then also it provides you all the benefits, like, okay, the scale out benefits which you can provide. Again, in this kind of big data cluster deployments, there is always a challenge of data being like growing significantly on a daily basis. So this kind of environments will again help in scaling the environment, and then it's very easy to scale the environment in PowerFlex. As I mentioned, the scalability benefits, you can just add a node, and then automatically the PowerFlex will be doing all the rebalancing and whatever is required at the storage layer in the background. So it provides you the same kind of performance and the scalability benefit. And then again, the SQL big data cluster, again, this is a detailed reference architecture. I'll provide you a link for this solution. Just wanted to highlight that the entire big data cluster environment can be deployed as containers on top of VMs here. And similarly, we did a solution with Oracle, which is one more traditional large enterprise database. Oracle, again, it was done on multiple, operating systems and then multiple container platforms. And then also Oracle 12c and 19c, both were used as there are still a lot of customers using 12c, even though 19c has been released. Again, there is a lot of use cases, especially for Oracle, where the customers are looking for test dev and DevOps kind of environment. Again, in this solution validates that. Again, this was done with Kubernetes containers running on top of VMware. So the links are the URLs for this detailed solution. Again, whatever I shared there is very brief update on some of the key architecture concepts. But again, these are the links, are the URLs for these two solutions, which will provide you all the details, including sizing, how you deploy, and the reference architecture for these two solutions. One is the SQL 2019 Big Data Cluster on PowerFlex with Kubernetes and VMware, and the other one is the Oracle on Kubernetes with VMware running on PowerFlex. So as I mentioned, in addition to traditional databases, again, NoSQL databases like Cassandra or MongoDB, these are very predominant with containers. Again, PowerFlex as can provide, not only it can support any kind of virtualization or bare metal, and then also it provides support to bare metal configuration and containers. And then it also has all the support required for deployment of containers like CSA support. And then also the benefits which you can get with respect to scalability is really ideal for these kind of NoSQL databases. And then what you are seeing here are some of the solutions which we have validated for cloud native applications like Cassandra on top of PowerFlex with Kubernetes. So just to conclude, whatever is the kind of applications, whether it is traditional databases like SQL Server or Oracle, or whether it is like a modern NoSQL database like Cassandra, or an analytics application like Elasticstack or SAS, PowerFlex can provide you the most predictable and performance-driven outcome for your applications. As you can see, some of the in-house performance numbers here, the number, like you can get up to 10 or 11 million or more than that IOPS for any of your applications with kind of sub-millisecond latency. For an application like Oracle, you can get like 10 million IOPS with sub-millisecond latency. And then also for modern applications like Cassandra, you get up to like more than 300, 400K operations. And then the key thing I wanted to highlight here is these are all performance numbers which you can expect or get from PowerFlex with sub-millisecond latency.
Good afternoon, good morning, good evening, wherever you are. My name is Mark Stockham. I'm a field CTO with Dell Technologies Data Protection Solutions, specifically working with VMware technologies. And today we're going to be talking about data protection for multi-cloud in VMware environments. So, what do we mean initially by multi-cloud? Multi-cloud for us in this context is those on-premises, those hybrid, those multiple public clouds, any or all of the above, being able to operate in all of those clouds and give data protection solutions regardless of where the workloads run. Which hyperscalers are we going to be talking about? Primarily AWS, Azure, and GCP and Google. There are others that we'll touch on, but primarily those three. The most appropriate use cases will be covered for data protection relating to all of these clouds. We'll discuss optimal architecture. We'll be looking at some of the critical workloads, and we'll also touch on automation elements for reasons that will become apparent a bit later on. So to start off with, what are the most appropriate use cases? Today we're going to be talking about long-term retention to start off with. We'll then be moving on to cloud disaster recovery, backing up into the cloud from on-premises environments, and also backing up from within the cloud itself. In all of these scenarios, we're going to be looking at it from a data protection storage perspective, so the data domain, be that a physical appliance, a converged appliance, or a virtual appliance, and looking at things also from a data mover perspective, so the data protection software itself. In all of these scenarios, performance, efficiency, and the ability to operate in the multiple clouds, Amazon, Google, Azure, as well as VMC, etc., are going to be addressed in the use cases. So, first scenario, long-term retention to the cloud. In this case, we're going to be using the cloud to give us the ability to hopefully reduce our reliance on tape, on those less accessible mediums, those things that take us longer to get data recovered from. So we've got the on-premises environment, we've got an active tier carrying out operational day-to-day protection and recovery. We're taking some of that data that has aged out and we're moving it to the cloud tier. We have a long-term retention tier, if you like, using S3 compatible storage. So in this case, looking on premises at something like Dell EMC ECS, Elastic Cloud Storage. But the topic for today is, of course, the cloud. So equally, we can take that deduplicated, that compressed, that encrypted data, and we can move it into the public cloud. Use a public cloud provider purely for their storage. So we have the ability to use AWS, Azure Blob Storage, AWS S3, Google Cloud, various other clouds, purely to give us that storage capability. So we're taking the highly efficient deduplication that the data domain gives us in the first place. We're able to take that policy engine, use that policy engine to decide what we're going to move to the long-term retention, the cloud tier. We can scale highly based upon the physical appliances that we can deploy. We can also use a data protection appliance like a PowerProtect DD series 3300, 4400, giving us an entry point, much lower entry point. And we can take, even if we want to, a virtual appliance, a DDVE, and start at something like a 1 terabyte incremental increase of storage, and deploy that and use that as the on-premises storage. We can support third-party data movers, but obviously better deduplication is achieved with Dell Technologies solutions, and this helps us to move away from the likes of tape. So this is an entry point, if you like. This is using the cloud environment purely for its cheap storage. Moving on to the next level, cloud disaster recovery. So taking your virtual estate, your VMware estate that runs day to day, taking that environment, protecting the data onto a data domain on premises, be that physical, appliance, etc., and then taking some of that data and pushing it again into cloud storage. In this case, Amazon S3, Azure Blob, and making sure that we have copies that are available in the cloud. Should we want to spin that workload up in the case of a disaster recovery, we can convert that image, we can pre-convert it, or we can convert it on the fly and run it as an EC2 instance. The same thing can occur for Azure, so we can convert it to an Azure VM image and run it there. Pre-conversion also available should we need to or want to. But if we do want to run it just as another VM, if you like, we can also leverage VMware Cloud on AWS and just run that, or just take that image, bring it up, restore it into as a VMware VM, and we can then run that in the cloud, carry on running, and then should we need to move that workload back on-prem after the disaster has passed, we can vMotion that virtual machine back on premises. So we've got two options. We can take the option to run it as an EC2 or an Azure image, or we can run it in EC2. What this means is we've got this orchestrated failover capability into the various clouds. Recovery can be minutes. If we pre-convert some of these images, pre-conversion can be run on a regular basis. Once that image is uploaded into the cloud, we're able to recover in minutes. We can have recovery point objectives as short as 15 minutes, seamlessly integrated with what's going on premises, and application consistent recovery is available in Amazon itself. So this can replace a secondary or a tertiary data center. I've seen this in a lot of cases throughout EMEA, which is the region that I cover. So can obviate the need for making high physical hardware purchases, and also the cost of facilities managing entire premises. So what about if we want to actually back up from on-prem into the cloud? What does that look like? Of course, we've got the usual efficiency of DD Boost. We deduplicate to the client side, we compress, we encrypt. That information is protected on premises. We could then take that data and move it into a data domain virtual edition, a PowerProtect DD virtual edition, running either in Google Cloud, in Amazon, or in Azure. And this gives us the ability to leverage the lower cost of running natively in those cloud environments. Being able to run in EC2, for example, is much, much cheaper than running in VMC. What we can get here, really, in which we cover that use case. So we don't need to use on-site storage. Boost takes out a lot of the pain of ingress, of moving data from on-prem into the cloud, and it gives us a multitude of deployment options. Use case here could be a remote site with a very small footprint, not enough footprint to deploy even a data domain virtual edition or a small appliance. If you have limited WAN capabilities, the ability to carry out this client-side dedupe allows us to minimize the amount of data that gets transitioned. And the facilities on site may not be suitable to host data protection storage. It might just not be suitable. So this is the scenario that we see in a lot of cases, customers wanting to take the data, move it out, and store it initially in the cloud. So just jumping very briefly into an architecture slide. The architecture we're taking into consideration here is the use of virtual proxies, client-side deduplication, giving us the ability to do change block tracking from a VMware perspective, and take as little data as possible to move it across the network, to then let it reside on the highly efficient protection storage, giving us minimal footprint. We'll cover why that's important very soon. But the highlight here is, whenever you move to the cloud, between clouds, between zones, availability zones, regions, etc., or when you egress, obviously one of those hidden costs is the cost of moving data. The less data you move, the better things tend to be. And also, if we're doing this from a software-defined perspective, automation is something that we can leverage, and we'll come on to automation in a few slides' time. What we can also leverage here is a lot of the in-stack and vRealize automation capabilities of the stack, and that data efficiency really does pay dividends when we're not just on-prem, but also in the cloud. So what about if we have existing platforms that we're running on-prem and we want to replicate that data elsewhere? Well, again, the efficiency that we have as part of the platform, the deduplication, the compression, the encryption, allows us to take that data and then just carry out a replica between the on-prem environment and the PowerProtect DD Virtual Edition running in either GCP, AWS, or Azure. And what this means is we're able to take that data and get it into the cloud in as quick and as efficient a manner as possible. Some customers just want to be able to move their data and get it into the cloud so that they can leverage it and replicate it elsewhere. We've got the ability to support third-party software should we require it here. Very easy to deploy through the various different marketplaces. Latest and greatest versions have been released in the past week or two on some of these platforms, and this means that reduces that ingress-egress cost, means that that bill shock is reduced or minimized. So what about where we have VMC, VMware Cloud, for example? In this scenario, we've got the on-premises environment. It's running as you would expect, all your virtual machines, vSAN, ESX, NSX, etc., etc. We're also able to configure and run the environment in hybrid link mode, so we have that VMC instance that looks, smells, feels exactly like what's being run on-prem. So that's great from the perspective of being able to run workloads either on-prem or in the cloud in a hybrid and a seamless fashion. But from the data protection perspective, what we really want to be doing is making the most of the adjacency that we have between the VMC instance and the native Amazon facilities that reside next to it. In this case, we're able to run PowerProtect DD Virtual Edition as an EC2 instance using S3 storage. And because it's sat literally next door to the VMC instance, we've got high bandwidth, we've got a variety of methods of connecting to it, which gives us the ability to drive down cost for protecting those workloads that reside in VMC. We could equally run it in VMC, but it's a more cost-efficient option to deploy in native Amazon. What do we get here? Enterprise class data protection for VMware Cloud and AWS. We get that image-based protection capability, instant recovery of those workloads either within the VMC instance, or we can vMotion them or just run them on premises. We've got the ability to store in S3, which gives us that cost benefit. And it's a consistent and seamless operation experience for the VMware operator. We'll come on to that a little bit later on from an automation perspective. What about when we're protecting workloads from an in-cloud perspective? So in the scenario here, we have a multitude of applications that reside on-prem or in the cloud. In this case, cloud applications. We have a specific set of application tools that allow us to take that data and move it from the client directly to PowerProtect DD Virtual Edition residing in Azure, Amazon, Google GCP. The ability to take that, leveraging all of the existing benefits, the deduplication, et cetera, the minimization of network traffic, and fundamentally giving higher performance, lower backup window times, being able to manage this stuff on-prem and let it reside in the cloud. And a lot of the deployment capabilities are available through those marketplaces. So it makes a lot of sense to be able to leverage the benefits of being able to run PowerProtect DD Virtual Edition in the cloud on whichever cloud provider you want, and be able to protect those various workloads that you are interested in. Not forgetting the likes of Kubernetes that are covered in other sessions and other topics of much discussion elsewhere, but are also protected by our PowerProtect suite of products. Mentioned earlier on about the low cost footprint. Just a very brief slide here. The way in which we deploy in AWS, for example, natively on EC2 is a much more efficient from a deduplication perspective. So we're able to store much less data to protect the same workloads. We're able to use less compute instances, so the cost of EC2 compute will be lower. The cost of storage will be lower from a block perspective, and the cost of object storage will also be low based upon the lower footprint. And you can see some comparative costs in here, but just to make the point that it's not just about the minimization of the network traffic that we mentioned earlier on, but also if we're running natively in the cloud, we're able to drive down costs there too, which is obviously a key driver for most customers moving to the cloud for cost reasons. Now, all of this would be slightly irrelevant if we didn't have a way of managing the entire environment. So we're able to use Data Protection Central to get a single view of what's going on throughout the environment. A number of ways in which we can deploy and utilize this. This is not the only way in which we can do this. We also have the ability to tie into the likes of Tanzu Mission Control, but that's a topic for the cloud native side of things. Just want to make the point that all of this needs to be visualized and managed in an effective fashion. And while we're speaking about management, it'd be remiss of me not to mention vRealize automation. So taking the scenario we just mentioned where we had on-prem, we had VMC, and we've got the native EC2 data domain running in EC2 natively, we also have the ability to tie into vRealize automation. So vRealize automation being that element that gives us full lifecycle management of those VMs, regardless of whether they're running on-prem or in VMC when we're in that hybrid link mode. Now we have a comprehensive set of vRealize integration capabilities right now, regardless of which data mover that is being used. But the product management have asked me to give you a sneaky peek into what's coming soon, what's coming next. So as you're no doubt aware, vRealize 8.0 released earlier on in the year. vRealize 8.2 integration for our data protection extension will be published shortly. What this will allow us to do is give customers, yourselves, the ability to create policies which can then be exposed through vRealize automation and can be attached to virtual machines, giving us those day two operations for protecting, backing up, restoring to new and various other tasks that you'll be familiar with from vRealize Automation 7 that we will be the first to promote, to produce for vRealize 8.2. That's something that will be coming out later this year, but watch this space. This should be the first you've heard of it. So in summary, what we're talking about from a data protection perspective are solutions that map across all of the VMware cloud delivery options, regardless of whether you're on-prem private cloud, whether you're using some sort of subscription model, VMC on Dell EMC, AWS public cloud, GCP, Azure, etc. All of these delivery options are covered. We can protect workloads in those clouds, from those clouds, replicate to, restore from. In addition to the obvious Kubernetes, Tanzu, vRealize integrations that we've mentioned also. And this technology that we use, the architecture that we use, gives us a significant benefit right now. And watch this space throughout the whole of VMworld. Look for Dell Technologies data protection solutions and see what's coming next, what we'll be announcing, and what's coming next to further enhance the way in which you can protect your workloads when they're running on any of these VMware platforms. With that, I'd like to thank you for your time and your attention. And if you do want to get in touch, my name is Mark Stockham, mark.stockham@dell.com. Please feel free to reach out, and I'll be happy to answer any questions. Thank you very much for your time and attention.
This is Shashi from PowerFlex product management team, and I mainly focus on developing applications and workload solutions for PowerFlex. And in today's session, we'll talk about some specific use cases and applications for high-performing machine learning solutions like Elastic Stack on PowerFlex with VMware. So just a brief update or a brief summary of what is Elastic Stack and its use cases. So Elastic Stack, previously known as ELK Stack, is kind of a combination of 3 different modules, open source modules. One is the Kibana, Elasticsearch, and then also the key other module is the Logstash. Again, the Kibana is the component which again mainly handles the visualization and manageability. And then the Elasticsearch is the open source tool which takes care of the entire data ingestion, enrichment, and then also the storage analytic operations. And then the Logstash is a component which kind of takes care of all the ingestion and then again feeds that ingested values into the Elasticsearch, and Kibana helps in the visualization. So all these three components together is called as elastic stack, which has become very popular now for customers who are challenged with really exponentially growing, very mission critical and high throughput intensive machine language and analytic applications. So why again customers are interested in Elastic? Like first thing is again Elastic is open source. Again it is definitely becoming very popular. Again a lot of customers are looking for alternatives. There are some leaders in this field, but again customers are looking for alternative because machine data analysis is becoming more expensive and then also very challenging with respect to performance and also other throughput and scalability requirements. So they're looking for a more efficient way of handling this kind of data. And then also they're looking for platforms or infrastructure which can be scaled easily and then also provide some kind of a really predictive and then also predictable performance and then also with respect to reliability and other benefits. So these are the key challenges again customers are looking for, and then Elastic is one of the very popular open source tool which is again gaining really good traction. And then again customers are looking for deploying this kind of deployments on containers with virtualization, because that's the way they can actually address a lot of challenges with respect to these customers, because they have that kind of flexibility now wherein they can actually manage different kind of or different challenges with respect to performance with different applications and containers and also the VMs. So let's talk about PowerFlex. Dell EMC PowerFlex again is a software defined storage. Again the three key tenets are harness software, embrace change, and deliver predictability. Again, when I say harness software, Dell EMC PowerFlex is the software-defined storage, which is really known for its performance, scalability, and fluidity benefits. Again, when I say embrace change, the other pillar is the deployment options PowerFlex provides, and then also the different options with respect to the platform support, whether it is 2-socket or 4-socket, and then also the consumption models, whether you need a completely engineered system or an appliance model, wherein you can bring in your own networking. So you have all that flexibility and deployment options with PowerFlex. Again, the other key tenet for PowerFlex is the predictability. You get 6 nines of availability, and then also the automation which you get with PowerFlex Manager, which is the orchestration software, is very unique because it can actually provide end-to-end automation and orchestration capabilities for your entire stack, including networking, storage, and compute resources. And whatever is your challenges with respect to workloads, whether it is performance or reliability, PowerFlex can provide you that kind of predictability. So they get a little bit more details on the PowerFlex software-defined storage. Again, PowerFlex is known for performance, scale, and resiliency. How does it provide that kind of massive performance? The PowerFlex can provide that kind of unique massive performance because of the architecture, the unique architecture which PowerFlex has. On a PowerFlex system, every node on the cluster, including every drives sitting on those nodes, actually contribute with the IO operations. This is one of the main reasons why, because of this aggregated resources, you get millions of IOPS with sub-millisecond latency. And then also you get the same kind of throughput. And then also when you scale your environment, because all your nodes and drives are contributing with IO, you get the same kind of benefit without any latency impact. When I say scalability, I talked about the key benefits with respect to latency and also the performance benefits. Again, as you can see, you can start probably with the 4 nodes, a very small footprint of 4 nodes, and then you can grow up to like hundreds or even up to 4,000 nodes. We actually have customers who have more than 11,000 nodes in their infrastructure data center, and then also with almost up to 300 to 400 nodes on a single cluster. So PowerFlex provides this kind of unrestricted scalability, and then again, whether you use 4 or 400 nodes, you get the same kind of benefits with respect to performance and without any latency impact. And the other key tenant or the key unique value add or the differentiation with PowerFlex is the resiliency. Whether you use 4 nodes or 400 nodes, as I mentioned, you get the same kind of performance. Again, the other key thing, which is very critical for a database administrator or a analytic administrator, is the reliability of the storage. So on a PowerFlex cluster, if for some reason, if there is a planned or unplanned outage of a node, then the administrator or the application administrator does not need to worry about that. The PowerFlex storage will automatically take care of rebalancing the remaining IO operations, all the IO operations on the remaining nodes, and then also it will make sure that the IO is completely rebalanced on the other existing nodes of the cluster. Again, similarly, once that node becomes online, it will automatically make sure that the IO is completely optimized by rebalancing across all the nodes available on the cluster. And the other key thing I think which I mentioned as one of the tenets of PowerFlex is the flexible deployment architecture. So PowerFlex offers a unique architecture called a disaggregated or two-layered architecture, wherein you can have your compute and storage resources independently managed, and then also independently you can scale them based on the need. This is very unique architecture by PowerFlex because especially in analytics application, typically you don't need to scale your compute resources all the time. There is always a lot of data being ingested to the system, and then most probably your scalability requirements are only with respect to capacity. So in this kind of scenarios, you can actually independently scale your storage nodes and then keep your compute nodes as it is. Or in case if there is a requirement, you can also increase your compute resource as per the need, which is going to give you a very predictable and then also very cost-effective architecture for analytic applications. And also if there is a need for you to have all your compute and storage resources as a single system, as like a hyperconverged model, PowerFlex even provides, offers that, and then also it supports that. And then also a lot of customers start with a hyperconverged configuration for some specific use cases, and then based on the need, you can actually add only compute resources in a two-layered architecture as per the need. So as you can see, PowerFlex can provide you all these different kind of deployment models based on your need with the same infrastructure. And the other key thing I just want to highlight here is whatever is your application, whether it is like a very high throughput intensive application, like analytic application like Elastic Stack, or a SaaS grid, or any databases, or any other cloud native or container based applications. And you can deploy that on PowerFlex on the same infrastructure, and then that is the kind of flexibility you get here. So as you can see, PowerFlex can support bare metal configuration, wherein you can deploy some applications like Oracle RAC or any other traditional databases, or you can even have native applications running on containers, or you can even deploy virtual machines. And then also, if required, there are a lot of use cases where customers would like to prefer deploying containers on top of VMs for specifically addressing some isolation and security aspects, and even that is supported on PowerFlex. So you can see the kind of broad platform support PowerFlex provides for analytical applications and then also other mission critical applications here. And then also PowerFlex provides some of the very features which is very relevant, and then also which is required by large mission critical applications like native replication and compression, which are very effective for managing your huge ingestion and then also the growth in analytic applications like AML and other cloud native and then database applications. So let's go into detail of little bit of specific validation and then also some of the reference architectures we have developed with Elastic Stack on PowerFlex with VMware and then containers. So we have a reference architecture. This is a partner validated solution. We worked very closely with Elastic team here, and then we have come up with we have validated a solution wherein PowerFlex was used as the storage infrastructure, and then with VMware Hypervisor, we used Kubernetes containers on top of VMware Hypervisor to deploy the entire Elastic Stack components, which is Logstash, Elasticsearch, Elasticsearch, and Kibana, and all those components which I explained previously were deployed on top of VMs here, like on the virtualized VMs, and then again, ESXi 6.7 was used here as the hypervisor. And then again, this solution actually is completely validated, and then also it's not just, when I say validation, it's not just a validation of the architecture. We also did a quite detailed performance benchmarking on this solution to see what is the kind of value, because there is always a question by a lot of Elasticsearch or any analytic applications, analytic customers saying that, hey, if I virtualize this kind of environment, especially this kind of throughput intensive applications, what kind of performance can I expect? Because they're always worried about this kind of throughput intensive applications. Again, there was always a concern. So we have done like detailed performance benchmarking with the tools, which is completely the industry standard tool, which is developed by Elastic to make sure that what workload we are simulating is very realistic here. So as you can see on this ESXi 6.7 based PowerFlex cluster, with this cluster, we were able to achieve more than 1 billion events within 3 hours. Again, this is again a very basic 4 storage node cluster. As you can see, it's a very starting point of a PowerFlex node cluster with a 4 node storage only cluster. We were able to hit more than 1 billion events within 3 hours. And then again, this is the kind of performance you can get. So these numbers are like phenomenal. And then as you can see, again, when we grow your PowerFlex nodes from 4 to 8 or again more than that, you can get the same kind of linear scaling and linear performance benefits. So again, the other advantage, as I mentioned, is you can even scale only storage if required, or you can scale compute only if required based on your needs. So these numbers are again available in the link what I'm sharing in this. So you can go into the details of that white paper and the detailed reference architecture which I showed here, and then you can get all the details about other key performance numbers which we were able to get from this testing. Again, as I mentioned, like why PowerFlex for Elastic? So PowerFlex, as I mentioned, is known for its high performance and scalable block-based storage, which is really ideal for applications like Elastic Stack, because Elastic Stack customers are looking for this kind of high performance scalable solution wherein they don't have to worry about the challenges with respect to scalability and the daily ingestion. And then also if they need to scale, how easily they can scale without any, worrying about what needs to be done at the storage side. So, and they can focus entirely on their application and tweaking the application for day-to-day operations. And then the other key things, again, as I mentioned, is PowerFlex supports any hypervisor, including VMware, or you can even do bare metal or even on containers. And then the scalability of compute and storage resources independently is one of the key, really key factor. And the other thing I wanted to highlight, especially with Elastic Stack solution, again, Elastic is a GCP partner. Already the Elastic Stack is available. The entire Elastic Stack is available through GCP partner today on GCP Marketplace. Again, a lot of customers are looking to deploy this on top of containers, and then there is a lot of traction happening in this area. And then PowerFlex is already validated for Google Anthos, and then already there is work going on, and then there are some POCs and investigations, and then more work happening wherein we are investigating and trying to validate solutions where you can deploy Elastic Stack on top of containers with PowerFlex. And then also Google Anthos is one of the solutions we are validating. So just to conclude here, again, as I mentioned, for Elastic Stack especially, we were able to achieve 1 billion plus events with just a 4-node storage-only configuration with 3 compute nodes, and again with 3 hours. So this is with Elastic Rally benchmarking tool. And then again, as you can see here, it's not only analytic applications, like again, Elastic Stack and SAS Grid, as you can see, are some of the examples for analytic applications here. But even other applications, whether it is like a traditional database like Oracle or SQL, or even a NoSQL database like Cassandra, you can get the same predictability, or you can get the same performance benefits and the scalability benefits for these kind of applications on PowerFlex. Actually, I just wanted to highlight here that I'm covering some of the specifics or more details on some of these traditional databases and NoSQL databases, how you can deploy and what are the benefits with PowerFlex in another vBrown session. I'll be really happy if you can please also join that session, and then if you have any questions, please let us know. And then again, I just wanted to highlight the resource link here. Again, this is the detailed reference architecture, partner validated solution, which we have done with Elastic. Again, this has all the details with respect to what are the guidelines, and then also the sizing. And then also it has all the details with respect to the performance results, which I shared, like how we were able to get this kind of performance. And then also some more details about the test configuration, and then other test tunable parameters and all the details here. Again, I just wanted to end with a customer testimonial here. Again, PowerFlex, as I mentioned, is already, again, we are seeing a lot of traction of deploying this kind of AI/ML or analytic applications with PowerFlex. Again, we have a large North American bank. Again, they were really impressed when they were able to ingest more than 25 terabyte in 18 hours with just 5 VMs. That's what I wanted to highlight here. It's just 5 VMs, and then they were able to get 25 terabytes. So this is the kind of performance you can get. And then also the other scalability and linear scalability and the reliability benefits complements this. So this is a really great solution for analytics and any machine language or any kind of AI/ML kind of workloads. That concludes my session. Thank you.
Hello, everybody. Thank you for joining for this session today. Today, I'm going to talk about VxRail in the real world. I will share some experience that I have with this kind of appliance. And I will share with you some tips and tricks, okay? Well, I'll talk a little about me. My name is Arno Santana. I am a Brazilian. And so I have more than 20 years in experience with IT infrastructure, especially with VxRail. I started with 400 of VxRail, it's a EvoRail, okay? And if you want to learn more about me, access my LinkedIn, have an entire description there, and can you contact me through LinkedIn, okay? And then I will start our agenda for today. The first part of our presentation, we are talking a little about key points of VxRail, and after we are describe some important steps or key points or some tips about the installation, and after install, we have some key points to pay attention, and some tips and some problems I faced during the updating the device. And I will share some tips with you, and and some reference and docs to solve possible problems during the updating or during using the device in day by day, during the day by day. Okay, so the key points of VxRail. In my opinion, VxRail is a game changer. For me, is the best HCI solution. I have some experience with other players, other solutions, but for me, if you use VMware, if you have this free infrastructure, VxRail is the best solution, because the true single pane of glass, you can do everything on the same screen, the vCenter screen. And this is great, because other solutions, maybe you need to go out of the center, perform some tasks, return to the center. In this case, it's not. This is truly real single panel of glass. You do everything inside the center. The interface, you are very well customized using on your day-by-day IT administration, IT infrastructure administration. And the other interesting fact is the compatibility fully compatible with vSAN. Some years ago, during VMworld, I'm not remember the exact year, I watched a presentation about problems with vSAN. And one of the most common problems with vSAN is about compatibility. The other thing is very interesting about VxRail is the real on-click update. You press on button and everything goes automatically. You know, do you have firmware updates? Do you have vSphere updates? Do you have vCenter updates? Don't worry about these, and the process is very automated, and you don't need to take care. You don't need to worry about this. You don't worry about, okay? And the other interesting fact is the unique point of contact. If you have problem, you just call for one person, one number, and they will solve your problem without need to contact many vendors. This is a great advantage of the HCI, and especially when you're working with a VxRail. Well, now I will share some tips about the installation. The first one is don't ignore the requirements, especially about network and DNS. You need to spend some time planning your installation, and it's very, very important using the solve procedures for install. I have experience with more 200 devices deployed, and every installation is a new installation, and every installation do you face different kinds of problems, and many times the problems are occurring because sometimes you will not check and try the requirements, especially about the network. Okay, and it's not a problem if you spend some time planning your installation, reviewing requirements. Okay, and reading some solve procedure, special notes about the installation before you start the installation. Okay, if you are using Dell network suites compatible with smart fabrics, evaluate the benefits of use this feature. Okay, because when you use smart fabric switches, do you not need to configure the switches? VxRail configure automatically the switch for you. This is maybe save time during the deployment. Okay, many people said no, this is not so good. But if you deploying a cluster with a lot of nodes, maybe this is a good idea. Well, it's preferred to use the switches in the mode, not in the stacking mode. Prefer to use VLT if you are using Dell networking, or VPC if you are using Cisco switches, or other manufacturers have different names for the same feature. I don't recommend the use of stacking, because when you use Tor switches in the stacking mode, when you need to perform some kind of maintenance, like primary updates, you can incurring on network disrupt and network down, and this is not good. And when you're planning your network for HCI solution, especially about VxRail, we recommend to use two switches. And in this mode, VLT or VPC, they are working independently. But outside, if your other switch looking for this, the other switch see like one switch, okay? But do you have benefits about this configuration? Because you can perform updates without any network outage, okay? VxRail requires some specific VLANs, and you need to configure that. before you start your implementation. When you after you put the device on the rack, you need to cable them. When you are cable them, pay attention in the ports. Don't worry about network interface cards outside the onboard interface cards, because the setup using only onboard cards, okay? And my recommendation for this is using odd ports in on switch and even ports in another, because VxRail that have a predefined network organization, network layout, and if you're looking in the network planning guide, this document you can find during the LMC websites. At the end of the presentation, I will share the address of the LMC websites when you where you want to find this kind of documentation. After installing the devices, after cable the device, I recommend to configure all iDirect of all nodes first, because sometimes I face problems. I had problems with some implementations. I remember a specific case. I spent a lot of hours believing that the problem is network configuration. And in fact, the problem was a problem. You need to look at direct console user interface of each node and look if the information about PSNT is present. Some nodes produced last year have a bug with this, and they don't have PSNT identification, and these they not can be found during the cluster configuration. And because of this, I very, very recommend to configure iDirect first. Look if each node are health. Look for hardware problems before you start your implementation, in fact. In case of using external vCenter, take a look at VxRail vCenter Server Planning Guide. This is a document because not every vCenter configuration are supported on the VxRail installation. Especially when you use external vCenter Server, you need to check not only vCenter Server Planning Guide, but support matrix. You need to check if you are using the correct version of the vCenter Server before you start your implementation. VxRail Manager have the full IP address, but I really, really recommend you to change for a definitive IP address before you start your cluster building. Okay, and for 2-node cluster, I really recommend you to configure a witness traffic separation, a special network, a separate VLAN for this, and take care with you the witness about 2 facts. The documentation about 2-node cluster is very, very simple, and sometimes you face a lot of the problems with 2-node clusters because it's not so common implementation. It's not well covered in the training for implementation of VxRail. If you perform VxRail implementation course, it's a small portion of the course that they talking about 2-node cluster, but 2-node cluster is a little difficult to put on production because the documentation are simple and not cover all aspects. My recommendation is for this is use the same version of the rules about the vSAN witness. When you download and deploy the vSAN witness, take care with this, because if the vSAN witness has a different disk version than the hosts, you can't perform the deploy of the VxRail 2-node cluster. Okay, Well, if it's happening during your installation, you face this screen, do not panic. I face this kind of the problem in some implementations. In the most of case, just press try again, and this solves the problem. Many times this is occurring because some tasks do not perform at the correct time, and because of this, you face this kind of the problem during the implementation. But just press try again. If this doesn't work, look at the log and try to do the task manually. Example, in one of my implementations, I faced a problem with a specific step when the configuring enhanced vMotion compatibility and the installation stopped. I faced similar the screen of this, but I just read the logs and enable Ransom Center compatibility manually and done problem, and the installation, and I press try again, and the install continue, and the cluster was deployed with success. After install, it's very important to rename entities, because the X-Rail after the installation has different names. It's not different, strange names. Not to say strange is the best word for this, but many customers, many people want to rename the entities. But my recommendation is look for the solved procedures for this, because not any entity can be renamed. Okay, and the solved procedures are very, very complete about this. They have step-by-step instructions to perform renaming entities. Okay, enable vSAN perform services is very important too. Enable Skyline, the online health check. I recommend this because before you enter in production, the environment start production. This is very important. You make a health check of your cluster using the online option. If you want to use the duplication, compression, and encryption, this is the time before you put the device in production. Because when you activate, when you enable these features, it's necessary to reformat the disks. And this task is time consuming. And the other thing, during this task executing, you have limited availability. Because of this, I recommend, and after install, before you move your workloads to the new cluster, enable this, okay? And the other very important step is enable ESRS, the call home function of the X-Rail. And this is not only used for problems. Recently, we have ACA as an analytical consulting engine. The data transferred by ESRS are used for analytical consulting engine. Analytical consulting engine is a very new feature introduced last December. And it's very, very interesting because this feature provides information, analytical information about your cluster and perform updates. When you perform updates, I prefer, for my experience with a lot of implementations, to use offline bundle and the internet upgrades, especially when you are deploying more than one cluster in the same organization. Maybe this is a strange scenario, but it's not so strange for me. Because we have a limit on the standard cluster of 64 nodes, and sometimes some companies work with 2 or 3 clusters. And sometimes when you need to deploy one more than one cluster, you need to do that. Download the offline bundle and perform updates faster than you use the internet upgrade. Okay. If you found errors during the upgrade, don't worry. Again, don't worry. Just press try again. It's most cases enough. Okay. And I performed installation here in Brazil in a customer, a lot of 2-node clusters in remote regions of Brazil. And some regions don't have good power sources. And sometimes during the update, I face a power outage. Okay, don't worry if it is occurred because you just power on the solution again and the update continue. Okay, very rarely you face a problem that you need to contact support to solve this kind of problem. And if you face some error during the upgrade, please look the log. Sometimes the log have more information, more detailed information that help you to solve the problem. Well, solve the problems before you can contact the support. Okay. Before contact support, take a look at event code reference. And this, I put some reference here, just 2 links because this documentation changes every day. And just put two links. The solve online, the solve has a lot of procedures step by step. And the InfoRub. InfoRub is an entire documentation about VxRail. So for today is this. Thank you for your time. And you have doubts, feel free to contact me. Okay, thank you.
Hello everyone, my name is David Santos. I'm an NSX engineer, and today we're gonna talk about the NSXT 3.0 integration with Kubernetes. So this is the last CNCF survey from the last year, when Kubernetes users talk about their experience with Kubernetes and also what they think that are the biggest challenge to use that solution. In this case, we have here the first one is like culture change. So the way that we deploy in Kubernetes is a little bit different than using other platforms to develop. And also they have some challenge with security, complexity, and monitoring network. And from like the 6 major issues here, we can use NSX to address 4 of them. That's security, complexity, monitoring, and training. And this session, we're going to cover these 4 challenges. Kubernetes use something called Container Network Interface, or simple CNI. And this allows that some vendors like VMware develop a third-party plugin to integrate with Kubernetes and deliver network. And NSX use this integration behind as the integration with NSX will be done by a component called NCP. That's the NSX container plugin. So in the left side we have Kubernetes, and in the right side we have NSX. And to do this integration, we're going to have here in the middle the NCP. NCP will talk API with Kubernetes and talk API with NSX. NCP is some containers that run in the Kubernetes cluster. We have some containers, some pods actually, that run in the master, and also others that run in the workers, and they will exchange, like they will translate the Kubernetes language to the NSX language. Basically is what NCP does. So in Kubernetes we have namespace, and when NCP figures out that there is a new namespace in Kubernetes, it will tell NSX that a new namespace was created, and automatically NSX will create a segment to host that namespace, and also all the routing that's needed using a T1 gateway. And if it's a netted network, it will create also the net rules. We also have the pods that will be hosted in that namespace and will be connected to a network, to a segment. So NSX will create a container interface and will connect that container interface to that segment, providing also the IP address to that pod and everything that's needed to communicate. Here in Kubernetes, we can deploy security rules, like we can enforce our security posture using a network policy. In NSX, we're gonna control that using the distributed firewall. Here we have 2 ways of doing that. We can deploy the network policy using the Kubernetes CLI, and also we can create the distributed firewall rules in NSX that will be applied to the pods that are running in Kubernetes. So both ways are fine and work well. Also, we have the ingress for load balance, for L7 load balance. This way, when you create an ingress here, everything that's needed for that ingress work, the rewrite rules, and also the load balancing rules to the pods, to the pool, and also the inclusion of that pool and that pods in the pool. All of them will be done automatically in NSX. Also, the service, like if you do like a service layer 4 load balancing, we also can use the NSX for that, providing L4 load balancing for the pods. So to start this integration, we have Kubernetes that will deploy the pods, and NSX that will deploy the connectivity. So this way, NSX will be integrated to Kubernetes using a YAML file, and for everything that's created, it will deploy the firewall rules, the networking, the L2 networking, the L3 networking. Here we can have routed networking and also netted networking. We can also have the load balancing rules here and apply tags to everything. The way that tags work here allow us to create firewall rules based in tags based, and also load balance rules tag based. So when you tag a pod, when you tag like an application, automatically we include that pod or that application in a load balancing or in a firewall rule. So NSX will provide routing, switching, load balance, either L4 or L7, and distributed firewall, and also visibility. Visibility is something really nice that you can check, like the connectivity from like a container pod or a pod port to a database VM, and check the communication between them. If you have like a firewall rule that's blocking the communication, or if the communication is working fine. So to start, we're going to create a namespace. The namespace will be created as cub control, create namespace vBrownBag. This namespace will be created, and also the source net rule. So here we're gonna create the cub code, create namespace vBrownBag, and here you can check the namespace was created, and also the, let me just zoom here a little bit, and also the logical suite that will host the containers to that namespace. So the next step is to create an application. So our application will be called vBrownBag application controller. We have here two sets of application controller. One is the web and the other one is the app. So when you create that, we will create two pods of each one of the replica sets, the replication controllers. We're going to apply the configuration, and we're going to check here the container creation. After a few seconds, everything is created, and you can check here that they are also connected to my
Hi everyone, my name is Karol Boguniewicz. I'm an expert and engineer from VxRail technical marketing team at Dell Technologies. The topic for this session is vSphere and VxRail REST API. Get started in an easy way. And if you open that, then I assume that you're interested in RESTful APIs. And that's
Hey, this is Shashi. I am from PowerFlex product management team, and I focus on developing applications and workload solutions with PowerFlex. In today's session,
NSX will be integrated to Kubernetes using a YAML file, and for everything that's created, it will deploy the firewall rules, the networking, the L2 networking, the L3 networking. Here we can have routed networking and also netted networking. We can also have the load balancing rules here and apply tags to everything. The way that tags work here allow us to create firewall rules based in tags based, and also load balance rules tag based. So when you tag a pod, when you tag like an application, automatically we include that pod or that application in a load balancing or in a firewall role. So NSX will provide routing, switching, load balance, either L4 or L7, and distributed firewall, and also visibility. Visibility is something really nice that we can check, like the connectivity from like a container pod or a pod port to like to a database VM, and check the communication between them. If you have like a firewall rule that's blocking the communication, or if the communication is working fine. So to start, we're going to create a namespace. The namespace will be created as cub control, create namespace vBrownBag. This namespace will be created, and also the source net role. So here we're gonna create the cub create namespace vBrownBag, and here you can check the namespace was created, and also the, let me just zoom here a little bit, and also the logical suite that will host the containers to that namespace. So the next step is to create an application. So our application will be called vBrownBag Application Controller. We have here two sets of replication controller. One is the web, and the other one is the app. So when you create that, we will create two pods of each one of the replica sets, the replication controllers. Here we're going to apply the configuration, and we're going to check here the container creation. After a few seconds, everything is created, and you can check here that they are also connected to my segment. We can check here all the four pods connected to that network, and everything looks fine till now. The next step is to create a service and an ingress. So the service will group like the similar pods in the same group, like in the same service. The same service will be shared for like the similar pods, and you're gonna do that using labels. And also we're gonna, in this case, we're gonna have a service called web and another one called app. And also we're gonna create an ingress rule to load balance the external traffic to either web or app based in the URI. So everything that's /web will be load balanced to the web service, and everything that's /app will be balanced to the app service. And also we have here our VIP that's will be the external IP for that application. So here we're gonna take a look in our service YAML file. So we can check here that we have two services, the web and the app. And based in the labels, we're gonna do the load balance. So here, apply the configuration for service. You can check the service, and now the ingress. So we're going to take a look in the ingress configuration, and here we can see that we have /web to the vBrownBag web and /app to vBrownBag app. I'm going to apply this configuration to our namespace vBrownBag, kubectl get ingress, and here you can see that our URL vBrownBag.demo.corp.local is running. Here we can check the rules that match our regex for load balance. Here's the /app, and here you can take a look in the /web. Also the rewrite rule to /, and we can check if it's successful working, accessing our URL. I'm using here a private certificate, and everything's working fine for web. Now let's take a look on app, and everything looks fine also. The next and last step for this demo is the microsegmentation. So based in the labels, we're gonna provide the security for the environment. So we're gonna take a look in our configuration file, in the replication controller YAML file, and then we can see that all the labels have also been applied to the pods. And here, based on those labels, our distributed file will reinforce the security posture that will block the communication between web and app. We're gonna take a look in the replication controller configuration YAML file, and you can check here that we have two labels, vBrownBag Web and vBrownBag App. Now we're gonna check where those pods are running. So we're gonna SSH to Kubernetes worker 1, and now take a look on the pods running there. And we're gonna enter in the second pod, and to do that, we're gonna start bash inside that container, and once inside that container, we're gonna start to try to communicate with other pods in the same network. So I'll start the communication with like a web container, then to the same web container, and then to app. And I can see here that the communication from web to app is working. Then I'm gonna create another group called vBrownBag Web, and this group will use labels, tags, as will be tag based. So it automatically discovers what was created in Kubernetes. So here I have the web, vBrownBag. This will be our source, and our destiny will be the vBrownBag app. We also create a dynamic rule to include everything, all pods that has the tag app in the scope vBrownBag. Once configured that, we will set the reject and publish this rule. Now I'm gonna do the same test, and you can check that the communication between web and app doesn't work, while the web to app is still working. So this concludes this presentation. Thank you very much for watching, and see you next time.
Thank you for taking the time to look at to view my vBrownBag session that I'm going to record. It's how to use vRealize operations as you're monitoring single pane of glass. I work for Select Medical, and we're located in Mechanicsburg, Pennsylvania. I am a vExpert for 2020, and If you look at my slide deck there, I do have my Twitter handle and also the address to my blog if you would want to reach out to me after you view this. A little bit of my background. I've been using the ESXi for quite a few years, vRealize operations, for over 6 years. Create a lot of custom dashboards, reports, alerting. Been using the True Visibility Suite. Also do a lot with vRealize automation. So I'm going to show some demos, that whole single pane of glass, how you can integrate the two together. And just real quick with the V community, I've been involved since like 2013. Started by just going to some local V mugs, and then I thought I wanted to give back a little bit. So I've done some presentations at some HVC events. I've done a power block and also talked to some little hacks. And if you haven't gone to a little hack, those are really good. You should try to get involved locally if you can. So to use VRops as your single pane of glass, there's a lot of really good built-in stuff right out of the box. Some really good dashboards, alerting, and reports. And then once you become more familiar with it, start creating your own dashboards and your alerts and start looking at super metrics. And then you can use it for troubleshooting, right sizing. If app teams ever come to you and say, I need more CPU and memory, there's some really great dashboards to get the proper size of your VMs. Or to even show costs to your managers. If somebody says, hey, I want to move this to the cloud, there's some really good dashboards on showing the cost on-prem versus the cloud. So that's, I keep saying that single pane of glass. I mean, there's so many uses with VRops. And then to start extending VRops, instead of just using everything that's built right out of the box, they have what they call management packs. So if you go out to marketplace.vmware.com, there's some that you can get, and that'll start expanding the capabilities of VRops. Some examples are some of the storage companies like HP or EMC have some management packs. So not only can you monitor, your hosts and your VMs, but now you can start getting a lot deeper into your SAN environment. So that's, that single pane of glass. And what really made me think about the topic of my presentation is when I started looking at the text display widget. You can actually, with that widget, you can link to internal URLs, external URLs, website widgets. You could show weather maps if you have a lot of SaaS applications. A lot of them have like a status website of how well they're doing, and you can link to that. And what you can't do with it is you can't alert off of any of that data. It's really display only. But my use case was to create VRops to be that single pane of glass for our environment and just to show data from many different sources. Here's some examples. I said I do a lot with VRA also, which is vRealize automation. Is I create some websites that I link to with VRops.